Welcome to Module 1. This is an introduction to computing fundamentals, the absolutely fundamentals that you need to know for the Tech Plus exam, if you're taking that, but also just for understanding computers in general. This module is going to cover the domain 1.0 of the Tech Plus exam objective, which is 13% of that exam. So if you're like me, you're probably wondering, what is a computer? Well, let me tell you something. When the first time I saw a computer, let me get out of this full screen, it was something like this, right? I told this story in another place. From Africa, got here in 2008, and 2009, 10-ish, my dad bought us a computer, something that looks absolutely just like this. Now, the primary thing we used the computer for was obviously going to YouTube, watching videos and movies and things like that. And my mom had me kind of recording things into DVDs. So if she finds a movie that she likes from the internet, she's like, "Can you record that so we can put that on the TV?" So I started learning how to basically record things from YouTube's and these other online websites. Anyway, long story short, one of these days the DVD drive dies. Yeah, that thing that's looking at right there, that's what we call a DVD drive. So that thing dies. And it wasn't injecting, getting out. I couldn't really do anything with it. So I go to Walmart, I buy me another one, and then I come back and try to replace this DVD drive. And that's really what changed my perspective on computers. So the first time I opened a computer was literally just to replace the DVD drive. And I, took out the screws and using a knife, that was like a habit of mine, right? I just, take things apart. But this time it was a computer, something that I knew for sure, wasn't just a regular toy to play with. Anyway, I took the computer apart, took the case off, and the things that I found inside the computer literally fascinated me, right? I find hardware, that were not connected, find what we call motherboards, find what we call a CPU, central processing unit, find what we call a RAM, random access memory, and all the other things at the time, by the way, I didn't know what they were, but I find all of them inside and I was like, okay, well, I've been using this thing for a few months. Now, is this the thing that does everything so is this just the hardware that's inside of this thing? So my fascination with computers has started that way. So from that moment on, I started learning and learning and learning. Now, this module number 1, we're going to take a look at the computer, not just the computer, but what happens, right? The absolutely core knowledge that you need to know when you are learning about computers. So here is the learning module. So first thing we will talk about is the input. Input are for example, the hardware that we use to put things into the computer. But once things are in the computer, they need to be processed. Remember, the central processing unit, the processor. So we will talk about that too. Then talk about the output. See, once the things are inside of the computer, you don't want them to stay there. You want to be able to see what the computer is doing, and that's where the output comes in. So you got things like monitors and so on and so forth that help you be kind of to see the things that your computer is doing. Then the storage. In these days, we take photos, we take videos, we do all kinds of things. They have to be stored somewhere, and that's where storage comes in. Then we'll take a look at the binary. This is the language the computer understands, the 0 and 1s, the language of a computer. Then from there, we'll take a look at hexadecimal. Hexadecimal is used in a lot of places. For example, MAC addresses, your media access control. It's presented using hexadecimal. And there's a lot of other things that uses hexadecimal, including IP version 6, IPv6. So IPv6 is presented as hexadecimal. So it's really important to learn what hexadecimal is. Then from there, we'll take a look at decimal. Decimal, it's something that you and I use every day without really knowing what we're doing. Because since we were kids, we have been told to use decimals. Decimals are just numbers from 0 all the way to 9. But once we get to 9, we run out of number. Therefore, we borrow 1, then we put a 0, right? Once we get to 19, we run out of number again. Then we borrow 2, then we start at 0 again. So that's the counting system that we humans use day in and day out without really knowing, because, our brains have been, wired to just do these things automatically. Then we finalize this by look at the Octal. Octal, it's a little bit old. It's still used in Linux systems. So I'll probably show you that as well in Linux, but it's really not being used. It's not used as often anymore. Then from there, we'll take a look at the unit of measures, right? When you're counting how fast something is, how are you going to measure that? So that's measured in throughput, for example, networking. So whenever you're getting, let's say 5 gigahertz, let's start with the processor, right? Not networking, processor. Well, how fast is the processor? You can say 5 gigahertz throughput. That's what I am getting. Well, that measure. What about network? Well, network can say, oh, I'm getting 5 megabytes per second. I'm getting 100 megabytes per second, 1,000 gigabytes, probably 1 gig, which is like a 1,000 megabyte per second, and so on and so forth. So we'll talk about that, but like I said, as well as processing speed. Then we'll finalize this module by taking a look at the troubleshooting. There are a couple steps, 6 to 7 steps, troubleshooting methodology that CompTIA wants you to know when you're facing any IT problem. And this is the section where we will introduce all that to you. Let's get to it. Starting with input and processing and output and storage. Well, input, this is the data or instructions that's being entered into the computer. You're like, I think I understand what that means. Exactly. When you are using a keyboard and then you are typing keys, like keystrokes, you're pressing your keystrokes, and then like writing a letter using like a Microsoft Word. Well, you are inputting keywords, keys into the computer using a keyboard. So a keyboard is one of example of an input device. It's used to put things into the computer. A mouse is another example of a hardware that is used to put things into the computer. Touch screens when using like a smartphones, and the microphones, the one that I'm using to record this course right now, scanners, and so on and so forth. So all of these things are designed to kind of put things. These are the like input devices. They're designed to put things into the computer. Well, once those things are put into the computer, they have to be processed. That's where the processing comes in. This is the manipulation of data according to the instructions. Depending on what you're doing, the processor does the calculations. And processing is done by a CPU. A CPU, it's something that we call a central processing unit. I want you to think of this as the brain of the computer, right? So think of the input as the eyes. The eyes, they see things and they let your brain know, or they let you know, hey, this is what I'm looking at it right now. Well, the processing will be the CPU, will be the brain, right? In a case of a human. So it does follow the instructions, and those instructions mostly they're coming from some kind of a program, like a software, something like an operating system, OS, right? Or a regular application, something like a Microsoft Word, right? That's something that will also give instructions to the CPU, to the processing unit. Once that instructions have been processed, we have to see it. That's where the output comes in. These are the results of processing displayed or transmitted. In another word, this is where we get to see what we're doing. So basically, this happens so fast that you can't really tell the difference. When you press a key on the keyboard, poof, automatically you see that on your monitor. Well, but literally what just took place, there was an input processing that took place, and then obviously the output now that you are able to see that on the monitor. So monitor, it's not the only output device we have. We also have a printers, right? You can print things from your computer to piece of papers, right? Printers help us with those kind of things. Speakers, if you are listening to music, right? Projector, if you're maybe teaching, or maybe you're watching a movie and the movie is being projected on the screen for you, and so on and so forth. So these are going to go in and kind of convert those digital signals back to a human readable form. Again, with the help of the SAM software that you use to input those things inside and so on and so forth. So last but not least, it's the storage. everybody knows what this is. All right, this is the storage. This is used to retain the data, basically hold on to the data that you have in the computer. So right here, we have quite a few of those. For example, we have HDDs. HDDs, these are hard disk drive, HDDs, hard disk drive. These are a little bit old. They're not older as a floppy drive. For those who are old enough to remember floppy drive, but these are old. They've been around for a while, and they have a platters, so they have things that move around as data is being written inside of the HDDs. But these are hard disk drive. They're not that fast, right? To the things that have been replacing HDDs are SSDs. SSDs are solid state drives. Solid state drive. It's another form of a hard drive. Again, I will show you all these things that I'm talking about right now. I'll show you these. I'll actually, you know what? I will go there right away so I can show you all these things very quickly before we move on. But these are SSDs. SSDs are solid state drive. These are faster than HDDs. The reason is because they don't have any moving parts. So SSDs, they're like regular chip, or I will show you what a chip is. Then you have your USB drives. Absolutely. Some of you still remember these. These were very common a few years ago before cloud took over. But you also have a cloud storage like Google Drive, Microsoft OneDrive, so on and so forth. So these are used to store data, store your music, store your photos, store your files into the computer. But when it comes to storage, we also have non-volatile storage, but we also have a volatile storage. So your RAM, your random access memory, something that I'm going to talk about in more depth, it's used as a temporary storage, meaning it's volatile. Things get written and things get destroyed very quickly inside of a random access memory. So let's go to Google quickly so I can get to show you these. That way you have an idea of what we are talking about. So when you look at the computer, let me bring up one of the picture here. This right here is the computer, right? This is like a desktop computer, desktop because it sits on top of the desk. So that's that. You also have a mouse. Yeah, I know what that was. You also have the keyboard that you use to type things into the computer. You have the speakers. You also have the monitor. So you can say, okay, monitor, speakers are the output devices, right? And then you have a keyboard and your mouse as the input devices as well. So what else that I mentioned that you need to see? Well, we talked about CPU, Central Processing Unit. Let me show you how this looks like. Then we have quite a few companies that come up with these. And one is Intel. Intel is like the granddaddy of this kind of stuff. But this is a CPU. It looks like this, right? The way you attach this to the motherboard, I'll show you what a motherboard is. Actually, this is a pretty good example. This is like the older ones, the older versions. So it looks like this, then you just, you flip that just like that. Then you attach that onto the motherboard, and this thing, it does all the calculations for you. So this is the brain of the computer. And when you attach to it, it looks just like that. There's this little thing there that you push it down into its place so that it can lock in. There we go. It can lock in so it cannot move or go anywhere. All right, another thing that we talked about was solid state drive. But before I show you solid state drive, let me show you HDDs, hard disk drive. This is the hard disk drive, what you're looking at right now. Okay, I wish this was like in a physical setting room where you get to open a computer up and get to see what's inside and so on and so forth. But this is a solid state drive. These were the platters that I was talking about right there, that moving thing that looks like a DVD, right? It literally just looks like a DVD. But this is the thing that the data is written on top of, and this little guy right here, it's used to be able to write and read the things that's within the HDDs. So because the data is in pretty much everywhere, these are really not that fast. They're still used, but they're really not as fast as solid state drive. So solid state drive looks like what you're looking at right here. And It doesn't have any moving parts, no platters, nothing that's spin around. So it's just like a regular chip, really, which makes this really, really fast. And some of them are really, really small, really, really tiny. These are what they use in smartphones. These are what they use in all these IoT devices, or these well, devices that requires a lot of storage, but the storage that needs to be fast. So if you have like a laptop, tablet, smartphones, you probably are using a solid state drive now. So what are some of the roles that each component plays in the computing system? Well, you got the input devices. Like we said, the input devices, they're between the user and the computer. So the user used these input devices to put things into the computer. So they convert different forms of data into digital format. Absolutely. Like I said, if you're typing things on the keyboard, it's going into the computer. The software and the operating system does all kind of things to it. Then you have your output devices, right? Like we said, this is designed to show things to the user, right? Your monitors, your keyboard, not a keyboard, your monitors and your printers. All these things are designed to convert the computing data into a human readable form so that the human can be able to kind of see it. Because when it's being processed inside of the computer, well, it's just numbers. It's just ones and zeros. We'll talk about that. It's just binary. So the CPU is going in, is doing all the processing. The RAM, it's helping with the some of the calculations. We'll talk about the RAM in a bit. But you got to see it, right? The CPU can just be doing the work and then it doesn't give you any feedback. That's where the output device comes in to help you be able to get that feedback on the things that's being processed within the CPU. So the CPU is not the only thing that does the process. So the CPU is the brain that execute all the instructions, but we also have a few other things that does the processing, like the random access memory. I'll tell you a little bit about this very quickly here. Random access memory are used when you have things open on your computer. So for example, right now I have this PowerPoint open. Well, it opens in the RAM. So if I were to open up Microsoft Word right now and start typing things, well, as I am typing those things, it's open in the RAM. The reason is the RAM, the random access memory, it's very fast. So it talks to the CPU quicker than a hard drive. That's why when you are currently working on things, it will be stored in the RAM, in the random access memory. But those things are temporary. In other words, if I don't save my work as I'm typing things into the Microsoft Word, that's gone when the computer shuts down because the RAM, random access memory, it's temporary. It's temporary. It's not designed to kind of store things long term. If you want to store things long term, you save that into the hard drive. That's where the SSD comes in, and that's where the HDDs comes in. Then you have your GPU. Your GPU, this is a specialized for graphics. It's known as a graphics card, right? Graphics processing unit. I think that's what GPU stands for. Let me double check that for you. Yep, graphics processing unit. That's what that stands for. Well, this is a very specialized. It's loved. It's loved by gamers. People who play games, they love GPU. Why? Well, GPU is insanely faster, very fast compared to CPU and compared to other things. So usually the job of a GPU is to let you be able to see the things that's being processed by the CPU on the screen. For the most part, GPU are used between the computer and the screen, right? But we can make them very fast, and they do make these very, very fast, especially for the gamers when you are playing a game and you are shooting things where you want to see that on the screen in real time. That's where the GPU comes in. Very specialized most of the time for graphics as well. Then we mentioned about storage. Storage, like we said, there's volatile ones like a RAM. You also have your hard drive, and which is non-volatile, which means can store things in the long term. But we also mentioned the cloud. We also mentioned the older ones, things like a tape for archival. I work in cybersecurity. We do a lot of storing things. The cloud tended to be very expensive for us. So therefore, sometimes we put things in the tape. One of the company I used to work for, that's exactly what we did because we had to comply with HIPAA. And HIPAA was like, you got to save this for about 7 years. We're like, oh my God, 7 years? We can't keep that into the cloud because in the cloud, you pay every hour, every minute, right? So we had to put all that stuff in the tips. There are some tips that are like 2,000, terabyte of data. We'll talk about the terabytes and bytes and all the other stuff in a minute here, but that's another storage. And you might be like, okay, Francois, well, what are some of the real world examples of computer processing, right? When do I use this? Trust me, if you're watching this video, you are using this already, right? This is why I love IT. Well, a smartphone taking pictures, right? When you taking photo with a smartphone, there's a lot of things that's taking place. One, the input is the camera on the actual phone. Now, the processing is the CPU that's inside of the phone, obviously. Now, you might add filters and things to it, which is all done by the inside of the smartphone. And then the output is the image that gets displayed on that little screen of your smartphone. And the storage is the storage of your smartphone. I think you got the idea. Same thing apply when you're shopping online. The input will be the things that you enter. For example, let's go and you search for a product on Amazon.com. Well, that's the input. Well, the servers where the online website is housed, it's going to do all the processing, right? And then the output, it will be the confirmation on your screen telling you, here's the things that I was able to find. And the storage will be obviously the things that's within the server that's processing that order for you. This can be applied to automatic manufacturing, can apply on weather, you name it. There's this input output is happening all the time when you are using computing devices. And that takes me to storage units. All right, this is all about how we store things, starting from the smallest unit of them all, and that is a bit. A bit is it could be a 0 or a 1. It really depends on what is taking place. But this is the smallest unit of data. Okay. A 0 meaning there's nothing taking place. A 1 meaning there is data. So think about this as the power, right? The on and off switch, right? So your power is coming, that's a 1. There is no power, that's a 0. So a bit is the language of love. This is the language that a computer understands. It's a binary. Okay, we will talk about that in more depth later on. When you take these 8 bits, they turn into a byte. And these can present a single character. When you take 1,024 bytes, they are turned into a 1 kilobyte. Okay, now you're like, oh, wait a minute, Francois. What is this? Is 1,024. There's a little bit of math behind it. I'm not gonna get into it, but on marketing documents, they usually just say 1,000 kilobytes instead of saying like 1,024. But technically, in a technical documentation, you might see this presented as 1,024 kilobytes, 1,024 megabytes, 1,024 gigabytes. But in marketing documents, you might see this says like a 1,000 meg or a gigabyte or like 1,000 gig. It's the same thing, right? Technical documentation might introduce that like that. Again, there's a little bit math behind it that we're not going to get into it. But a 1,000 kilobyte equals to 1 megabyte. And 1,000 megabyte equals 1 gigabyte. And this is where things start getting into the things that you and I are familiar with. For example, with our internet speed, well, we might say that I am getting 100 megabytes per second, or 100 megabyte per second. It's kind of the same concept here that we're talking about. Okay, and in your storage, you might say I have 100 gig. Same thing, 100 GB, gigabytes. Okay, so on and so forth. So Again, 1,000 gigabytes is 1 terabyte, and 1,000 terabyte is 1 petabyte. We're not here yet, but we have gotten to number 6. We are in the terabytes. A lot of the storage, it's in a terabyte right now. Our Wi-Fi speed, internet speed is still in gigabytes, but the storage have gotten into a terabyte. And I like to believe that companies like Google, they probably have a petabytes storage devices in their data centers, right? But consumer products are still in a terabyte as well. Putting this into a real world, you're like, okay, where or when do we use this in the real world? Well, you use this every day. Well, in the text documents. Well, if you open Microsoft Word and start typing things, really creating like a text document, you are using a very small kind of a size of the storage. Once you save that, it doesn't really take that much. It's like in the megabytes, like a couple megabytes, and that's it. When you take a photo, for example, depends on the resolution of the photo. It might also take a couple kilobytes to megabytes and so on and so forth. Music is same thing, but when you start going into the high definition video, then that start getting into the gigabytes. Okay, so in the real world, we use storage all the time when we're storing things into the cloud, in smartphones, when we're playing games, and all of these things require storage, and those storage are presented into those things that we just finished discussing. Now, what about the speed? What about the throughputs? All right, throughputs unit are presented in some per seconds, right? So we can say bits per seconds, or kilobits per second, or megabits per second, and so on and so forth. So it's mostly commonly used when we're describing network speeds. For example, I can tell you in my computer right now, I am getting some hundreds megabytes per second. Actually, let me go to Google right now very quickly, and let's take a look at this. So if I open Google here and just do speed tests, okay, my Wi-Fi is a gig. That's like the internet that I pay for. But because I am on this old laptop that I am using right now, I am not getting all that speed, which we will talk about this because usually when it comes to computers, it's going to have to slow down to the thing based on the speed of that particular device. That's the same case with all the hardware that's within the computer. If there's like a hardware that's slower, well, every fastest hardware is going to slow down so that they can all kind of keep rolling on the same speed. Anyway, this is my speed, and it's presented in megabytes per second. As you can see, this is the speed that I am getting, my download speed, excuse me, and this is my upload speed as well. So going back here and get to the slide here, you can see that these are presented as bits per second, right? Kilobits per second, megabits per second, getting into the things that we commonly used. Gigabits per second. So like I said, right now I have 1 gig Wi-Fi or internet, although I am not getting the entire gig. But you also have a terabit per second, right? Now, putting these throughputs into a real world, you can see that back in the days, we're talking about in the 90s or probably 80s, when they have the dial-up modem. Well, the speed was very, very slow. This is doing the internet version 1.0, right? Pretty much. Where the web in 1991, when the web was invented, the web didn't even have images. There was no image. Part of the reason was because the image consumed a lot of bandwidth, and there was really no bandwidth to consume. So dial-up really was all text. That's what, web, one was all text, because that's a little bit easier to kind of come through instead of an image. Then it got into the broadband, then it got into fiber or Ethernet and fiber. The speeds are like a gig to a couple megabytes. Ethernets have different standards. When you get into the A plus, you get to and all that kind of stuff. But you also have Wi-Fi, Wi-Fi 5, Wi-Fi 6. You also have USBs, USB, 1, 2, 3, 4 now. and then you have 10 gigabytes Ethernet, or we call these by their categories. So we call it like a cat, which stands for category, Cat 5, Cat 6, Cat 6A, E, Cat 7, Cat 8, which I think is the most current right now, which goes up to 10 gigabytes per second. When it comes to fiber optic cables, well, this thing is extremely fast, depending on the kind of fiber that we're using. If we're using like a single mode fiber optic cable, it can go up to 100 gigabytes per second. Right? This is like, I say 100, like 400. Like literally, it can literally go up to 400 gigabytes per second. So this is the cable that they use as the backbone of the internet because it is insanely fast. What about processing speed? Well, processing speed are used for CPU, central processing unit. And like I said, this is the brain of the computer. The speed of a CPU is measured in hertz. A hertz is 1 cycle per second. When you have a 1 million of these, it's known as a megahertz. When you have 1 billion of these, it's known as a gigahertz, and so on and so forth. So there's the clock speed. This is the rate at which the CPU performs the operations. So you probably have seen like labels on your laptop, or if you've bought CPU, you probably have seen things like 2.0 gigahertz. They're talking about this. So basically, this CPU here can do 2 billion processing every second. CPUs are really, really fast. They're not as fast as GPU, but they are really fast. And part of the reason is because every processing that takes place in your computer has to go through the CPU. Remember, the CPU is the brain. Remember, as a human, you can't really function without a brain. Like everything we do, the brain have to send a signal to the body, including walking, including me talking, including the way I'm doing my hands right now, which you cannot see because I'm not on the video. But like, everything we do, the brain have to get a signal and send that signal to that part of the body. Same thing with the CPU. So no matter what you do, if you open a program, the CPU will do calculations. If you open 10 programs, the CPU will be doing the calculations for all those 10 programs at the same time. So again, CPU speeds are presented from 2 gigahertz all the way to 5 gigahertz. And this is all the speed, and usually it's measured in 1 billion speeds per second as far as processing goes. There's a few other things that you need to remember when it comes to CPU and the speed. And one of them is cores. You probably have seen this where they said, oh, this is a quad core, meaning like 4 CPUs. This is a I core and this and that. Well, these are numbers of processing units within the CPU. Keyword processing units. A core, if this is like a multi-core CPU, that means it's one CPU that is acting as 2 CPUs that can do like instructions double the speed of one CPU. In other words, more cores, it's better for multitasking. And the reason is because it's like having a multiple CPUs in one CPUs. That's really what this means. So instructions are done very quickly because you are having a multiple CPU do the actual work. A lot of the CPU we have right now, they have a lot of different cores, like a multi-core, quad-core, so on and so forth. And the reason is because we are using these computing devices nowadays to do additional things at the same time. Well, I can be shopping online and playing video games and having my computer downloading a program at the same time, downloading some that can be taking place at the same time. Therefore, the CPU has to be able to do all the instructions or calculate all that instructions at the same time. And another thing that the CPU have, it's known as a cache. And this is really good when it comes to working with the RAM, random access memory. So this is a high-speed memory that's closer to the CPU, meaning it's a way of the CPU basically caching instructions, if you will. When it's calculating it, well, these caches, which they're known as L1, L2, L3, which are like different levels of a cache. These are how the memory, the random access memory, will communicate with the CPU as the CPU is doing the calculations, and the RAM is kind of holding on to that application as the CPU is doing the calculations for that given applications. So the larger the cache, the faster the data that can be accessed. Okay. So you might be like, okay, I got it. But what are some of the practical applications, right, that we use these things on? Well, for storage, well, it really depends on what you do. If you do video editing, you might need a multiple terabyte of storage. If you just use computer just to document things, well, just a couple gigabytes would just be fine. If you're like an enterprise company that have a bunch of a data center, you probably are going to go with the petabytes. Okay. What about when you're buying like a system, for example? Well, a lot of software are going to have a system requirements. They're going to tell you, look, if you're going to buy me, these are the kind of requirements that you should have. For example, if we were to go to try to buy a software right now, let's go to Adobe Photoshop system requirement. Okay. We go here very quickly and get down here at the minimum or recommended system requirements. You can start seeing some of the things that we are talking about. By the way, this is the other stuff that really helped me get into cybersecurity and doing all IT in general. Because when I started working with computers, I developed a kind of an interest of recording videos where like record like using a camera. So I was walking around recording weddings. I started recording music videos. Yeah, I mean I have a YouTube channel where I've posted a lot of that stuff, but that really helped me kind of understand the computer parts because I used to do a lot of research, try to figure out like which one of these computer that would be the best for my video editing software. I was using Premiere Premiere Pro from Adobe. That was the tool that I was using. But I also used a lot of a Photoshop, designing covers and things like that. Anyway, back to the point. So you're going in, you're trying to buy Photoshop. Every software, majority of them, they're going to give you the system requirements. So for Photoshop, it's here telling you the processor have to be multi-core. Now, multi-core Intel or AMD processors. The operating system can be Windows 10 or Windows 11, or something better. Your RAM, your random access memory have to be 8 gigabytes of RAM. If you have 16, that's even better. And then scrolling down here, we can see graphics cards, right? It's going in, it's telling you have to be 1.5 gigahertz GPU as far as memory goes. Your monitor resolution, your video RAM, your hard disk space, your internet speeds, and you got the idea, right? So in the real world, a practicality, this is how we use this, right? So you go in, you're saying, okay, I'm looking to buy a video editing software. What kind of a software that can help me do that kind of stuff? You go and you say, I need internet speed, or I need to get me a new Wi-Fi. Well, you're going to go in and start looking at, okay, well, this Wi-Fi that I can buy from, let's say, Cisco. What is the speed on the Wi-Fi? Or can this thing do 1 gigabytes per second? And so on and so forth. As we move on, we get to decimal systems. When you look at the exam objective, specifically the 2.1.2, talks about identifying a notation or notational systems, excuse me. And that's where the decimals are. That's where the hexadecimal, the octal, the binaries, and things are. So let's start this conversation by talking about decimal. I won't spend too much time here because I believe you already know what this is. You're like, do I? Of course you do. Well, you and I have been kind of a trend since we were kids. Let me remove that. Since we were kids to count in decimals. And it usually goes, it's actually based on what we normally call a base 10 numbering system. And it usually goes on from a 0 all the way to 9. So it looks like this: 0, 1, 2, 3, 4, until we get to 9. Then once we get to 9, we run out of number. That's why this is known as a base 10. The reason why it's base 10 is because 0, it's also a number. So 1, 2, 3, 4, 5, 6, 7, 8, until we get to 9, which is kind of equals to exactly 10 numbers. Anyway, so once we get to 9, we ran out of number. Guess what we do? We go back from the beginning, we borrow the 1. We said, oh, okay, well, we don't have any numbers left. So then we said, okay, let's borrow 1. And the 0 carry over. And then we have the 10. Then we go, then there's 1, 1, that's 11. Then there's 1 with a 2, that's 12. And then there's 1 with a 3, that's 13, until we get to 19. Once we get to 19, we run out of number again. I remember it's base 10. So let's go back from the beginning. Then we borrow the 2. We say, now we have 2. And then we bring down the 0. Oh, yeah, now we have the 20, all right? Then we have the 2 again, and we keep the same number. We have the 2 again with 1, right? We have the 2 again with a 2. We have the 2 again with a 3. You're like, Francois, get out of here. Why are you confusing me with this stuff? Look, I got it. I absolutely understand. But we are so used to counting using the base 10 number system that we don't think about this at all. But this is very natural to humans. This is how we understand it. This is how we count things. This is how we count money. We don't think about this when we're using it because since we were kids, we were taught that this is how we count. You count from 1 to 10, and that's what it is. Okay. And that takes me to binary systems. Binary system is the language of love. This is the language that computer understands. This is the language that computer speaks. It is based on base 2. It's not based on base 10. Base 10 is for us, humans, you and I. Computer only speaks base 2, which is a 0 or a 1. It's as simple as that. But the same rules that apply when we are counting using a base 10 numbering system also apply here. But we'll get to that in a minute. But usually this numbering system is using only 0 and 1. So this is really important for computers, right? Especially, for example, when data is being transmitted as electricity, because data have to go through the wire. That wire uses electricity. So usually when data is going through, that means it's on. In other words, that means there's 1. And then when there is no data that's being transmitted, that means it's off. In other words, that means it's a 0. That's really how computers do its thing. So this is the core foundation of all digital computing. Like the kind of computers we have right now, they all speak binary. And right now, there's Google and Microsoft recently introduced what we call quantum computing, or quantum computers, which uses a qubit instead of a binary, meaning it's a completely different numbering system, So basically, these quantum computers are going to be using like a different system than all other computing devices use. But the computers that you and I currently use, they only speak binary, which is 1 and a 0. So each binary digit, it's a bit, like we said earlier, and it's the smallest. So when you count into binary, you are using the base 2. So you go from a 0 to a 1. And then once you get there, you run out of number. Then you said, okay, it's a 1 and a 0. Then you run out of number again. And then you say it's a 1, 1, a 0, and so on and so forth. So you can keep going and going and going indefinitely. But what if we try to convert this? What if we try to convert a decimal into binary? Let's say that we have a 75 here. 75. Now, let's say we're trying to convert, this is a decimal, this is a regular number you and I can understand. Let's say we try to convert that into a language of love, the language of the computers. Well, how do we do it? So the way we will do that, let's actually go ahead and do that quickly here. Let's start with the 0. Let's create our regular decimal number system. So 0, 1, 2, 3, 4, stay with me, 5, 6, 7, let me move this out of my way. 8, and we have a 9. All right, let's just say this is the base 10 numbering system as we just learned. So 75 is that 7, is that 5, that's that there. Okay. Well, when you are going in and trying to get this into the language of love, the language of the computer, or you have to do some conversion. And the way you do that, it's let's create another chart. Let me use a different color here. Quickly chart for the binary. So using the power of 2, we can say, okay, 0 to the power of 2, it's 1. 1 to the power of 2, it's 2. 2 to the power of 2, it's 4. 4 to the power of 2, it's 8. If you failed class in high school, don't worry. This is as mathematical as we will get. 8 to the power of 2, it's 16. And yes, I did memorize these numbers. 16 to the power of 2 is 32. Yeah, when you do this for a long time, you get to memorize this stuff. 32 to the power of 2 is 64. Basically, you're doubling these numbers. 64 to the power of 2, it's 128. There we go. And you can keep going on and on and on in the bottom. Let's stop here. Part of the reason is because we are looking for 75, and 75 is between here somewhere, right? It's between these numbers somewhere. Okay, so stay with me. Then we're going to use a different color here quickly. So imagine I want to convert this decimal number, 75, into binary. So how do I do that? How do I turn this into ones and zeros? Well, the way I would do that, it's by looking at this little chart that we just created here, this power of 2's chart here, the binary counting, then be like, how do I get 75? Well, I can take the 75. Let me write it out here, 75. Hopefully you can see that color a little bit better. I can say equals, we can say 75 is bigger than 64. So I'm going to turn on 64. I'm going to circle it or put a dot box around it so you know that this has been selected. So you can say, okay, it's a 64. All right, then we can say, okay, well, if it's 64 plus 32, is it bigger than 75? And the answer is yes. So we're definitely not going to choose that one. But it's a 64 plus 16. Is it bigger than 75? Actually, let me bring a calculator so I can be doing this very quickly instead of me speaking. So I'm going to bring in the calculator. If I can search the calculator. There we go. Bring this guy here. I'm going to put this on the side so we get to see it. All right, there we go, right here. So where were we? We're trying to get 65. So we're trying to get 75. So we can say 65 right there, plus 32, say 32 equals 97. It's bigger than 75, so we don't get to use 32. All right, let me delete that. So 64 plus 16, hopefully you're doing this with me, equals 80. 80 is bigger than 75, so we don't get to use 16 either. Then we can get 64. All right, again, we're trying to get to 75, and then we're converting to binary, and you'll see all that in a minute once we have this done. You can say 64 plus 8, plus 8 equals 72. Oh, that's smaller than 75. Okay, cool. Then we can circle 8. We can circle 8. Then we can say, okay, 64 plus 8 equals to 72. There we go, like that. Then we still need to get to 75. Remember that, right? 72 it's not equal to 75, but we are here on the 8 space. So 72 plus 4 equals to what? Let's do the math. You're like, I know what that is. Yes, you do. So plus 4, gonna go slowly here, equals to 76. 76 is bigger than 75. So 4 is not in there, right? Then we're gonna say back to 72 plus, again, it's that 72, that right there, plus 2 equals to 74. Yeah, that's smaller than 75. So 70, number 2, it's in there. There we go. Number 2, it's in there. Then we can plus 2 here, and then that's going to equals to 74. And then, I mean, you can imagine, then we have 1, so we can plus 1, And then we finally got our 75, our beloved 75. Okay, let me just circle that and circle 1 so that we can keep this going. So this is how we got to 75. So what does this have to do with binary, you might ask? You're like, Francois, I was right here patiently trying to understand what you were doing, but what does this have to do with binary? Let me grab a different color. So right now, since we have what we're looking for, here is how in binary it's going to look like. Well, because there's data in 64, because 64 was used, we can say that's a 1. It's literally that simple. We can say, oh, that's 1. 32, there was nothing taking place over there. That's a 0. 16, there was nothing taking place there. That's a 0. So 8, there we did use 8. So that's 1. 4, there was nothing there. That's a 0. 2, it was 1. And 1, there was 1. And then obviously there's a 0 here for 128. There's no, we didn't even mention 128 is because it's way bigger than 75. Okay. Look at that. This is how 75 in decimal, in the language that you and I love and understand it, this is how 75 will turn into binary. All right, this is how it will look like into binary. So if you got this, great. If you don't, really nobody does this manually, right? But I would encourage you to come up with these charts, kind of the binary chart, and play around with this. It's actually fun, right? Play around with it to try to convert some numbers into binary. For example, let me actually give you this as a homework. Try to convert 108. 108, how would you convert that? You will figure it out. Oh, let me give you a bigger number. Well, let's convert to 210. Something that is bigger. That will get you to use that guy as well, right? 210. You will start with that and then keep going until you figure out what that is in binary. So take a piece of paper and try that. And then put your answer in the chat. Yeah, put that answer in the chat. The comment section of this video. So in what systems or applications that uses a binary? Let me change the color back to red. I like red better. Anyway, so in what systems that uses this? What kind of applications that comes in mind when it comes to binary? Well, digital logic and or not, right? When you're doing these operations, there's a lot of ways you do this, right? You do and or this, and or that, especially when you're programming. Well, that's, binary. Binary can be used there. Memory addressing, right? Each memory location has a binary address. We have a fancy way of calling that. If you want to know more about that, let's get into the A+ class, which goes deeper into these things. You have a file storage when you're storing files in the computer. You are using binary. Basically, look, network communication, machine code, error. The computers that we have right now, they all use binary. 1 and a 0 is the language of love. That's the language the computer understands. And that gets me to hexadecimal numbering system. So hexadecimal numbering system, it's a base 16 numbering system. So we talked about base 2, we talked about base 10. Now we're talking about base 16. Okay, so this one's a little bit different because what happened is they took the base 10, which goes from 0 all the way to 9. And when they get to 9, they said, holy crap, we are running out of number. Therefore, they start using laters. You're like, wait a minute, Francois. Why did they use later? Why didn't they just use 11 and 12 and on and on and on and on? Well, this was just for convenience purposes and maybe, to confuse the crap out of some of us. Back to the point. So the digits looks like this. You got a 0 all the way to 9, just like how we have that in the decimals. And then when you get to 10, 10 becomes A, 11 becomes B, C becomes 12, D becomes 13, all the way until you get to F, which becomes 15. So it's a base 16 because 0 is a number. Remember that, right? 0, it's a number. So F equals 15. F does not equal to 16. The reason why this is a base 16 is because of 0, it's a number. That's why we call this a base 10, because like I said, 0, it's a number. So where do they use this, right? When you play with tools like Wireshark is going to present things in hexadecimal, absolutely. But IP version 6 it's written in hexadecimal. If I bring my CMD here quickly, I like to be showing you things. So let me go ahead and zoom in here. Let me say IP config /all, /all. Basically, show me the IP configuration and then give me everything. So I can see a few things here. Let me, make this a little bit bigger. Go scrolling down to the end, we can see the Wi-Fi. All right, let me actually just show you the Wi-Fi. So here, there's a few things I wanted to show you as they relate to Mr. Hex, the hexadecimal. The physical address. Physical address are your MAC address, MAC, the media access control. You will learn this. This is the unique number that gets assigned to every hardware once it's created by the manufacturer. So Dell creates a computer, they're going to give that computer MAC address. It's very unique for every computer, every smart device. Anything that connects to the internet must have a MAC address. Okay, back to the point. So this is also known as a physical address. Why? It's usually burned into the NIC card, the network interface card of that particular device. So for example, computers comes with these things known as a NIC, network interface card. These cards, they're the ones that where you will find this right here. And again, if that's confusing, please join things like A plus and A plus and a little bit of network plus or security plus. That's where we will talk about that in more depth. Anyway, so the number you're looking at here, it's 48 bits, and it's a hex. It's in hex. Well, why? Because you start seeing letters right there, D6, so on and so forth. Another number or another thing that uses hexadecimals, it's IP version 6. So if I go here, let me see if I can find the IPv6. It looks like I don't have one turned on into this machine. But if I scroll up a little bit here, there we go. I don't even have to scroll up. I can see IPv6 in one of these virtual thing that I have here. So IPv6 is what you're looking at here. This thing that's written like that. So you can see FE80, Collins, F9F1B, Collins, and so on and so forth. So this is IPv6. It's 128 bits as far as the long. So it's 128 bits, and it's usually a group of 8. It's a group of 8. Sometimes it's written like this to make it shorter, like with the double colons like that. But you take 8, you times that by 16, which will learn hex. It's a 16. Well, you get 128. Again, getting ahead of myself. You want to learn more about the IPv4, IPv6, join a networking class as well. Anyway, I just want to show you some of the places where we use hex. Back to this. So how would you do some conversion? So if somebody were to ask you, hey, I want to convert a hexadecimal, hex, to binary, how would you do that? Well, it's actually quite easy than you think, right? What you need to remember is that A equals to 10 and B equals to, and F equals to 15. So basically you will convert the hexadecimal into decimal, into the language that human can understand. And once you have that, everything else, it's really kind of straightforward. So let's kind of set up the diagram again, little chart that we used earlier. So you can say 1, 2, let's say 4, and let's say 8. All right, as you can see, doubling. You can keep going to 16 and so on and so forth. But let's stop with 8 because it's really easier. It's just that easy. So, and let's say that we have a number. Let's say we have a binary number that's known as let's do what? Let's do A9. Okay, like that's the number, right? That's the binary A9. So right now you can be like, okay, I got this. I know A equals to 10. That'll be bingo, right? A it does equals to 10. Then number 9 is number 9. Number 9 is number 9. Remember, hex goes from 0 to 9, and once it gets to 9, it goes to 10, similar to what we have in the decimals. I've said that enough already. So if we go back to this, we can start looking at this. We'd be like, okay, so how do we get 10? If A equals to 10, then how do we go? How do we get a 10? Well, we can say, oh, well, 8 is going to be on, all right? We got 8. 8 is going to equal to 1. Remember, binary, ones and zeros. Let me say 1, or a 0. There we go. So 8 equals to 1. Why? Because 8 is smaller than a 10. I'm trying to go a little bit faster now. 4, it's not in there. Why? Because if we take 8 plus 4 equals to 12. It's bigger than 10. So that's a 0. 2, it's on. The reason is you take 2, you plus 8 equals to 10. And then once we have what we're looking for, the rest is a 0. So in binary 10, it will equal to 1, 0, 1, 0. It will just look like that. What about the 9, you might ask? I guess you got the idea, right? If I just bring it down to 9 here and put the 9 right there. So 9 will equal to 8 again. There's 1 for 8. There's a 0 for 4, 0 for 2, and then there's 1 for 1. Why? 1 plus 8 equals to 9. So this one will equal to 1, 0, 0, 1. So in hex, in a binary, I should say, A9 will equal to 1, 0, 1, 0, 1, 0, 0, 1. This is what the computer understands. When you type in A9, this and that, computer have no idea what you're talking about. It only understands this right here. Okay, so let's do one more conversion, then I'll give you that little homework that I've been kind of, this is the second time, so that I gave you last time. So come up with the number. So you might say, okay, Francois, let's do a big one. Let's go back here. Let's grab FE80. Let's try that. All right, let's do FE80. I'm going to do FE80. There we go. And this is the number that we're going to convert into binary. So how do we do that? Well, we figure out what F is in the first place. Well, you're like, okay, I got that. F equals to 15. You'd be like, bingo, F equals to 15. I'm going to put that down here. I'm going to do 15 like that. And then how do we get to 15? We go back to that little chart here. So 15 equals 8 plus 4, which is 12. 12 plus 2, which is 14. 14 plus 1, which is 15. So it's basically everything turned on here. So it's going to be 1, 1, 1, 1. That's literally what 15 is. 1, 1, 1, 1. There we go. In binary. What about if we want to do E? I'm going to bring E here. There we go. E coming down. So you're like, okay, I got that. E equals to, where is E? E equals to 14. Bingo. So 14, let's probably say 14 here. You got the idea. I'm going to put that in parentheses there. So E equals to 14. And then, so how do we get that into binary? Back to that little chart again. So it's 8 plus 4, which is equals to 14. No, that equals to 12. Excuse me. 8 plus 4 equals to 12. So you have 1 for 8, 1 for 4. Then we have 1 for this, because 8 plus 4 equals 12. 12 plus 2 equals 14. Once we get what we're looking for, then we're done. So that's a 0 for 1. Then that will be equal to 1, 1, 1, 0. E in binary, it looks like that. Then you can do that for 8. I can do that for 8, which is 8 in binary. It looks like this. We got 1, the rest is 0. Then you got 0. 0 means pretty much everything is a 0. That like that. And then that's how it looks like. All right, let me give you a little homework. So for you, I want you to convert this. Let me bring back my CMD. I want you to convert, let me give you a harder one. And I'll give you the easy one. So the second one, 9F1B. So go ahead and convert. Let me put this in a different color. 9, put a 9 here, F1B. Gosh, I don't know why I'm writing 3. B. There we go. B. And put your answers. Oh, that looks like a Bitcoin. That's pretty good. I probably should be buying some more Bitcoins. All right, that's B. So convert this and put your answers in the comment section of this video. Okay, so like I mentioned, in what applications, what places do you find hex or hexadecimals? Like I said, things like Wireshark absolutely comes in mind. Wireshark, when you are going in, you're trying to kind of figure out what's going on within different network pockets. Well, it does show you things in hexadecimal. And I know one person. I don't know her personally, but she's retired now, and she used to work for the SANS Institute. She's the only human that I've heard of, I don't know her personally, that I've heard of that can convert hexadecimal into binary automatically, just like that. So she can be looking at it and tell you what something is. For example, she can look at this memory address right here, right, just like that, and then tell you what that exactly converts to into binary and in decimal as well. You and I, maybe you can do this, but I can't. I can't. I have to take the long process of converting this. Anyway, so we use hex in memory addresses. So your RAM. In your RAM, if you were to do forensic and try to figure out what's taking place in the RAM, well, you will find the numbers that looks like that, and that's presented in hex as well. In color codes, yeah, you've seen things like FF000, trying to present some kind of a color. That's all in hex. MAC addresses, I told you, MAC address, it's a unique number. This is a media access control. It's a unique number that gets assigned to every application, every computer by the manufacturer. So it's presented in hex. Assembly language, such as the ones that they use when they're programming applications. Well, they got things in hex. Debugging software, file signatures when you're signing files, all of that stuff is presented in hexadecimal. So it's really important. And last but not least, we have Octa system. The Octa system, it's base 8. It's base 8 numbering system that uses a digit from a 0 to 7. Now, this one, it's not commonly used anymore. Part of the reason is because, it was used back in the days, right? Used in the early computers. We're talking about the Unix machines. The Unix, the age of IBM, the Linux computing system still uses this, especially when it comes to permissions. I'll show you that in a minute. But this one was using the power of 8. I was using the power of 8. And let me actually show you this quickly. Let me bring up my Kali Linux here. There we go. Do I have that on? Yes, I do. Sign in. Then let me show you the file system of Kali Linux, which uses Octa. So if I go to the terminal here quickly, and then let me go ahead and zoom in so that you can be able to see this. Let's see ls-l, right? ls-l goes in and show me these right here. These are the read, write, execute, read, write, execute, read, write, execute. But so basically, these are the permissions that are assigned to a D. D is for directory. And it looks like all these are directories. I don't have any file. But if I had a file here, it would say something else. Anyway, these are the permissions. But how do you assign this? Well, you can assign a permission in Linux using Octal. That's why I brought you here. For example, let's create a file here. I can just create it here. Let's create a file. Let's call this file. Let me touch a file that's known as a CyberPros. There we go. If I ls here, we have a CyberPro file now. If I ls-l quickly, we have this CyberPro file that has these kind of permissions. So here's where Octal comes in, right? This system that they used to use back in the days that's still being used in Linux computers. Or I can say chmod, meaning change directory, or change module, I should say. I can say chmod 777, and I can just say do that on CyberPros. This right here is the file system. If I press enter and then do ls-l again, ls is list things, -l means list those things in a list format, which is what we're looking at here right now. If I go up a little bit here, so you get to see both of these, you probably can't. Maybe I can make it smaller. Let's see if I can. No, I can't. Okay, let's leave this alone. So go up a little bit here. I'll show you both of them quickly. Okay, see, these were the permissions. I had a read write, there was nothing here. Then I had a read write, there was nothing there. I had a read write, and there was just read, and there was nothing there. And if I scroll down here, when I say chmod, which is a change module, that's what that stands for. Change permissions. and then say 777, that means, hey, I want to turn on everything, right? I want to turn on everything. Like, okay, Franz, so I am way confused. How the heck did you get the 7? Well, this is where the Octa comes in. Well, in the Octa system, the way it works is like this. The read is 4, right? The write is 2, and the execute, that's what the X is 1. Is 1. Are you still with me? So remember, we say it's it's base 8. It's base 8. The Octa system is base 8 from 0 all the way to 7, and this is it right here. So you take 1, you plus 2, you plus 3 equals to 7. Right there equals to 7. So when the permission, let me see if I can go up a little bit quickly here. So when the permission was read write, this was an equivalent to 4 plus 2. That was a 6 right there. The R was a 6 right there. The RW, excuse me, because the R is 4, the write is it's 2. Okay. Then here it says read and write again. That was another 6. And right here it only says write, write. That was a 4. So technically, the first permission right here, it was that. You're like, I think I'm following. Well, we can change it back. We can use a chmod. Right now, if I use to chmod and then just say 664, it will change that back to what you're looking at it right here, right now. Okay. But I just want to kind of show you this, the practicality, kind of, try to be a little bit practical for you here. But you got the idea. Now, going back to our slides so we can be kind of finalizing things here. Let me get back here. Let's see. So going back to this, we just finished talking about Octal. We can take a look at what we have next. What we have next is practicality of these notation systems that we just finished talking about. Like I mentioned earlier, they use these in programming, networking with things like MAC addresses and IP addresses. I showed you what those were earlier. You can see some of these in encryption. Yeah, when you go in and you encrypt things, hashes uses these as well. If you don't know what these are, join the security plus class. You have things like web development that uses these on things like encoding and decoding things, right? You have system administration where you are assigning permissions similar to what I just did in Linux. That's the kind of a system administrative type of a stuff where you're giving people permissions and removing permissions and so on and so forth. So these are used everywhere. And I'm glad you're taking this class so you can learn the core things that the computer uses. Troubleshooting methodology. Well, it's not the question of if something is bad is going to happen. It's the question of when. Man-made stuff have issues. Things will happen. Systems will break down. So you need like a methodology. You need like a systematic approach into solving problems if they do come up. And computer problems, they come up all the time. Like I said, it's man-made, human-made, so it does come with the human issues, which is, problems. So they are, CompTIA went in and kind of put like 7 different things that you can do when you are troubleshooting issues. And they said, step 1, you got to identify the problem. Well, how do you do that? Well, you gather information. I'm going to just introduce this, and the rest of the slides, we will kind of talk about each one of these in more depth. But again, step 1, you identify the problem by gathering the information. So if the user reports that, hey, I'm having an issue, you go in there, you start asking open-ended question. You're like, okay, can you kind of show me what was happening? So you get them to explain exactly what the problem is. Then once you have some information, you're going to establish a theory of a probable cause. This is where you create a list of potential causes. This is where you come up with a hypothesis, right? You guessing. You're like, okay, well, yeah, I think based on what you taught me, this could be the symptoms, okay? Then 3, you got to test the theory. Because remember, it's a hypothesis. It's a guess. You don't know for sure what you're thinking is the problem. So you got to test that. This is where you're going in, you're investigating each potential cause systematically, where you're starting with something and that doesn't work. You try another thing and that doesn't work, right? That kind of stuff. Then once you finish testing your theory, you establish a plan of action. This is where you develop a solution to your strategy. Then from there, you implement the solution. Once you finish implementing the solution, you verify. I can tell you when I was working as a tech support, we will do things and we would, not verify. We're like, oh, it's done. Hope it's working, right? But you got to verify the functionality. So if the problem was the screen doesn't turn on, well, by the time you finish replacing the screen, make sure, verify, test it, and make sure the screen it does turn on. Finally, this is the thing that a lot of people don't like to do, but is the most important of them all, documenting the findings, right? We had a system where we were documenting everything, with the tech support. And the reason is we wanted the other technicians to know what we did. Just in case that computer have problems in the future, the new technician will know this computer is known to be having these kind of issues. Getting into the first phase of troubleshooting. Well, the first one is identifying the problem. Now, there are some key steps that you can take when you're identifying problems. One, gathering the data, the information from the user. Remember, the user who is using that computer, well, they're the ones who knows the problem better. So they can tell you specifically what was happening when the problem occurred. So you got to go in there and start asking them questions. So gather the information and document those symptoms. Depends on what they're telling you. You're going to kind of make note of it. Then you will determine when the problem started. That's when you ask the user, when did it happen? Then identify any recent changes. This is actually really, really important right here. Most of the time when I was doing this, we will, bang our head against the wall, trying to be like, oh, that's what the problem is. That's come to find out, it's just a simple change. Many times when they make a change to a system and then now there's a problem, well, that change is the problem. And when we were doing this, we had to just roll back. Oh, yeah, when things are not working the way we want them to work, we just roll back to when it was working okay. So some of the common information to collect, including error messages, the exactly text. So, for example, let's say that the computer had a blue screen of death. You're like, is that a thing? Yes, it is a thing, especially on a Windows machine. Let me actually show you that. A blue screen of death. You were using the computer, then all of a sudden there's a blue screen of death. There we go. Yep, right here. It's just like where it's like poof. All you see is this right here. This is the classic one, right? This right there. This is the new one with the Windows 11 and Windows 10. But this is the one that the OG are used to right here. Anyway, so the blue screen of death usually happens when there's a changes into the hardware, right? When it detects a change into the hardware, the computer, but this hardware has to be critical to the point where the operating system cannot run. Anyway, if the computer all of a sudden it does this, well, you're going to need this right here, this error code right there, because it's going to tell you specifically this is the thing that is taking place, that's happening with me. So when you're asking the user what happens, you have to get them to be specific, right? With the error message. Okay. So system specifications, software versions, the timing when it happened, the environmental factors, was it too hot? Well, that kind of stuff. Some of the questions that you can ask, including what exactly happens when the error occurred? What was happening? Can you reproduce? This is one of those classic questions that I personally used to ask. Get the user to do what they were doing when the error happened. Okay, what were you doing when you first noticed the issue? The reason is you are asking these open-ended questions so that you don't get the user to just say yes or no, right? You want them to go into details. So you can be like, did you see a blue screen of death? well, then they're gonna say, yeah, yes, it was blue everywhere, right? But no, ask them quick questions to get them to tell you a little bit more information. And then you have some tools that you can use to help you identify the problem. Things like Task Manager absolutely comes in mind. Event Viewer on Windows, because it keeps tracking everything that is happening on your Windows. This is Task Manager, and bring it up quickly here. There we go. This is Task Manager. Task Manager is a tool in your Windows that is used for troubleshooting purposes. When, for example, a computer gets stuck, not functioning, you can go to Task Manager, for example, this Microsoft Edge, and then you can end the task. I can right-click on it as well. This Windows 11, they try to be fancy. You can right-click on that, and I can end the task, meaning force shut down. But you can see the CPU, the performance of your CPU, the performance of your memory. This is your random access memory, the performance of your disk, your Ethernet, right? Your applications. You can see the apps that start on the startup. These are the apps that start up automatically. Again, I'm getting ahead of myself. If you are interested in a lot of that, get into the A+ class. The next step is establishing a theory of a probable cause. Theory of a probable cause. So how do you approach this? Well, you got to consider the most obvious causes first, and then you will apply the principle of the simplest explanation. So you're going in, you are looking at the past experience to see if this particular computer had the same issues in the past. That's why the documentation is important. If there's any kind of a documentation, you get to those first. Try to figure out, okay, what did the other technician did to solve this problem? What did they say about it? Then you will go in, you're narrowing down the possibilities. Now, after going in and trying to establish, you are establishing a theory here. Remember that. So you're grouping those symptoms, and you're considering the recent changes to the computer, right? And if the issue is a hardware failure, you will know. If it's like a software bug, you will know. If this is user error, if it is a configuration problem, you will know all that. So some of the theory that you can come up with, including what you're looking at here. For example, the system crashes when opening large files, suggesting memory issues. Absolutely. What's the solution? Let's upgrade the memory. Remember, everything that opens on a computer opens in a RAM, random access memory. So if you have like a 2 gigabytes of RAM, that's not enough for you to do a lot of a multitasking. If you have like a 10 things open at the same time, well, 2 gigabytes of RAM might not be able to handle that. So your theory will be like, okay, well, if they open the large files and the system is crashing, therefore we need to upgrade the RAM. So that will be your theory. Then what you're going to do is test the theory. So test the theory. You will start with the simple things first. You will test the obvious, right? Then document each test and see if what you are thinking is the solution is actually the solution. Okay. You will have to be patient with this, because you might say, okay, I thought this was the problem. Then it's not the problem. You like, oh, I thought this is the solution. Well, then it's not the solution, and so on and so forth. Okay. In a computer, you might boot the computer into a safe mode. Safe mode, it's a location in your Windows environment where even if your computer is not booting up, it will let you boot into a safe mode. It's temporary, right? Where you can be able to do some troubleshooting and things. And the idea here is for you to test that theory. You're going in and you are reproducing the problem. You're trying to figure out, okay, what exactly you're thinking, okay, what I'm thinking right now is exactly what the problem is. Okay. And then you're confirming things, or you're rejecting things. There is a process. Again, as you advance your career, you will learn this. There's like a process you go to. You're like, okay, let me try this. Oh, that didn't work. Then you go this way, or you go that way. Okay. Again, you have an idea, hypothesis, theories. Then you're testing them. And then you are going to establish a plan of action. This is what you're going to do to kind of fix the problem. So these are going to be clear steps to resolve the identified cause of the problem. So what you're going to do in this case, you might back up things. This is really important. You might kind of back up things. You might need approval. You might need to go to the depending on the company, obviously, but you might need to ask permission from leadership before you can actually do any of the stuff you're thinking to do. So some examples that of the thing that you can do is to replace a RAM module. Well, if that's the case, maybe you need approval. Maybe you need to buy the RAM. And rollback, recent driver that's causing the problem. I'll tell you a quickly story. Early on, when I was getting started in this industry, I had a quickly gig. This was a contract job to go to Walmart to upgrade their registers and their security system. So the security system was using this software, so it wasn't working because the software wasn't working. So I go there and I was a rookie. I was just, just with an associate degree, and I only had like A plus, I believe at the time, if A plus, not net plus at that time. Anyway, I go there, try to upgrade this system to the latest, and guess what? I ran into issues. I was there for a long time, like I am searching things, I'm Googling things, and nothing is working. The company I was working for, they had given us a PDF with the steps by steps. Mind you, I was a rookie, so I had no idea what I was doing. But I had a PDF that had like things that I need to type into the computer to get it going. But those things weren't enough because I ran into an issue, and now this issue is not part of the document. So guess what I did? I tried to figure it out on my own. It wasn't working. Guess what I did? I rolled back. I said, you know what? I stopped the upgrade, rolled back to what it was before, and then I come back the next day after pushing that to tier two because I was like tier one, and the company had a tier two, somebody else who knew more, another people who knew more than I did. So I pushed that there. They remote in, they tried to figure it out, and they told me what to do, and I got it up. I got it to work. So what you do when you're going in and try to establish that plan of action, those steps, and try to do things, you're going to do a risk assessment. You're going to evaluate the potential impact of your change, of the solution. You're going to consider the worst case scenarios, and then you're going to have a contingency plan. In other words, you're going to have like a backup plan. If this doesn't work, then what? In my case at Walmart, I had just to roll back. Then once you're done doing what you're doing, you're gonna write it down, those steps, all right, that you did so that you can help other technicians in the future. Once you got that, you will implement the solution. This is where you actually make the change. So best practice is to follow the established plan. Whatever the plan says, in my case, I had a PDF that had a steps by steps. Says you're gonna do this first, then do this, then do this. Okay. You're gonna have to make one change at a time. If you try to do multiple, you might break things, obviously. And you see how they keep saying document each action, documentation. This is very crucial in IT. Even the people who works in cybersecurity, which is what I specialize in, people who does penetration testing, they think, oh, we're just going to be hacking things. No, you're not. You are going to do some hacking, but a lot of your time is going to be in documenting what you did so that the company can improve. Because, they don't pay you just to hack them. They pay you to improve their security, to make their blue team better. I am getting off topic. So back to this. You are implementing a solution. You're going in, you are replacing those hardware if it was a hardware issues. You're updating the software if it was a software issues, and so on and so forth. And then you are going to establish a plan of action. This is what you're going to do to kind of fix the problem. So these are going to be clear steps to resolve the identified cause of the problem. So what you're going to do in this case, you might back up things. This is really important. You might kind of back up things. You might need approval. You might need to go to the, depending on the company, obviously, but you might need to ask permission from leadership before you can actually do any of the stuff you're thinking to do. So some examples that of the thing that you can do is to replace a RAM module. Well, if that's the case, maybe you need approval. Maybe you need to buy the RAM. And rollback, recent driver that's causing the problem. I'll tell you a quickly story. Early on, when I was getting started in this industry, I had a quickly gig. This was a contract job to go to Walmart to upgrade their registers and their security system. So the security system was using this software, so it wasn't working because the software wasn't working. So I go there and I was a rookie. I was just, just with an associate degree, and I only had like A plus, I believe at the time, if A plus, not net plus, at that time. Anyway, I go there, try to upgrade this system to the latest, and guess what? I ran into issues. I was there for a long time, like I am searching things, I'm Googling things, and nothing is working. The company I was working for, they had given us a PDF with the steps by steps. Mind you, I was a rookie, so I had no idea what I was doing. But I had a PDF that had like things that I need to type into the computer to get it going. But those things weren't enough because I ran into an issue, and now this issue is not part of the document. So guess what I did? I tried to figure it out on my own. It wasn't working. Guess what I did? I rolled back. I said, you know what? I stopped the upgrade, rolled back to what it was before, and then I come back the next day after pushing that to tier two because I was like tier one, and the company had a tier two, somebody else who knew more, another people who knew more than I did. So I pushed that there. They remote in, they tried to figure it out, and they told me what to do, and I got it up. I got it to work. So what you do when you go in and try to establish that plan of action, those steps, and try to do things, you're going to do a risk assessment. You're going to evaluate the potential impact of your change, of the solution. You're going to consider the worst case scenarios, and then you're going to have a contingency plan. In other words, you're going to have like a backup plan. If this doesn't work, then what? In my case at Walmart, I had just to roll back. Then once you're done doing what you're doing, you're going to write it down, those steps, all right, that you did so that you can help other technicians in the future. Once you got that, you will implement the solution. This is where you actually make the change. So best practice is to follow the established plan. Whatever the plan says, in my case, I had a PDF that had a steps by steps. Says you're going to do this first, then do this, then do this. Okay. You're going to have to make one change at a time. If you try to do multiple, you might break things, obviously. Then you see how they keep saying document each action, documentation. This is very crucial in IT. Even the people who works in cybersecurity, which is what I specialize in, people who does penetration testing, they think, oh, we're just going to be hacking things. No, you're not. You are going to do some hacking, but a lot of your time is going to be in a documenting of what you did, so that the company can improve. Because, they don't pay you just to hack them. They pay you to improve their security, to make their blue team better. I am getting off topic. So back to this. You are implementing a solution. You're going in, you are replacing those hardware. If it was a hardware issues, you're updating the software. If it was a software issues, and so on and so forth. Once you finish implementing the solution, you have to verify the functionality. Like I said, it's not done unless it's verified, right? You got to verify it. So verify the solution, making sure that what you implemented does actually work, did actually fix the problem. So test the specific functionality that was problematic, and verify that the solution, it didn't create new problems, because in some cases it can. Then check it related to systems and see how they're functioning and their dependencies, and monitor the system over time. Absolutely. This is where you show up to the user and be like, hey, have you experiencing this problem again? Like, nope. Since you did what you did, the computer is working okay. Again, you're verifying the functionality. Look, it's not done until it's verified. Last but not least, you're going in, you're documenting the findings, you're documenting the solutions. Again, throughout the whole process, you were documentation, you were documenting everything. Like I said, what we had like a system, like a help desk system, where you can document things, and those things were searchable. So if somebody's having the same issues with the same computer, well, all that was in a document I can search for that computer, and then it will give me all the documents of the things that have happened in the past. It's like a little history of that particular computer. This is very helpful, especially if you're like a brand new technician to that environment. This is very helpful. The documentation is important. If you end up going into, let's say, tech support or doing anything that's related to just regular IT, this is one of those best things that you can do, documentation. And if the company doesn't have a system that that you can use to document this automatically, create one. Right? Create one. We start off using a Microsoft Excel, and over time, we deploy a specialized tool that allowed us to document everything, assign a technician to it, and know who did what, then track our inventory. What are some of the best practices? Best practices when you're documenting. Be clear. Don't use any jargons. Right? IT people, we love this kind of stuff. You just write things into technical details. Don't do that. Just take screenshots. If there's something that you wanted to explain, take a screenshot and then just a few things saying, okay, this is what that means. Because remember, leadership or somebody else might be looking at that and they might not be technical. So keep that in mind as well. Hello and welcome back to domain number 2. Domain 2 of the Tech Plus. Tech Plus. Hopefully you will take the exam. Now that's the whole purpose. But in this module, you're going to understand the hardware and a lot of other devices. This is the core fundamental. So we'll talk about what is a computer, what is a mobile devices, what is a cell phone, some of the things that you already use. But we will take that one step further. We will talk about what's inside these hardware, these computing hardware devices. So in module number 1, we mentioned things like CPU, RAM, and hard drives and things like that. But what do they actually do? So we will talk about that in more depth and talk about the motherboard, hence the name mother, right? This is the component that's within the computers. And this component is the mom of everything. It brings everything together. So we'll talk about that. This is going to cover some of the domain 2, not all of the domain 2. I should kind of specify that because domain 2 is a little bit big. It's 24% of that exam objective. So things like cloud computing, which is all part of the domain 2, we won't be talking about that, but we will talk about a lot of things as well. So here's the learning objective. So the first thing we want to talk about is identify and describe computing devices and their components. So basically, you're just going to learn how to recognize a computing device, meaning a hardware, meaning a laptop, desktop, cell phones, and some of the IoTs, right? Internet of Things. You're like, what is that? Well, this is Internet of Things. If you were to ask my mentor, he would tell you this is an Internet of crap because he don't believe that everything should be smart. But IoTs, these are hardware that are supposed to be smart. Think about your thermostat. Yeah, those are becoming smart. Think about your lights. Think about your refrigerator. Think about your microwave. Basically, IoTs, it's all the hardware, that were normally not connected to the internet, but they're now trying to connect them to the internet. Right? Hence why my mentor always called this Internet of Crap. I think one day I asked him, I'm like, why do you do that? And he asked me, hey, Francois, why do you think that my microwave should be smart? And I say, for convenience? He says, no. He says, it's all marketing. I think he's on the other side. We are in cybersecurity, so we're always on the other side. There's a lot of issues when you have IoT things going, and taking place. But, to that conversation, he says it's for marketing purposes, right? I don't need my refrigerator to remind me that my food is about to expire. I had to pause. I'm like, you know what? You're right. You're right. But anyway, that's IoTs. We'll talk about some of the hardware that's within Internet of Things. Then we'll compare and contrast a lot of these peripheral devices. These are kind of different devices. We'll talk about their form factors. and the kind of things that we will connect to computer, right? Again, some of them we touched up on them a little bit, mouse, keyboards, and things like that. Then we will explain the connection types. So as you're connecting your keyboard, what are you using to connect the keyboard? You're like, okay, I use a USB. Absolutely. Well, you're like, no, I don't use USBs. I use Wi-Fi. Oh, I don't use Wi-Fi. I use Bluetooth. We'll talk about all those in that section. Then here we'll talk about configuring basic devices settings. This is going back to the core software of your hardware, like the software that tells your hardware what to do. And that is known as a firmware. Firmware. You're like, what the heck is that? Well, a firmware, it's a software that controls the hardware. It basically tells the hardware what to do. Basically, we have three types of a software. Let me actually go ahead and mention them right here, right now. And if you want to learn more, then get into the A+, the second part of A+. That's where we talk about software in more depth. But we have three different types of software. You have a firmware, which is, like I said, the software that controls the hardware. Then you have the OS. The OS, this is the operating system, things like Windows, right? Linux, Mac OS, all Android for the mobile devices. All of these are software that basically allows you to interact, allows the user to interact with the hardware. And then you also have apps, applications, right? When you are interacting using your software, I mean, using your operating system, you're interacting with your computer. Well, what do you use? Maybe you use Edge for browsing the web. Maybe you use Google Chrome. Maybe you use Microsoft Word. Those are apps. These are specific software, specific applications that are designed to do a specific thing. So a firmware is what we're going to discuss here, and that's going to be your BIOS and the UEFI. UEFI is a UEFI. BIOS is the input, a basic input and output system. That's what the BIOS stands for. And it's old. It's been around for a very, very long time. And in the last about 15 years or so, we've seen UEFI coming in and trying to replace the BIOS. Now, UEFI is basically the newer version of the BIOS. Whew, I am getting ahead of myself. So let's get to it. First thing we're going to talk about is desktop computers. You're like, Francois, I know what that is, and I'm sure nobody uses desktop anymore. And I'll be like, you're wrong, right? There are some people that uses desktop. For example, imagine the people who does CAD, people who design like architecture stuff. All right, they're architecting things. They're using those CAD software. Well, let's say CAD. But it's CAD. I don't even remember what that stands for. Anyway, maybe you can put that in the chat. But right, the people who are architecting houses and things, they use desktop. People who do video editing, right? Most of them use desktop. People who play games, like video, gamers, most of them, you will find them on desktop computers. So what is this desktop? Well, it's a computer that sits on the desk. Literally, it's on the top of the desk. So you probably have seen this. Let's go to Google. I'm going to talk about all of these from Google so that you get to see this. Desktop computer. Let's go to image here. Not shopping. No, I'm not trying to buy anything. Let's go to image so we can get to see this. I'm going to go with this one. That guy right there. There we go. That looks pretty okay. This is a HP. And let me see if I can show just the image so we get out of all those distractions. Okay, this is a desktop computer, this thing that you're looking at here. Now, I kind of like the design. It looks like one of those newer designs that these manufacturers have been coming up with. But you have a desktop computer. It's on the desk, and most people will use it. So you got USB connectors here. We'll talk about USBs and Thunderbolt and some of the other connectors, but you have them here. You also still have the DVD drive. A lot of the desktop computers still have DVD drive. Laptops, however, they don't have DVD drive anymore. I really haven't seen any laptop with a DVD drive. Anyway, but on the back of this desktop machine, you also have other places where you can connect things. So you have your monitor, and on the back of the monitor, there's some connections, and you hook that up on the back of the computer itself, and then off you go. So this is a desktop. Usually desktops are faster. Let me see, back of a desktop computer. Let's take a look at the back of this thing. So usually they tend to be faster compared to laptops. Yeah, they tend to kind of perform a little bit faster. So let me just go ahead and zoom this one in. I'll put this on the other side and we'll take a look at this one. So right here, you have quite a few things. You have the power. This is where you plug in your power supply. This is the power supply right here with the little fan and things. This is what kind of converts the DC to AC power from the wall outlet. So basically converts the power from what you get from your power company to the power that the computer uses. Usually what you get, it's a lot of a voltage. So this thing kind of converts that down a little bit. The reason I mentioned that is because it might pop up on that exam as well, if you're taking the exam. So you have, this is where you connect your power. Then you have this power supply here that kind of converts the power, as I was mentioning. If we scroll down a little bit here, we have the old PS2 connector. These, yeah, you're like, I've never seen those on the computer, right? These are very old, right? They used to be like they used to use these in the old computers, and these were used to connect your mouse and the keyboard. These connector, we call those PS2 connectors. Then you have your HDMI connection port right there. You also have your VGA connector right there. There's also a DVI. There's another connector DVI. These are old, by the way, so some people might not really even, kind of. Most of the newer computers would probably not use this, but I saw the exam calling some of these out, so it's really kind of important for us to mention them. Then you have your SATA kind of a connector, right? This is pretty fast. And these are the connectors that you find inside of the computer, usually on the motherboard. So pretty fast. Then you have your USB. You have your RJ45. We'll talk about this for your Ethernet. No, this is the RJ45 right there, not that guy. This is the RJ45, additional USBs. And you also have your audio ports. This right here, it looks like it's an older computer, right? There you go. This is the DVI, and this is the VGA. Some computers might have two, some computers might only, have one as well. And if they have one, it's usually this guy right here, okay, the VGA. Older computers, new computers, they don't have this kind of stuff. But again, these are kind of desktop machines, right? They sit on top of the desk, and usually some of them are bigger than you want them to be, but they do have some form factor. Right, form factor is basically how high the design of the whole thing. So you got the tower that sits on top of the disk. You also have the all-in-one. You also have the small factor, which are like a little bit smaller, and then you also have those desktops that's a little bit of horizontal as well. What is the advantage of the desktops? It's better when it comes to cooling. Some of them are really quiet, especially the Apple ones. They're kind of quiet. It does have more of expansion slots, like you saw on the back of that computer. There's like a room to grow. You can hook up a lot of other things. It's easier to upgrade, absolutely. When you open the computer and get to see what's inside of the desktop, you get to see a lot of things that's in there, so you can really upgrade that. And it generally more powerful to the price. Like I mentioned, they tend to be very fast as well. Where do you find these? Well, in office, gaming, content creation workstations. You got home computers. People are still using these, and the CAD that I was mentioning earlier. And that takes me to laptops and mobile devices. Well, laptops, everybody knows what this is. This is a portable computer. Right? It's just like a desktop, but that is portable. It's usually integrated with things like display. because with a desktop computer, you must have an external, you must buy external monitor. Well, with the laptop, that thing is integrated into it. The keyboard is also attached, but also the pointer, right? The little mouse that you move around. It's usually battery power, which means you can unplug it from the power connector and then basically go anywhere. It's portable, right? Usually, a lot of people are using these as a way of replacing these desktops, but like I said, desktops are not going anywhere anytime soon. They're still here, although they're not as common as they used to be. The form factor, you have the traditional ones, but you also have the two-in-one. Most of these are like a tablets. You probably have seen things like the Surface and Surface Pro. That it's a tablet, but you can hook a keyboard on it. You can use it, it can do all kinds of stuff to it. Some of these are detachable, and you also have these Ultra Book that you get from places like Google. Google have a lot of those. And you also have some gaming laptops. The laptop that I'm using right now, it's a gaming laptop. Why that I use it is for performance purposes. But also I do a lot of virtualization, meaning, creating computers inside other computers. So a really high performing laptop, it's a must. The brand that I use is called MSI. Huge fan of MSI. Right, there are gaming machines, they're a beast. Like for example, the laptop I'm on right now, I've had this for like 6 years now, and it's still kicking. Still kicking. All right. Then you have your tablets and smartphones, and these are touch screens, right? They're very portable, easier than laptops. You have some apps installed in them. They have a very limited input and output ports, and they often use the mobile operating system as well. So let me go back to Google. Let me show you a few of these, which I believe you guys are familiar with these already. So let's start with Apple iPhone. There we go. No, not news, not news, not shopping. I just want to go to image. There we go. These are the iPhones. You're like, yeah, everybody know what this is. Yeah, pretty much. But it's very limited to the kind of ports that you have. Other than the power port, everything else, it's pretty much gone. And then you have your iPad, right? Similar to the iPhones, you got the camera on the back, you got the front camera. You also have the screen, which is touch screen. They allow you to input things into the laptop, the tablet itself. So this is the iPad, right? Pretty good. You also have, let's see what else did we have here that I want to show you. Smartphones, you got tablets, you got the idea. Okay, let's keep going. The other ones we have are servers and enterprise systems, right? We also have these. These are really power hungry. Servers. Servers are computing devices that are designed to serve, right? They usually are very reliable, and they can stay up for a very long time. Meaning, once you power this thing on, you really don't want to shut it down, all right, for a very long time. I used, to, work with these. In one of my previous job, we had like a little data center. I want to call this a mini data center, where we have, a couple of servers running web traffic, another one running Active Directory, and a few other things. We didn't want to shut those things down. We didn't want to shut them down. So the RAM, random access memory, that you find in these servers are error correcting memory, ECC memories. They tend to be expensive. ECC memories are expensive. The reason is because they're correcting errors. Now, they're going in as the server is going in and processing things. They're correcting the errors that they're encountering as well. Most of the time, servers, you find them inside of a data center. So as far as managing these, you can kind of remote in. There's a RDP, remote desktop protocol. It's one of the things that you can use to remote into these servers if there are window-based servers. You can also remote into them using SSH. secure socket layer. No. SSL, that's the secure socket layer. Sorry, this is different. This is a secure shell. Secure shell. It's port 22. This is used to secure the web. Completely different. I always confuse these two. That's why, I had to take a minute. I'm like, am I teaching the right things here? Right? This is SSH, secure shell. It's also used to remote into things for administrative purposes. SSH and RDP, they're both extremely, extremely secure. We'll talk about that in more depth. But these servers, they also have form factors. But before I continue, let's go back to Google and I can show you a few servers from Dell. Dell servers. Dell had a company known as EMC. They combined, they like merged together, and they've been really coming out with a bunch of a pretty good servers. So a server is something that looks like this, just like a regular machine, but this thing is robust. Robust. There is a lot of storage in this. There's a lot of processing power in this. So these are the ones that you'll find in a data center. You're like, Francois, you've said a data center about 5 times. I have no idea what that is. Hold on a minute. A data center. It's just a building, huge building where you will find a bunch of hardware inside. Inside. So something like this. So the regular building, let me bring in, this is a pretty good image. Something like that. Oh, horrible quality. Horrible quality. Let me see. That's too fancy. All right, hopefully this, yeah, that's a regular scratch. Well, you got the idea. I'm sure you got the idea. Just me here being picky. All right, let's see that. There we go. So something like this, a data center, and you can see on top of it, there's like a bunch of cooling things, a bunch of power, batteries, and things like that. The reason is there's inside of a data center, you don't want things to shut down. You don't want anything to shut down because the entire internet runs on a data centers. So if this shuts down, for example, could mean Facebook is down. Literally, because everything we access is stored in some kind of a data center somewhere. That's the internet. The internet is basically servers, and clients. So servers are the hardware that serve stuff, like the servers that I'm talking about right now. Web server, it's a server that serves web traffic. Email server, it's a server that serves email traffic. Streaming server, it's like Netflix, a server that, help you stream music and things like that. Clients is me and you, right? These are the cell phones we use, the laptops we use. We will connect to something like Google Chrome and then get to the server, right? That way, resources. Now, if you are interested in how computers talk to each other or how this connection takes place, then you might be interested in Network Plus. Network Plus courses, which we have that course on the Cyber Pros training platform. Anyway, back to it. So this is a server or a data center. And inside the data center, you will find the things that we were looking at. So if I go back to that image that I had earlier, I could, even something like this will do, right? You got a bunch of hardware in here, like those Dell machines here. There are hooked up with wires, something like, RJ45 cables or fiber optic cables and things like that. And voila, voila. So servers do have form factors, right? You have the ones that can fit on the rack. You also have a tower servers. You also have a blade servers. You also have micro servers, right? They're, kind of a pretty good on, saving you some space. But what do they do? What are some of the function of a server? Like I mentioned, you have a web server that serves us web content, database servers, file servers, applications, email, authentication, and virtualization servers. You got it. It really depends on what that thing is designed to serve, is designed to actually do. On enterprise, they use servers for storage purposes. Okay, so you might have the direct attached storage. You may also have the network attached storage, but also may have the storage area network, SAN. You may also have a tape libraries where you putting things in the tapes. You also have a redundancy, this RAID. With the RAID, we have different ones. We have RAID 0, RAID 1, RAID 5, RAID 6. There's also RAID 1 plus 0, which is like RAID 10, right? All these are like a different RAID where you can use a redundancy, meaning using multiple hard drive, right? Combine those hard drives together so they can be used at the same time to give you the redundancy. Just in case if one disk fails, one hard drive fails, the other ones are there to, to pick up where, the things left from. We will come back to RAID in more depth because it's important. And RAID, it's talked about in A+ as well. But going back to things like storage network, storage area network. So this is not attached, right? SAN is attached and DAS. These are like attached to your local area network, your LAN. So they appear as a file inside of, your File Explorer. File Explorer is this guy right there, that little file thing, okay? So they look like they're attached to it. Basically, these are like in the same building as the building where all the computers are. Okay, which is okay, but what if there is a problem? What if there's like a natural disaster? Then you have a bigger problem. Where a SAN, on the other hand, it's not attached to the enterprise, to the file storage server, for example, of the company. Well, what I'm saying is it's outside of the organization, and then you connect to the organization using something like a fiber channel. Like a fiber channel, it's one of the connections that you can use. You can also use iSCSI, right? Your connection, right? You can also use that to be able to connect storage area network to your file server at the company. And that takes me to IoT. Like I mentioned, this is the Internet of Things, right? This is the idea of trying to make everything smart. Try to make everything smart. And this is coming up in trend. I have a friend, I always talk about him. I have a friend who's making over $300,000, literally $300,000 working on Microsoft as an AI, IoT researcher. He's an IoT researcher, and then he's making that good money. So if once you hear about IoT and then you're like, oh my goodness, I really like that stuff. That sounds really interesting. Specialize into it. Because this is here to stay. It's been around for here and there, but now it's becoming mainstream because a lot of hospitals now they use IoTs. A lot of home they're becoming IoT. People are buying these smart things, smart lights and smart cameras and smart thermostats and all that kind of stuff. So you are the person, if you specialize in this, you're the person, either you're the engineer that designed this kind of stuff, or maybe you're going to add a security on top of that, where you become like, let's say like a penetration tester that tests IoT products. That's also a career track. By the way, that's one of my other goals in this class, is that maybe you decide what you want to do by the time we finish. You're like, you know what? Screw cybersecurity. I want to go with this other direction. And that's absolutely okay. That's why this class is free. And I'm recording this. Feel like having fun as a way of me sitting with you, just having a discussion about this whole IT stuff. Anyway. But this is IoT, Internet of Things, is the idea of trying to put the things that were normally not connected to the internet, connected to the internet. So thermostat, refrigerator, microwave, and so on and so forth. You also have a wearable. People having iWatch and smartwatches. It's for tracking their fitness, for just, health monitoring and things like that. Well, that's all IoT. You also have environmental sensors and industrial IoTs, right? These are designed to kind of check the temperature, for example, inside of a data center, look at the humidity, air, the quality of the air, all kinds of stuff. For industrial control system, we call this IOC, industrial control system, they have been really pushing a lot of IoT in IOCs. Now you could like, okay, Francois, what is IOCs? Well, it's a specialized, it doesn't have to be IoT because it's been around before IoTs. This is industrial control system. I don't know why I read IOC. Nope, that's not what that is. Industrial control system. There we go. There we go. Now I'm thinking, right? This is the ICS. There we go. So you can specialize in ICS. The SANS has a lot of courses on ICS. But what is ICS? Well, ICS is an industrial. This is the system that controls the power plant, that control power, that control water, right? It's basically the infrastructure when they put this in place, it doesn't change as often. So you can specialize in that because what they're doing now, they're adding smart stuff inside of ICS. And guess what? That's a problem. Huge problem. Okay, so IoT devices, they connect using things like Zigbee. We'll talk about that, and Z-Wave and Wi-Fi and Bluetooth. But really, just remember, IoT devices are smart devices, things like thermostats, similar to what you're looking at here on the screen. And that takes me to the motherboard section, right? The motherboard. Well, hence the name, the mom, right? The mother. This is the component within the computer system that is designed to basically controls everything. I'm talking about like everything that must work on the computer has to be connected to the motherboard. This is the mom of everything else. So if you watch this video from the beginning, you know that I told you the little story of me opening a computer. When the DVD drive died, I opened the computer. So here, I don't know why I put a drive there. So let's go to motherboard. So when I opened the computer, this is what I saw inside. Before I show you a motherboard, see inside of a computer. Desktop. Let's take a look at the desktop, okay? Hopefully I'll find a pretty good image that can allow me to show you some things. Yeah, the desktop that I was messing around with was just like this one. It looked like this. So let's take a look at this desktop right here. There we go. So this is what's inside a computer. There you have the power supply right here that provides power. These are the power, cords that comes from the power supply. So these are, you can hook these up to pretty much anything. Anything that needs power, you will use these. Usually there's extra kind of cables here that you can use for all kinds of things, right? Anything that needs power, they will get it from this, power supply. Anyway, the thing that you're looking at right here, this whole thing is the board. This is the motherboard that we're talking about. And as you can see, everything has to be connected to this thing. For example, we have the CPU right there. That's the CPU fan. If you remember CPU, that's the central processing unit. So that's the fan. Why does the CPU must have a fan? Well, because the CPU is doing a lot of calculations and it gets hot. It gets hot. So it needs to be, kind of cooled down a little bit. And there's usually like a fan on top of the CPU. You also have, right here, you also have, these are known as a SODIMM, but these are used for the RAM, random access memory, RAM. So you kind of plug in your RAM there. But you also have your external. This is the beauty of desktop computers. You can upgrade things. So you also have your external things that you can attach to your machine right here. They have these attached and that attached and that attached. And these things are designed to do all kinds of things. And you can attach them through that right there. For example, if you want to turn your desktop into a Wi-Fi enabled device, Well, what you can do is just buy the Wi-Fi thing and then just come and open it up and just plug that bad boy in here. And voila, now your desktop will have Wi-Fi. You won't need to be plugging in cables anymore, right? Anyway, back to the point. So everything inside the computer has to be connected to the motherboard for those things to work. So if I go back to the let me close this. If I go back to the motherboard, so you get to see it really good. This right here, it's a motherboard. This is a motherboard. The mom board. There we go. So on top, the you have a location for the CPU. Like I say, you can lock that in there once you have the CPU to kind of lock the CPU in place. You have where you put your RAM, your random access memory, like I mentioned. I'm repeating myself now. You also had your VGI, the cable that connected to your external monitor. You also have additional place where you can add additional things, like additional, cable. You also have your SATA connector, SATA, SATA, SATA connectors. All these are those connectors. They do all kinds of things. They can transfer power, they can transfer data, all kinds of things. The other thing is on the motherboard, you can see all these lines going everywhere, right? There's like a bunch of different things taking place. Well, these are the ones that are designed to take a lot of things. For example, on the CPU, you got all these things right here that you cannot see. But some of them are transferring power to the CPU. Some of them are transferring data. Some of them are transferring all kinds of things. Okay. And the RAM, it's usually closer to the CPU because they need to communicate. Remember, whenever you open something, that thing opens in the RAM, in the random access memory. We'll talk about that in more depth. So when the CPU is doing a calculation of something, that thing has to be opened in the RAM. So if I go here right now and open this and that and that and that and that and that, everything I will open, it will be open in the RAM. The RAM is the one that short-term memory that allows us to open things inside of it. But after the calculations, well, once you finish using the program, you close it. When you close it, it's no longer in the RAM, right? Because RAM only hold on to things that are being actively processed by the CPU. Okay. All right, let me get back to the slides here. Let's take a look at a few things. So you just saw the motherboard. Motherboard has a bunch of sockets, including the CPU sockets. You got those LGA, AMD, and so on and so forth from a different manufacturer, different vendors. You have memory slots, DIMM and SODIMM. This is where you put your RAM. You have the chipsets, right? That controls the data flow between the CPU and other peripherals. We usually call these the bus, bus lines. Those little lines that I was showing you, we usually call these bus lines. They basically carry, like I say, data power across the entire motherboard. That's why you're able to, for example, hook up your phone to your computer and then it start charging, right? This is the reason, folks. This is the reason. All right. You also have your expansion slots. This is where you add additional things. These are known as a PCIe slots, where you can add additional graphics cards, for example, or any other thing that you want to expand on your computer. You also have your storage connections, where you put your SATA to connect it to your external hard drive, hard disk. It could be also internal hard disk that you have inside of your computer. Motherboard have form factor. So for example, there's this ATX, which is the standard, motherboard form factor. You also have a micro ATX for smaller desktops, mini ITX for those compact systems. Then you have your extended ATX for high-end desktops, like gaming desktops and CAD desktops as well. So we've been talking about the CPU. Like Francois, it's time for you to tell me what the heck is a CPU. Well, CPU, like we said, it's a central processing unit. This is the brain of the computer. I probably have said that 10 times already. But here's the definition. It's the primary processor that executes instructions. You're like, okay, instructions from who? Well, from the user, the person who's using the computer, and from the programs. A program can say, hey, I need this amount of, these many hardware. Well, the CPU will do the calculations as well. So what are the manufacturers of a CPU? Intel is one of them. You probably have seen Intel inside. Yeah, Intel, really, it's a big, when it comes to CPU. They have the i5, i7, i9 now. I think they have some other numbers. But you also have AMD, ARM, IBM, Power, and RISC. All of these are manufacturers, but they basically create these CPUs. But Intel is kind of the king. And then as far as the architecture goes, we mentioned that some of these CPU central processing unit, they work as a multiple of them. So you have like dual core CPU that basically function as two CPUs. You have a quad core CPU that basically function as a four CPUs, and so on and so forth. These CPUs, they also have a level of caches. So there's level 1, L2, L3, right? Cache of memory that they use between the CPU itself and the RAM, random access memory. Okay. When it comes to performance, we mentioned this. There's the clock speed, there's the core, there's the cache size, and so on and so forth. All of these helps the CPU make the decisions. Remember, CPU performance is measured in megahertz. So 2.0 gigahertz of a CPU, that means this CPU can process 2 billion instructions per second. Yeah, per second, folks, per second. So it's extremely fast. All right, so multi-core processing enables parallel executions within multiple processing cores on a single chip. Absolutely. Like I said, if you have like a dual core, quad core CPUs, it can do multiple things at the same time. For those people who think multitasking, it's a good idea, right? So you have a dual core, you have quad core, you have an octal core, and so on and so forth. So it can go from a 12 all the way to 64 plus cores. It really depends on the kind of a vendor or the kind of a CPU that we're going after. And that takes me to memory. Memory, these are RAM, random access memory. This is a temporary volatile storage for active programs and data. You're like, what's the keyword here? Volatile. Meaning things that you store in the memory, in the RAM, it just disappeared as soon as you shut down the computer. So it clears when power is removed. So as soon as you remove the power, everything that you were working with, it's gone unless you've saved that stuff into the hard drive. Why do we have RAM? It's because of the speed. Remember, a CPU is processing billions and billions of calculations per second. So we need a location that is very fast that can hold on to that, that can help us open that thing the CPU is doing a calculation on. So for example, if I go here and open Microsoft Word as an example, I click on Microsoft Word, and now it's thinking. You see, right there, the CPU was doing the calculation, but RAM was getting ready to open Microsoft Word. Then you saw how fast that happened. This is it right here. It came back. I probably should be showing you that because that's part of that PhD class. Let me go ahead and minimize that anyway. But what we're doing, right? What we're doing with the RAM, we're going in. We are holding on to things as the CPU is doing the calculation on them. Okay, you say, Francois, I think I got that. What are some of the types of RAMs? You have DDR4 SDRAM. This is the current standard. You have a DDR5. This is the newer standard. You also have LPDDR. DDR4 for low power and mobile devices. You also have those error correcting, checking correcting CPUs. I say CPUs, but RAM, which is like I mentioned, they're used in servers and things like that. So RAM are extremely important. We use them, we love them, and they can also be configured with things like single channel, dual channel, quad channel, oct channel, and so on and so forth. Again, this is where the RAM, it's acting as multiple RAM at the same time. They also work with the CPU cache. So you got L1, L2, L3 as a way of caching things as the CPU it's going in and doing the calculations. So they basically these are like the things that are waiting to be calculated within the CPU. One other thing that I should mention that we're talking about, since we're talking about the memory here, is page fire and swap space. Well, your question might be, okay, Francois, I got that, but what happens when I open a program and then I leave the program running, then I don't use it. I don't use it. For example, then when I come back, I open another kind of a program, and then I never look at the other one that I had open earlier. Well, then what? Well, that program will be put into a page file. A page file, it's known as a virtual RAM, like a virtual, random access memory, VRAM. And the reason why this is called a virtual RAM, it's because once this program is temporary, this file is temporary, and it gets built every time you turn on your computer. So as soon as you turn on your machine, this program gets built. And this right here, it's where the computer is going to put things that you're not actively using. That's one reason. That's one reason. That's not the only reason. But the things that you leave running, that you haven't touched in a while, they get put into a page file. But also, when your RAM, it's overwhelmed. So let's say that you open a bunch of stuff at the same time. Let's say you open 50 things. And then your RAM is like, oh my God, I can't handle 50 things at the same time. You're opening too much. But guess what the RAM going to do? It's going to put some of that stuff in a page file. That's right, in a page file, and then actively allow you to be using the things that you have open. So the things that you're not actively kind of working with, it's gonna kind of put that on a page file. So instead of shutting down the computer, because that's what you will normally do since you overwhelm the RAM, it's part of the buffer overflow attacks. All right, this is not necessarily what that means, but buffer overflow, when you overflow the memory of your CPU, or I mean, of your RAM, it usually goes in and shut down. But because of a page file, it's gonna go in and kind of give you that little breathing room. Now, you will see the thing slowing down. That's obviously, but it's not gonna shut down. So let me show you the thing, CPU. You got to see this. This is the CPU. I think I showed you this earlier. Again, this is attached to the motherboard, something like that. Then you have your RAM, random access memory. So it looks just like this. This is your RAM. Oh, RAM, they brought the RAM car. This is your RAM. And the best place for you to upgrade your RAM, let me take you there. And I'm taking you here because it's not just for upgrading your RAM. You can do a lot of things. It's at Crucial from this company. I recently upgraded my RAM of my computer from a 16 to 64-bit. And I can actually show you that. I can go here I can right click on the Windows and go to System. Let me show you this. So I can basically show you the things that we just finishing all this time talking about. There's my storage right there. Graphics card is, pushing out 60 gigabytes. But I wanted to show you here is these right here. One, you got the processor. This is the brain of that computer, the CPU. As you can see, mine is i7, right? It's 2.6 gigahertz. That means this right here, it's acting as like 2.5 CPUs at the same time. So again, it's a gaming PC, so it's really, really fast. I kind of like it. Now, RAM that are installed, look at that, 64, right? Again, I used to have 16. So what I did, I went to Crucial. I haven't even seen this company, right? This company been around for a while. Every tech people, they probably know this thing. Their RAM tend to be like a little bit cheaper. So I went to Crucial, and then I grabbed one of these DDR5 RAM. Obviously, you had to check and make sure it's compatible with your laptop or your computer. But it's a really good project for you to do. Right? If you have like a laptop and you say, you know what, I want to upgrade the RAM, go for it. Go for it. Just make sure you have the right tools, and you will get the tools from iFixit. This is the toolkit that I have, iFixit. I just have it for fun, because I'm in cybersecurity. I don't do this stuff anymore. But iFixit have a tool. I haven't been here in a long time. Let's go to a store. They have this bundle. There we go. This is it, the Pro toolkit. This thing, it's not that bad, just about 50 bucks, but you can basically open anything. I'm talking about anything. All right. So this is what I have, and that's what I use. But and I probably should say you can open anything. You can open the mobile devices and laptops and computers and things using this toolkit right here. So ifixit.com and go to Crucial if you just want to grab yourself like a RAM or a hard drive that are cheaper. There are things that are cheaper and they're very reliable. That's why people love it. All right, let's get back to the slides. So back to the slides here, and let's talk about storage devices and some technology. Well, in module number one, we touched up a little bit on the storage, and now let's add a little bit more to that conversation. So if I go back here and just start with the very first one. So I start with the floppy disk. You're like, Francois, hold on a minute. Were you that old when the floppy disk were a thing? And my answer to you will be absolutely not. All right. Absolutely not. But folks, this was the very first kind of a storage media that they were using in computers. And it wasn't really that big. It just a couple megabytes, and that was it. And then from there, they went to the SSD. No, not SSDs, but HDDs. This is a hard disk drive. And I think I did show you this in module number one. So this is the hard disk drive. It's still used, and some of the ones that we have now, they're very, very high in terms of storage. So they kind of have like terabyte and terabyte of storage, but they're not as fast. They're not as fast. And then you also have SSD. Right? SSH, that's what that thing is. But when I say SSDs, SSDs are solid state drive. Okay. It's like the newest. This is what they have in smartphones, and this is what if you want storage that is very fast, this is the kind of storage that you will want. Okay, when I change the computer, my computer, when I upgraded the RAM, I also upgraded the hard drive. Guess from where? Same location, from Crucial. So I did grab one of these. I attached this one. I think I got like 2 terabyte. I attached that to my computer. And then I changed everything. My computer had like a Windows 10 on it. So when I added the hard drive, I changed all of that, and then I pushed this to Windows 11. I didn't really want to upgrade to Windows 11, but since I had like a newer hard drive, SSDs, and it was really, really fast, I said, what the hell? Let me just do it. All right. Let's see. What else do we have as far as storage? So back here, you also have those optical storage. So these are including things like DVD and CDs. And I know some of you watching this, you probably never heard about this. DVD. I mean, if you are like a high school kid, I have kids, and I always tell them I used to with DVD. They're like, what? What is a DVD? I had to take them to Goodwill one day and show them something like this. Literally. Like that was the DVD. I used to enjoy this. I used to record videos with this and that kind of stuff. Anyway, so this is a DVD. It's a DVD drive, and that's a DVD. Put that in there. And uh, DVD can kind of store things. That's why I brought you here. You can store things not that big, just about like 4 GB, I believe. You also had a CD. They just like DVDs, but they were used for music. All right, they're used just for music. CD, you have the ones that you can read and write. You also have ones that you can only read. You cannot write on them. All right, and the same thing with the DVD. You also have a Blu-ray. They thought, you know what, DVDs are just not that, they tend to just die, quicker, or they don't have enough storage. Therefore, let's just go with the Blu-ray. And sure they did. Blu-ray they have like a larger storage compared to DVDs, but still, I really don't remember last time I watched anything from a Blu-ray or a DVD. Right? Computer doesn't even have the deck anymore, right? There's no place to put these DVDs in them anymore. Anyway, so these are storage as well, or at least they were used as a storage devices in the past to store music and to store, videos and things like that. You also have a USBs. I didn't get to show you those, but I did show you external, like DVDs and things. These are all external. You have tapes, and so on and so forth. And that takes me to keyboard and mice. Well, keyboard, you know what a keyboard is. Some of them are mechanical. Like the keyboard that I have, it's a mechanical keyboard. I kind of like them. It's a little bit nice when you're typing on a mechanical keyboard. They tend to be a little bit more expensive, but the most common ones are these right here, right? But you also have these kind of a keyboards, right? The different designs. Look, most people just roll with this, and the type of a connections that you will have on the keyboard, it used to be USB. I think most people still have USB, but a lot of us are now doing, Bluetooth and, as a way of connecting the keyboards. You also had the PS2, like I mentioned, this is old. So the layout in the US this is what we use in the US, but when you go to Germany and some other places like France, they have their own kind of alternative as well. What about a mouse? Well, a mouse, again, used to kind of move things around inside of the computer. This is a mouse that I am using right now. Well, you have optical ones, you have a laser ones, you have a ball ones, the old ones, you have a track ball and you have a trackpad for like laptops and things. Anyway, these are mouse. Right? Mouse are used to kind of move things around in your computer. These are used as input devices. Touch screens and styluses. Okay, so touch screens technologies. Well, that includes things like resistive and capacitive, which is like the most common ones. You also have infrared and a few other things. Anyway, you know what a touch screen is. Touch screens, if you have like a smartphones or tablets and things like that, you have a touch screen capabilities. Single touch, you do things. Multi-touch, you do multiple things, and so on and so forth. So some of these, they use these as styluses, if I'm saying that word right, right? And these are used basically to write or help you write on your touch screen device. Some of them are rechargeable. I'm not a big fan of these. I don't know why. Hopefully sometime in the future I'll try them. But I'm not a really big fan of tablets and things. I really haven't found any common use. I mean, any use case of them, at least in my life. But I've seen people using these for, taking notes and designing things and art and all kinds of stuff on their tablets. Scanners and cameras. Camera and scanners, you know what these are. Scanners designed really to scan things. It could be documents, photos, multi-documents. Some of them are portable, right? Designed to just scan things. Then you have your camera. Camera includes, things like webcam for video conferencing. A lot of people, after the pandemic, we all had video cams, right? You also have digital cameras for those professional photographers. I got some for presentation, surveillance for things like CCTVs, and some other specialized cameras as well. So you know what cameras are designed for all kinds of things, and you know what scanners are. You know, some of these are like they do printing and scanning and all kinds of stuff. Nowadays, our smartphones can be used for scanning things. All you do, you just install the app and off you go. And that takes me to biometric. Like, okay, what is biometric? Well, bio means you. Bio means you. So biometric devices, these are devices that can be used or can be used to identify who you are. Right? Most of them are used for security reasons. Okay. So when we want to authenticate, meaning we want to figure out who you are, we might use a biometric scanner, for example, to try to figure out who you are. So if you ever went to a place and they're asking you, hey, put your finger right here. Let's do a finger scan. Well, that's a biometric. Why? Because your finger is unique. Right? Nobody else should have the same finger as you are. It doesn't even, not even your siblings. So they all have their own kind of uniqueness in their fingers. Anyway, so fingerprint readers are biometric, facial recognition, biometric, iris and retina scanners that scan the retina and the part of your eye and things like that. Well, that's all biometric. Again, it's unique, uniqueness in you. That's what biometric tend to target. Now, when you use biometric as a way of authenticating people, well, this is the strongest way of authenticating people. And now I talk about this in more depth in Security Plus, so maybe consider joining that class or taking some of the training that I have on Security Plus. But when you authenticate using biometric, that's super strong. And the reason is unless somebody managed to cut off your hand, your fingers, they can't really authenticate if you've used biometric as a way of authenticating yourself. So biometric security things to consider, including what you're looking at here, the false acceptance rate. So false acceptance rate, or FAR, is when we accept, or the biometric system accepts someone when it's supposed to have denied them, supposed to have rejected them. So this becomes like a false acceptance, right? FAR. And then you have your false rejection rate, FRR. This is where the system rejects someone that is supposed to allow. And then when I'm teaching this, I usually ask the students, and then I'm going to ask you this right now. Which one do you think is the worst? Which one do you think is the worst? And some people are like, you know what? I think this one is the worst, right? The FAR is the worst, and that will be correct. So false acceptance, this is like accepting someone who was supposed to be denied. That's not good. Now, false rejection, it's annoying. Rejecting people that are supposed to be here, it's very annoying, but it's not as worst as accepting people who were not supposed to be there in the first place. So biometric is heavily used in things like multi-factor authentication. Again, in Security Plus, we talk about this in more depth. You can also use biometric for voice. Apparently there's some uniqueness in your voice. So they do some pattern matching and kind of figure out what's unique about your voice. So biometric can also be used for that. What about display technologies? Well, what if we want to see things on the screen? Well, we use LCD. These are like monitors, right? This is display, okay? So you got all kinds of monitors. They're all used for all kinds of things. But the biggest thing or the biggest reason is to be able to be the output device. Output device. There we go. So again, we're going in and we're doing things inside the computer. We want to see what we're doing in the computer. LCD monitors or whatever monitor, LED monitors, they all the same, just different quality and things. OLED monitors, all of them are designed to just give us the things that the computer is seeing. Now the technology behind them, it's a little bit different. And for example, OLED are better, with TVs and things. LCD are okay with things like, small screens and all that kind of stuff. But again, all designed to do one thing and one thing only, output. Allow humans to be able to see what the computing device is doing. You also have ink, like printers. They're able to kind of print things on papers back to the point of output. They're there to output things. You got LCD projectors. You got the digital light processing, DLP, right? That is included, as you know, the technology that's included in these display systems to again allow us to be able to see the things that's happening within our computing device. What is the specification of these things? Well, the display specifications, including what you're looking at here, right? 2080, that's for regular HD. You got 2560 and so on and so forth for things like 2K, right? And then you got the 1920 to 1080. That's you know what that is. That's full HD. A lot of TVs and laptops, and now they support this. But you also have TVs that are going 8K, yeah, going 6K. They're going I think something that was like 16K. 16K. It's like, oh my goodness. We're not there yet. But you got cameras. They're also taking this kind of resolution as well. Printers and their types. Well, you have laser printers, commonly used in office printing, right? Those like a bigger printers where they're printing a lot of things. You also have inkjet printers, right? You find these in home places. I used to own one of these, but you can also print photos and color documents and things like that. Then you have your thermal printers, right? These ones, they don't use any ink. So they're pretty good on things like receipts. If you go to buy things and you see that little printer they use over there, those are like thermal printers as well. But these are not the only ones. You also have a 3D printers that print like physical objects, right? If you can go on YouTube and just search 3D printing, you will be amazed. You will be amazed on how these things print something out of nothing. And they said long-term 3D printing, it's going to be the future of manufacturing because you can literally print anything, any objects, right? But we'll have to wait and see. Audio output. Well, when it comes to audio, you got speakers, right? When we're talking about output, you got speakers. This is something that you're hearing this voice from. You're like, okay, Francois, I got it. Um, but you got internal that's built into the device. You got external, like an external speakers. You got multimedia speakers within subwoofer, commonly used for TVs and things. You also have like a surround system if you just want to go all in on music. You have smart speakers that have these voice assistants like those Apple speakers and Alexa speakers and Google Home speakers. Anyway, you got the idea, right? When it comes to audio output device, speakers are ones, headphones are the others. And you also have some other specialized output devices that can allow you to kind of output things. That's what we're talking about here. These are what allows the human to get something out of the computer. All right. For example, the plotters, these the large format printing that uses a pen to print on CAD and architecture. And if you go to YouTube right now and search this, you'll be surprised what you see, especially in these manufacturing facilities. They use this quite a lot when they're, kind of creating things or creating diagrams of things or fetches of things. Display connectors. So you have HDMI. HDMI is the most common way of connecting to your TVs. Again, this goes in and give you that 4K and 8K and things like that. You also have DisplayPort. DisplayPort are faster, they're better than HDMI, so it supports a higher bandwidth than HDMI. And it has some kind of a sync and FreeSync kind of a technology inside of it. Pretty fast, extremely fast. A lot of devices they're using DisplayPort now. USB-C, it's really kind of fast, and it can carry DisplayPort signals. There's also power delivery and the data simultaneously, which means you guys know what a USB is, right? We use these to charge phones. We use this to do all kinds of things. Then you have your legacy connectors, things like DVI, very old, VGA, very old, SDI, very old, and those analog port, those SP2 port, and all kinds of things. These are legacy and they're old, and we don't use those anymore. Let me go to Google, show you HDMI, and show you DisplayPort very quickly. All right, here on Google, we type in DisplayPort. And if we go here, this is the DisplayPort. Okay, this is the DisplayPort. It kind of looks like the HDMI, but it's just a little bit different, right? That's the HDMI, and this is the DisplayPort. DisplayPort is better, faster than HDMI. Looks like that. You basically hook that up on your monitor, and then you connect the other end to the computer, and then off you go, right? Off you go. What about HDMI? Nice HDMI. There we go. This is the HDMI. That's the connector. That's how it looks like. Again, it's used to connect to things like TVs. You can buy this to hook your TV to your laptop and things like that. You can also buy the converter. So you can buy HDMI to DisplayPort. You can buy cables that look like this, where you hook up your HDMI and then you get the DisplayPort on the other end, and vice versa. Okay, they do have these. So if your TV or your computer doesn't support something, don't be limited to whatever it has. You can upgrade it. You can do all kinds of things. And that takes me to USBs. We know what USBs are. Absolutely, USBs. They have different versions. Version 1, 2, 3. I think now we're up to 4, which can transfer up to 40 gigabytes per second. Ooh, that's pretty fast. But you also have the connector of them, Type A and Type B and Type C USBs. The Type C is the newest. This is the one that you find in a lot of these phones these days. So, but that's USBs, right? USB Universal something. I remember what a USB stands for. You will look it up, right? What if you're connecting a network, right? What if this was like a Wi-Fi, or maybe not a Wi-Fi, but a desktop computer? Well, how would you connect this thing? Well, there are multiple ways to connect this using your network connectors. One, it's Ethernet, RJ45. This thing have 8 pins, modular, right, connector, and it comes in different categories. You got Cat 5, meaning category 5. You got Cat 6, category 6. You got Cat 7, Cat 8, which is like the newest, and they have the highest speeds, and they can go up to 10 gigabytes per second and more. You got the idea. These are RJ45. We call this Ethernet. They're used to help computers connected to the internet. They're not the only ones. You're like, okay, what if I want to connect phones? Well, you can use RJ11. RJ11 is used for telephone, especially those office telephone. You also have a coaxial cables that are used for, cable internet, without forgetting fiber. Speaking of fiber, fiber comes with a different connectors. You got LC, which is for small, which is this small form factor. You got SC, or subscriber connector, which is the push-pull type of connector. You also have a ST, straight tip, which kind of looks like the straight-through cable of Ethernet. And then you also have MTP, multi-fiber connector. UEFI has a single mode and multi-mode. Actually, single mode and multi-mode fiber, it's more of like a speed. Like the connector can be really, different ones. But a multi-mode, it's usually used in as the backbone of most businesses, and it's not as fast as single mode. Single mode are the ones that we use as the backbone of the internet. So when Google have a wire that goes from America all the way to the UK or Europe, well, they're using a single mode most likely. All right. There are some specialized network connectors as well. You got SFP, small form factor, pluggable. You got SFP plus. This is the enhanced SFP, which can go up to 10 gigabytes. Then you have a QSFP, quad SFP, that goes up to 100 gigabytes per second. Then you have your DAC, your direct attach copper, for those, copper cables. Anyway, these are the connectors. Actually, you know what? Let me go to Google and show you some of these very quickly before we talk about Bluetooth. So if I go here and bring Ethernet cable, Ethernet. This is Ethernet. This is the RJ45, right? The reason why I call this 45, the pins, you open them up, you will find, it's like 45 of them. But this is the RJ45 cable right here, okay? Like I say, there's a different category of this. You got Cat 5, Cat 6, Cat 6E, Cat 5E, Cat 7, Cat 8, right? Those are just the category. And then you have your fiber. Ooh, fiber optic. There we go. So this is your fiber optic cables, right? Again, they have different type of connectors, those LCST and things like that. But fiber, they transfer power using lights. So they don't I say transfer power, but they transfer data using lights. They don't work as the copper cable works or the RJ45 cables. These are different. And then when they're doing their work, you don't really want to look at them because they can damage your eye, right? The light beam that's transferring those data, those ones and zeros, it's not good for the eye. Wi-Fi standards. Okay, so Wi-Fi, this is what we use when we connect our laptop wirelessly, right? We're transferring data and signals and things like that through a radio wave, meaning we're using air to transfer things instead of using wires, okay? So there has been a kind of evolution of Wi-Fi. Wi-Fi been around, and it started off as the 802.11b. By the way, these are the standards of Wi-Fi, meaning they go together. The task force that's in charge of Wi-Fi, they basically come up with the standard. And they said, okay, this from now on, and this is the standard we're going to use. So all the vendors, the manufacturer of a Wi-Fi product, they just have to follow this. So Wi-Fi over the years have come to a different evolution, a different standards, if you will. 802.11b was the very first version, and this one, I want to say late 1990s, really allow you to transfer 11 megabytes per second. Very, very slow. So, and it used the 2.4 gigahertz range, right? 2.4 gigahertz, that was the kind of the range there. And then, somebody said, you know what? Let me come up with the 802.11a. 802.11a really didn't work out. And part of the reason was because they tried to push the 5 gigahertz, 5.0 gigahertz range. And that really didn't fly. Why? Because hardware wasn't ready at the time. We're talking about like early 2000s now. So they had to go back and they said, you know what, let's come up with the 802.11g. And that was the standard that we stayed on that standard for a long time. Reason is because it increased speed with the 54 megabytes per second, which was really fast. That's still fast. That's still usable. And He also went back to the 2.4 gigahertz, which allow you to basically, it was faster. It can allow you to connect from like a longer distance, because 5 gigahertz, you have to, it's fast, but like you had to be like close to the access point. Anyway, in 2000, I think when I want to say 2008 or if in, never mind. But they came up with 802.11n, kind of after 802.11g. 802.11g was around for a long time and got introduced, and it came up with the newer technology that's known as a MIMO. If you've seen that little movie, MIMO, MIMO, pretty much, something like that. But no, but this was multiple input and multiple output. In another word, this was the first Wi-Fi standard that allows you to use multiple antennas, literally on your access point. So basically means your Wi-Fi can be pushing things to you twice as much, using multiple antennas. So the speed got pushed up to 600 megabytes per second. Because remember, now multiple antennas can be used in this case. And then we had Wi-Fi AC, Wi-Fi AC, but 802.AC. This is also known as Wi-Fi 5. They're trying to do better with marketing because really nobody remembers 802.11 what? Unless you are in IT. If somebody asks you to keep remembering 802.11, 802.11, no. With a 802.11 AC, they say, you know what, let's just call this Wi-Fi 5. And that's what they've been calling this. And this pushed the speed up to 3 gig, pretty much. And then recently, they came up with the 802.11ax. AX is also known as Wi-Fi 6, Wi-Fi number 6. And this pushed the speed up to a 10 gig. Yeah, I don't know. I don't know if there's some people that use a Wi-Fi that's like a 10 gig, but the standard is here. The standard is here for that as well. Now, the frequency, this is the 2.4 gigahertz that I was talking about. But that's not the only one. There's also 5 gigahertz, but there is also the newest one, which is 6 gigahertz that can also be used for Wi-Fi. What happens when you want to secure Wi-Fi? Because when you set up your Wi-Fi, you got to secure it. Well, in the old days, they used to use WEP. WEP is the Wi-Fi equivalent privacy. Is that in here somewhere? No, it's not. So it's the Wi-Fi equivalent privacy. This was used for privacy reasons, right? It's old. It's really unsecure, and security wasn't really their focus. Privacy was when they kind of created this one. So they said, you know what, we're gonna come back with, we got to do something better. Then they came up with the WPA. This is the Wi-Fi protected access. I believe that's what that stands for. Wi-Fi protected access. I think so. You can look it up. Anyway, so WPA came out, specifically version 1, all right? And version 1 was okay, was pretty, secure. And they found some issues with it. And they say, you know what? We got to come up with a WPA 2. WPA 2 came out. It's very strong. It's still being used in a lot of places. But in 2018, they said, you know what? We got to come up with a WPA 3. And WPA 3 is the latest. It's still being kind of adopted, if you will. Very secure. It introduced a lot of things as well. Well, WPA2 and WPA3 does support things like pre-shared keys for personal use. When I say personal, meaning the way you set up your Wi-Fi at home. But you can also use these for enterprise use. If you do that for enterprise use, that means you want people to authenticate with their username and passwords without using pre-shared key. Pre-shared key is like the Wi-Fi password. Okay. If you're going to use these for enterprise, you have to set up what we normally call an 802.1x, meaning security, like meaning authenticating people, asking people, who are you? Right? Asking them to give their username and passwords. But you also have to create a radius server. That's the authentication, authorization, and accounting server, AAA server. You got to join Security Plus for more information about these things. Okay. Then a captive portal, you'll find these in the airport and like Starbucks and places like that. You also have WPS. This was used to allow Wi-Fi to connect automatically, like without you needing pre-shared key, without you needing to remember your password. Basically, WPS, it's a Wi-Fi protected setup, I think. Yeah, something like that. But basically, you push a button on your Wi-Fi controller or your access point, and that connects to your phone automatically. It will give you some kind of a code, a number, and then you will use that to connect. Really easy. It was very convenient, but there was issues, a lot of issues with it. Therefore, they have to take that back. Although recently they brought it back with some improvements. So we'll see how that goes. What are some of the advanced features? Like I mentioned, there's the MIMO, there's the MIMO, like multiple user using MIMO. And then you have the OFDMA that's also taking place, and BSS, for things like Wi-Fi NAM and SSIDs and all kinds of things. Again, Network Plus and Security Plus talks about this in more depth. Another connection is NFC and radio frequency identification, RFID. Starting with NFC. NFC is the near field communication. This is a very short range, like very short, yeah, shorter than Bluetooth. Yeah. So this is a very short range wireless technology that is basically used in things like payments. If you've used things like Apple Pay, that uses NFC. If you use things like Android Pay, Samsung Pay, that's all NFC technology doing the work. So it's very, very near, and it's a very, very short range. Radio frequency identifier. These are wireless that uses electromagnetic fields, similar to what Wi-Fi and an NFC uses. But most of these are used for things like opening doors and inventory tracking, asset tracking. Now, as far as the range goes, it could be near to kind of a several meters. So it's a little bit better than NFC, but they're both wireless. You're not using any wire. You're just going in after this is set up and configured the right way. You're just using it. RFID, pretty good for tracking inventory and things, and NFC, pretty good on things like contactless payments. Other things we have as far as wireless goes, including infrared and Z-Wave and Zigbee, right? Infrared is the technology that a little bit old. It used to be used in remote control. In remote. So if you have like a remote that must have like a line of sight where you have to point to the TV, well, that's infrared technology. It must have a line of sight in order to transmit the signal. So it uses these invisible lights, hence infrared, and it's very limited in the range as well. Very old legacy technology. Then you have your Z-Wave and Zigbee. Z-Wave and Zigbee, they're both low power. They're both low power as far as consumption of the power, and they can be used on a mesh network topology. If you don't know what a mesh network topology is, get into the Network Plus class. That's where we talk about mesh and these other typologies. Anyway, so the range is 100 meters to 30 meters indoors and 100 meters outdoors. And the Z-Wave is primarily used for home automation, whereas Zigbee, it's mostly used in hospitals. hospitals devices. Hospital devices, they use these quite a lot because, you know, well, those hardware they have at the hospital, they don't want to, like those IoT that they have, they don't want to keep changing the power, for example. They want to, once this thing it's in there, it just works and things like that. Again, Zigbee will be the technology they use in that. As we're getting closer to the end of this module, well, we're coming up to the BIOS. BIOS is the basic input output system. You're like, what is that? That's a firmware. We talked about that at the beginning. It's a legacy. It's old. And this one is pretty much not used anymore. But they're both this one and it's little kind of its big brother, UEFI, kind of a newer brother, UEFI. They're both used to kind of control the hardware. And that's what you learned. UEFI is the Unified Extensible Firmware Interface, is the replacement of the BIOS. Let me show you both of them so we can talk about them from Google. And close some of these too. All right, if you go back to the Google pictures, you can go to BIOS. There we go. This is the BIOS. This, what you're looking at here, is the BIOS. Just a bunch of text basically telling you what you should be doing. Your question is, okay, Francois, how do I get to this? Well, you get to this by pressing some kind of a key on the keyboard. Usually it's F2, F1, F10, F12, like those upper key on your keyboard. Yeah, those keys. You press those and you get to the BIOS. Well, when do you do that? Can I just do that when I'm using the computer? And the answer is no, it will not gonna work. Well, the reason is the firmware, like I say, it's the software that controls the hardware, meaning the firmware runs before the operating system, the other software that allows you to interact with your hardware. So what happens is you have to shut down the computer. If you want to get to the BIOS, you literally shut down your computer and then you press the power button on the computer, then automatically start pressing the F2, the F3, the F10, the F12 on the keyboard. Again, it really depends on the manufacturer, right? The manufacturer of your machine. If it's Dell, you just, a simple Google Dell will tell you, you got to press this key in order to get to the BIOS. If it's HP, you got the idea. So that's how you get to it. You got to shut down the computer. You're like, okay, well, what if, I shut down the computer, I press the key and then it doesn't work? You shut down the computer again? Basically, you press the key when your computer is going into what we normally call a post. Post, something we talk about in A+. Post is the power on self-test. And this is where the computer is going into the booting process. It's try to boot, right? Basically turn on the computer. So as it's going in and doing that, that's when you press the key. Then once you press the key, it will go into the CMOS battery. CMOS, the other word that's there. So CMOS, there's like a little battery on your motherboard that's labeled CMOS. And that's the battery that keeps your time and your bio program active. If you ever wonder, how come the computer doesn't forget the time? Well, thanks to the CMOS battery. Thanks to the CMOS battery on your motherboard, that's why your computer never forgets time. But another pro trick, I don't know if it still works now, but we used to use this like 10 years ago when I got started into these things, was that if you set up a password on your computer and then you forgot the password, you don't remember the password, guess all you had to do? Open the computer up, remove the CMOS. As soon as you remove the CMOS battery, it's going to go in and forget everything, including the password, including time, right? Time. And all you have to do, you just turn on the computer and then it's going to be like brand new without requiring you to type in the password. Anyway, this is the BIOS. You get to this and then you use your keys on the keyboard, upper arrow keys on the keyboard to pick and choose which one you want to get to that way. Let me show you CMOS before we talk about, I don't know why I'm typing that. I'm trying to get in Google. Let me go to CMOS battery on the motherboard. There we go. This is it right there. The thing that you're looking at right there, like that looks like a watch battery. That's it. All right, this is the CMOS battery. Meaning you open the computer, you remove that, you wait for about 10 seconds, you plug that back in there. Voila. Voila. Okay. The next thing I said we're going to talk about, it was UEFI, UEFI. So UEFI is the newer version of the BIO. And this guy, it's coming to replace the BIO. You're like, what do you mean it's coming? It's been around for a while. Like I'm talking about 15 or 20 years. Like literally, this thing. Been around for a while. But it looks like this. It's better. All right. It's cleaner compared to its old body, Mr. BIOS, BIOS. Okay. And then the beauty of UEFI, not only it has the graphics where you can see things taking place, but you also see the fan of your computer, the speed, how the fan it's doing and what it does. You get to see your performance, how your hardware are performing, your hard drive, right? Your CPU and your power, the voltage that you're getting. Like I mentioned, your fan speed. So that's the beauty of a UEFI. It's nicer, it's better, but it also allows you to see a lot of other things. It does have some pretty good security features like secure boot. Secure boot, something we talk about in Security Plus, where you're setting up, maybe you're setting up your password for your your BIOS, meaning before you access the BIOS, you got to type in the password. That's doable, right? And there's all other things that you can do here. But this is the newer version of the BIOS, better used pretty much in modern laptops now. All right, let's get back to the slides here. Back here, let me make this a big screen. And let's see if we forgot anything. It looks like we talked about all of these, except the boot options. So some of the things you do in the BIOS and the UEFI is to choose where your computer is going to boot from. Okay, you can say, hey, I want you to boot from the DVD drive first, or I want you to boot from the network. A lot of people with the servers, they, do that kind of stuff. Or I want you to boot from the hard drive, literally. So every time you try to wipe clean the computer, you literally, this is what I used to do, just put the DVD drive in, let's put the ISO in the DVD drive. These are the old days. And then you go into the BIOS, you change where it's booting from. You say, hey, I want you to boot from the DVD drive. And that's literally how you wipe clean that computer. So you will go into the DVD drive, you will look at the ISO, and then you'll find the ISO, then it's going to boot up the computer from the ISO, meaning a fresh install. Then when it's done installing it, you will go back into the BIOS, then you change it to the hard drive. Be like, hey, number one, when you're trying to boot this, go into the hard drive first. Then every time it goes into the hard drive, it points to the MBR. MBR is the master boot record, right? Literally in charge of pointing to the operating system, right? Then when it gets to that, it will boot up the computer. Really straightforward. What are some of the security settings that you can do? Well, you can do password protection. Like I said, the administrator controls access to the BIOS. That's really what that means. You can use some kind of a password where before you get to the BIOS, you type in the password. Okay. Now, this is where I have to remind you that too much security is not security. I know a guy who did this kind of stuff. In fact, he took this to the next level. What he did, he tried to do TPM, trusted platform match, which is a chip on your motherboard that allows you to set this up using keys. These keys, you're like, what kind of keys? We're talking about cryptographic keys. right? Like security keys. Let me just put it that way. Anyway, he did that. And then he said, you know what? I'm going to take this to the next level. He put those keys into a USB. He says, before my computer can boot, this USB have to be connected to the computer. And that's exactly what he did. And it was great. We were all cheering for him. We're like, yeah, good job, man. Good job, man. Until he lost the USB. Now he's locked out of his own computer. He can't access it because he didn't even use passwords. He used keys, cryptographic keys, which are now recoverable. And, he had to buy a new hard drive. So really, that wasn't fun. Anyway, you can do things like secure boot, right? Really preventing an unauthorized operating system from loading. That's very true. This is a part of the UEFI, like I mentioned, and it's required in Windows 11. So TPM, this is the Trusted Platform Module. If you enable this in your computer, it will allow you to set up, to do like full disk encryption, for example, like encrypting your entire hard drive, right? And to be able to use those encryption keys that I mentioned as well. Again, have trouble with this, join security plus classes. And that leads me to the drivers. Drivers, where are they? Well, drivers are software that allows operating system to communicate with the hardware. You're like, I think I'm following. Look, when Microsoft created their Windows operating system, Windows OS, well, they didn't really think about all the hardware from all the manufacturers. No, they didn't. Well, Mr. Francois here can create his own printing company. Let me call that printing company Cyberprinter. That's actually a pretty good name. Cyberprinter. Well, this Cyberprinter create a hardware. And that hardware is a brand new hardware. We came up with it. It's pretty good. It does the printing and it's pretty awesome. Well, I have to get this Cyberprinter to work with this operating system that people use. Guess what I need to do that? Drivers. That's why every time you, for example, you buy a printer, you have to install the driver for the printer. Why? There's a highly chance Windows doesn't have the driver for that printer. So the the driver is the software that allows the operating system to be able to communicate with the hardware. So every time you connect a new hardware to your computer and the hardware is not working, check the drivers or go to the creator of the hardware, the manufacturer of that hardware, and grab the driver from there. Okay, what are some of the driver types? You got the kernel drivers. These are the driver that kind of a change that talks to the kernel. The kernel is like the heart of the operating system. We'll talk about that. Or you can join the A+ class to kind of dig a little bit deeper into that. You got user mode. You got virtual and class and mini board. There are all kinds of drivers. Some driver components, again, these are executable files. For example, you can just go to the creator of that driver or that tool, that hardware, then a drive and download it from there. Most of the time you have to double check with the drivers, right? Meaning you got to double check the digital signatures so that you know for sure you're getting the actual driver as well. Okay, so for example, let's say that I bought a new Brother printer. Let me go here and show you this. A new Brother printer. All right, let's say this is the printer that I am buying. Okay, I'm just gonna use this one. This HP Jet, whatever that is. So what I can do, okay, it's not working for me. I just want to grab the name. There we go. Right there, I can grab this, copy that, go back to Google, and say, hey, give me drivers for, let me paste that in there, that. Now, if I click on this right here, this is the very first page right here of HP. Let me just accept this. Again, I'm just trying this. Right here, it says, let's see, errors occurred. Okay, this is just some errors and things. But right here, they can show me all the software drivers that's related to this. I can see that there's the driver universal Fox. I can see that there's this right here, which is sort of like universal. That's kind of pretty cool. But I can just click on the downloads and verify the hash of this before I, kind of start using it, right? And that's it. That's really it. As soon as I finish doing that, I connect my printer and my printer should be able to work. All right, let's get back to this. So how do you go in and install these drivers once you have them? Well, as far as installation goes, you double click on the executable, the x.exe. But some of these, they used to be installed through DVDs and some of them from USBs and all kind of things. You can also get them automatically from Windows. As a part of the Windows updates, you can literally go to management, no, device management, device manager, this guy right here. And this comes with all kind of devices that's connected to your computer. For example, if you want to get to the printer, let me see if I see a printer. There we go. It's just the printer queue here. But you can literally just go to the property of whatever that is and be able to see the hardware changes or be able to install the drivers. Okay. Again, I'm not seeing it. I guess it's because I'm rushing. Yeah, but you got the idea, right? So you got that way of installing it. You can also just update things. Just go to the manufacturer website and grab the latest version from there. Some of the best practices, it's making sure you're checking, make sure you're not getting a virus if you're doing this. All right, so double check, triple check, check online, and then keep in mind that if it's not broken, don't fix it. Right, so if your print is working okay, there's no point of you updating the drivers. Because if you do, it might break things, and you don't want that. The other thing is, if anything broken, you got to be able to roll back. And rolling back is by knowing what version of your driver that you had before you update to the latest one. So how do you troubleshoot driver issues? One, you identify the problem, right? By identify specifically which device that is misbehaving, right? And then you diagnose the problem using something like Device Manager or some kind of a diagnostics tools, like those physical hardware tools that you can use for diagnostic purposes. Then from there, you update and you reinstall. And this is where you actually do something. You maybe update the drivers if that's what's going to solve the problem. If you run into any issues, you can always roll back. Okay, so it's really easy when it comes to drivers. It's you just grab it from the manufacturer website, make sure you got the right one, not not a virus, and then push that on top of Windows. Usually, most of these vendors, they're going to try to make their drivers work with Windows without a lot of issues. So most of the time, it's just gonna work okay. Hello and welcome to module number 3. This module, it's all about operating systems, OS. But that's not the only thing we're going to talk about. We will also mention about a few other software, like specialized software that you should be aware of. So before we move on and tell you all about what we're going to learn, I want to mention a few things at the beginning. We have 3 types of software. The reason why I'm talking about this right here, right now, is because most people that I've seen tend to confuse this. So I want to make sure I clear this for you so you can understand it once and for all. We have 3 types of software. Well, software number 1 is what we normally call a firmware. You probably have heard of me mentioning this already, firmware. Okay. And this for the operating system or for the computer, let me just put it that way. For the computer, this is what we know as BIOS, basic input output system. So BIOS and its big brother or its newest brother, UEFI, U-E, there you go, that's the E, RFI, right? UEFI, right? So these are for a firmware. What do they do? Well, firmware kind of controls the hardware. A firmware is the very first software that basically tells the hardware what to do. In other words, without a firmware, hardware will be just a bunch of metal that is like absolutely useless. So this is the software that closely aligned with the hardware that literally talks to the hardware at the low level. Let me just put it that way. So when you push the power button on a computer, when you push the power button, the computer goes into what we normally call the post process. Post is it's not the post like the post service. This is the power on self-test. Power on self-test. This is the process of booting up a computer. Guess what does this? The UEFI, the BIOS, it's the software that kicks this process on. I'm sure you've seen this where specifically on your Windows computer, as soon as you push the power button, you know it takes a minute, right? You see some things on the screen before you see the Windows logo. I think the same process apply when you have like a Mac computer, right? It takes a minute before you can start seeing the logo of the Mac app, the Mac operating system. Those few seconds, that's where the bio checking all the hardware, making sure the hardware are up and running. We're talking about the core hardware. So the job of a UEFI and the process of a power on self-test is to go in there and be like, hey, Mr. CPU, are you up? The CPU is like, yes, I am. Hey, Mr. RAM, random access memory, are you up? I am up. Hey, hard drive, are you good to go? We're good to go. Then after checking all those core hardware, then it passes on the control to the second software. And that second software is exactly what this course, this section, it's really all about. And that is the OS, the operating system. Operating system is another software that basically give us the UI. So operating system sits between the user and the computer. It allows the user to be able to interact with the hardware, the computing hardware. So right now, I have this Windows machine right now, right? I'm sitting in front of this Windows 11. Windows 11 gives me this user interface, this UI that allows me basically to control the hardware, all right? So there are a few of these. There's a few different operating systems they should be aware of. The first one is Windows. I won't spend too much time on here because the rest of this class, it will be all about this. So Windows, it's very popular. It used to be 80% of all the market share, but right now it's around the last 70%, meaning 70% of all the computers in the world are Windows computers. So majority of the companies, they run on Windows. It's extremely important for you to get familiar with Windows, not just as a regular user, but as a power user, as somebody who knows more than the basics, okay? So the second operating system that you should be aware of, it's a Mac. Although, we're not so crazy about this, especially in IT, because there's not a lot of companies that uses a Mac, unless these companies, they do things like video editing and, CAD designs and that kind of stuff, CAD designs. So, but it's kind of important for you to know that the Mac operating system, it's out there. They do have a market share, especially when it comes to smartphones. So you kind of need to know Mac. But the beauty of a Mac, the underlying code of Mac computers, it's based on another operating system that's known as Linux. So a lot of the things that you will do in Linux will also work in the Mac computer. Yeah, that's the thing. And Linux is the computer of love. This is the operating system that we love. It's free. It's free. It's open source, which means it's maintained by the community, and it's used pretty much everywhere. Everywhere. If you are watching this and you want to be, to get into cybersecurity, Linux, it's going to be your best friend. Oh yeah. I tell you, I tried to stay away from Linux for a long time. I was like, I'm a window guy. I'm a window guy. So I try to skip Linux and I try to avoid it to the point where I say, you know what, to hell with it. Let me just learn some Linux because every job that I got is like, oh, we want you to be typing these commands in the Linux terminal. I'm like, oh my God, not again, right? So it led me into even getting certified in Linux. So I have my Linux Plus that I got from CompTIA, but that was out of me just being pissed off. I'm like, you know what? Let me just learn the basics of Linux. It's like I don't have to be the Linux guru or the system administrator of Linux, this and that, but let me just know more than enough. And that's what I did at that time. Anyway, so that's software number two. Software number three is a software that does a specific thing. So we usually call these apps, uh, apps or applications. So this is a software that is designed to do a specific thing. So right now on my Windows here, I have Microsoft Edge. This is designed to help me browse the web. I have Microsoft Word, designed to allow me to type things, type letters and things. Xbox, right, for playing games and things. Spotify for listening to music. Outlook for sending and receiving emails. You got the idea. So it's an app specifically designed for a specific thing. So these are three different types of software. The rest of this class, it's going to be all about this. But remember, this is part of that domain three, which is a title application and software, and it's 18% of that exam. So please pay attention. I'll try to demonstrate a few things for you. With that, let's get right into it. So here's what we are going to talk about, right? This is the learning objective. First, we're going to compare and contrast different operating systems. I've already mentioned Windows, Mac, and Linux, and all kinds of things. So we'll talk about those three specifically. And I should also mention Linux have a bunch of different variations, a lot. Linux came from a Unix. This was the very first operating system that came out of AT&T Bell Labs, I believe. Was it Bell Labs? I think so. You can look it up. But then a guy named Linus, probably butchering his name, oh, that's S. He designed a kernel for this, basically something that allows him to use Unix without really going to all the trouble. And that became Linux. There we go. So he open sourced this. He made this free, and they said, you know what, this got to be maintained by the community. And over the years, Linux basically won because all the things that you use on the web, they're probably running Linux. And I mean all. These Google data centers and servers and things, they all runs on Linux. So if you're going to be a really good cybersecurity, a really good tech personnel, you got to understand some basics of Linux. There's no exception around it. So we'll talk about that and talk about different features of these three different operating systems, Windows, Mac, and Linux. Then we'll identify various software categories and their appropriate use cases. Then perform some basic installation. If you were to install a software, how would you do that? If you were to update software, how would you do that? Microsoft have a Patch Tuesday. Every week on Tuesday, they send us patches or they send us updates, as well as maintaining the software. Last but not least, we will do some commands because, again, you want to become a power user, not just like a regular user. So I will show you things like PowerShell, things like CMD, command prompt. I'll show you like terminal in Linux because I have Linux installed. Unfortunately, we won't be using the Mac because I don't have a Mac installed on this one. But I will definitely show you a few things in Windows and Linux. So let's start this conversation by talking about a firmware. Like I said, this is the very first software that basically controls the hardware. So firmware, here's a definition. Firmware is a software that is programmed into a hardware device. Absolutely. And the reason why they said it's programmed into hardware devices, it's because not only controls the hardware, but there are some devices that only relies on the firmware. Like we have some devices that doesn't have an operating system inside of them. You're like, really? Yeah, of course we do. And you're like, okay, well, what kind of devices are those? IoT products, those Internet of Things, those thermostat, those are smart cameras that you have. Those things don't have Windows or Linux or anything like that running. No. They're controlled off of the firmware. So the firmware that's inside of the chip on on the IoT product is the one that tells the hardware what to do. Okay, so hold on to that thought. So here's some common firmware types. Again, I mentioned the basic input and output systems, BIOS. I've mentioned UEFI. So you find these in laptops, in servers, in regular computers. So these are like the most common. But things like routers and printers and storage devices and a bunch of different peripheral devices, they all have firmware. Remember, without a firmware, the computer, whatever computing device that you have, it will be just a metal that is useless, right? Because the firmware is that very first instructions, if you will. That very first instruction, that's what a software is. It's just a bunch of instructions. That's the very first instructions. When you push the power button, it goes in and check all the hardware and making sure they are ready so that it can boot up that device. Now, when it comes to updating firmware, this is one of those things that gets debated quite a lot because many times when you have a computer, this never happens. Like I don't remember. I do not remember the last time I updated my BIOS, if I ever did. So a firmware usually just tend to just work, and that's it. And that's it. But the problem is if somebody gets access to their firmware, then you're done. Because look, the firmware controls the hardware. If they have a vulnerability, like a weakness in the firmware itself, then you're in big trouble. So most of the time, there's really not even ways of updating the firmware. For example, your smart products, your IoTs, these things, they're running firmware, but it's like, so if there's a vulnerability, how are you going to be update that? Like they don't give you no interface. There's nothing to click on. There's so that's really one of the problem we have with the firmware. Once they're in place, they tend to just work, just do what they're designed to do. But in some cases, we might have some, bug and vulnerabilities. And in that case, you will, computer vendors, they might send some updates and you got to apply those. Okay. What are some of the firmware security concerns that comes in mind? Again, there are some vulnerabilities that can get into a firmware, but if your firmware gets vulnerable, then it's game over. You got either to patch. If there's no way to patch that firmware, then you have to do what most really good security people do, and that is isolate, segment, isolation. So basically put that thing that is vulnerable on a separate network, like a separate location of your network. So that even if they get into it, they don't have access to everything else. Okay. So there's also the verification. There's the secure boot. This is actually one of the things that you can do on your computer. Secure boot, where you're going in, you're telling the computer, look, the post process, the booting process, the power on self-test process, before we kick on to the post process, I want you to authenticate. Literally, I want you to ask me for password. And if you don't ask me for password, well, maybe let's use cryptography. So I want you to go ahead and look into the chip, the TPM chip, the Trusted Platform Module chip. Right? If you don't know what that is, again, get into Security Plus class because that's where we'll talk about this. The motherboard has a chip, and that chip can hold on to private keys, like keys that can be used by your firmware, BIOS or UEFI, to be able to kind of provide this secure boot process. Okay. Bad guys can also have some backdoors in the firmware if that's what they wanted to do. Firmware are great, but the thing we're going to focus on in this class is the OS, the operating system. So here's the core function of an operating system. Again, like I said, is designed to allow you to work with your hardware, basically provided a user interface so they can be able to interact with the hardware. And not only does that, but it will also help you manage your resources. In another word, you can store things in your computer and do all kinds of things. It also functions as a platform for a bunch of other applications. For example, if I ran Microsoft Word, well, this Word is running on top of the Windows operating system. So the Windows OS, it's acting as the platform that basically allows that Microsoft Word software to run or application to run. So it does allow you to do things like file management. You can be able to manage your files. You can also enforce some security. We also have one called ACE, which is kind of a part of that ACL, Access Control List. Microsoft calls this, nobody else does, because it's really annoying, because it's like controlling who should have access to your files using what they call an access control list. But we have other vendors, they call access control list when they're talking about something you do in a router or a firewall, which I will teach you what those are, if not in this module, but in the upcoming module as well. So stay with me. Again, operating system, these are some of the core functions. Here's the architecture. Here's how it looks like. So it does have a kernel. A kernel is the core of the operating system. This gives the operating system direct access to the actual hardware. Like I said, you are the user. The OS provides the UI, also known as the shell, SHELL. So you can be able to sort of like interface, you can be able to interact with the operating system or with the kernel, okay? There's also the system service. These are the things that are running in the background. There's also the applications. These are the applications that you interact with. You spin up Microsoft Word, you spin up Spotify, and so on and so forth. So there are different types of software or operating system, I should say, out there. For example, we have a client operating system, which we're going to talk about these in more depth. But these are the ones that you and I have: the Windows 10, Windows 11, Windows 7, Windows 8. These are client operating system. They're designed for end user devices. Then you have server operating systems. These are designed to work in the servers, right? So servers that are like in the data center, right? Server that are designed to serve. For example, Microsoft have like Windows Server 2008, 2012, 2019, 2020, and so on and so forth. So these are servers operating system, okay? And then you have these embedded operating system. These are for specialized devices. When I say specialized devices, we're talking about the IoTs, right? We call this embedded. Embedded, it's like a chip that gets embedded, basically added to a specific hardware to do a specific function. So that might need some OS. And there are, in some situations, like lightweight OS that can be put into embedded. But for the most part, these are just that firmware that we talked about earlier. And then you have a real-time operating system, or what we normally call RTOS. RTOS. RTOS is for real-time critical applications. And keyword here, it's critical. The reason is these are the OS that controls the power plant, that controls the water plant, right? These OS, you will find them in what we normally call a CIS, industrial ICS, industrial control system. There we go. Not CIS. It reminded me of that spy movie. But this is the industrial control system. What is this? Well, this is the system that controls a lot of things. So think about the system that controls the water for the entire city, right? That controls the power for the entire city. If you've been in New York, you see like the public transportation, those train stations that goes everywhere by themselves. Well, think about that infrastructure. That's really what an ICS is, industrial control system. It's a system, basically, once that system is put in place, it doesn't change for a very long time. So to monitor that system, you will need to run what we normally call a SCADA. SCADA, there we go, SCADA. And this is something that we learn about in Network Plus and Security Plus. So again, check those courses out. But SCADA is the thing that give us that interface that connect with this real-time operating system to basically keep an eye on how high the water is, how much power are we giving this part of the city, that kind of stuff. And then you have your mobile operating system, a mobile OS. These are your Android. These are your iOS for Apple. And we have pretty cool OS out of China as well. So I just want to mention those as well. But these are operating system that are installed in mobile phones. Now, let's keep on with this conversation and start talking about these specific operating systems, specifically starting with the Windows operating system. Like I mentioned, we have a client version of these operating system. Specifically, there's Windows 10, and right now we have a Windows 11. These different Windows, they come in different versions. For example, in the client family, we have the Home Edition, we also have the Pro Edition, and then we have the Enterprise Edition. They also have, the Education edition as well for, schools and things. But uh, each one of these different versions have different features. For example, if you want to join your computer into like a company network, well, you can only do that if your Windows client machine is running Windows Pro or Enterprise. You cannot do that with the Home. So there's like a different features that they take away and they add depending on the kind of version, if you will, of the OS that you're getting. So I didn't mention there's Windows 11, which also comes in a different kind of a different family as well. And Windows 11, it does have the requirements for TPM. That's that trusted platform module to allow things like secure boot. And part of the reason is because Microsoft really been pushing big time for security. And their OS is used by everybody, so it kind of makes sense for them to push for security. And I'll be going to Google quickly and show you a few things. But actually, you know what? Let's go ahead and do that right away. Let's go ahead and do that. Let me go to Google here, and let's take a look at Windows 10. Oops. Let's go to image. There we go. Maybe you have sit in front of a computer that looks like this. This is an example of Windows 10, right? So you have the Windows logo right here. As soon as you click on that, it gives you this start menu. Okay, and this is where you basically pick things from. You have your icon right here that present the user. You have the file icon here that takes you to the File Explorer. That looks like that. Okay, then you have your picture, take you to pictures, and you can log off and sign out using that right there. You can go to your settings using that right there. Okay, and then the other applications. As soon as you click on the start menu, the Windows logo, you can start typing into this type here to search for specific applications. So this is Windows 10, right? If you see a Windows that looks like this, it's a Windows 10. Now, for Windows 11, I have it, so I can just show you from my end. This is what you're looking at right now. It's Windows 11. They removed the start menu from the left location all the way here somewhere. And when you click on the logo now, the menu appears from the middle, right? You still have the user. You still have the icon to power on. If I click on that, it's asking me to update my Windows, but we're not going to do that right now. But you can lock the computer, you can put this into sleep, and so on and so forth. So one thing that you can do as a power user is right-click on this Windows logo, the start menu. When you right-click on this, it will give you like this quick kind of location that have the most common things. For example, you can go to Task Manager, like there's like Device Manager, Disk Manager. You can go to the terminal, you can go to the Task Manager, you can go to Settings, File Explorer, you can search, you can run, you can do all kinds of things. So right now, for example, I can go to, where should I go? Settings. Let's go to Settings quickly. Okay, right here, this is the settings. And in the settings, there's a lot of things that I can do here. We're not going to do that, including changing color. We're not going to do that, but I just want to show you how to get to settings. Let me get out of there. So let's get back to this and talk about a few other operating systems that Microsoft have. So before Windows 10 and 11, Microsoft used to have Windows 8. Okay, Windows 8 was the version that came before Windows 10. And it looked like this. There we go. It looked like this. And Windows 8, Microsoft was trying to go all mobile. Literally, they said, you know what, Apple, you can't really leave us in the dust. We're coming. Everything is becoming mobile. So Windows 8 was all mobile. They even removed the start menu. Literally, the thing that makes Windows famous, they removed that in Windows 8. So a lot of us didn't like Windows 8, myself included. I had a like this is the OS of Microsoft that I never used it. I mean I remember upgrading companies to it, going from 7 to 8 and all kinds of good stuff. But I really never used this operating system uh as I should. But before that, there was Windows 7. Windows 7 was a classic. Oh yeah, people loved Windows 7, myself included. So Windows 7 looked like this, and it was good. You had the start menu, you have where you can search things, you can see all the programs, you can shut the computer down. It was good. I loved it. I loved it. Before that, they have Windows Vista. Windows Vista. And the Windows Vista kind of looked like Windows 7, but it had a lot of issues. Oh my God. It had a lot of issues. This is one of the most bugged operating system Microsoft pretty much have ever produced. There was a lot of issues with the Windows Vista that they quickly fixed all the issues and then rebranded or renamed it to Windows 10, Windows 7. But this was Windows Vista. As you can see, it looks like Windows 7, but it had a lot of problems. There was a lot of bug. Like there's one report that says they fixed millions of bugs. When I say bugs, I'm talking about like computer code issues, right? So they had to fix a bunch of those to get this to work, and then they basically rebranded it. They said, you know what? Let's go to Windows 7. Okay. And before that, they have Windows XP until the whole thing. Windows XP. And uh, uh, like I mentioned last time, when we got into the US, this was back in 2008. Windows 7 was out already, but I remember going visiting some friends, and kind of try to use their computers, and they had a Windows XP on their machine. When my dad bought us a computer, it was already on Windows 7. So I basically just automatically got into Windows 7. But as I advance into cybersecurity and to try to hack into Windows and things, I had to install Windows XP because it was hackable. It was very vulnerable, so that I can kind of play with it and try to scan it and find vulnerabilities and weaknesses on Windows XP. So I don't think the current labs that I have XP installed, but I do have the operating system. Just in case somebody wants it, just put that in the comment and I will put that into something like a Google Drive so you can, download the Windows XP. But this is Windows XP. Windows XP was the most successful Windows of Microsoft of all time. It was the longest run. It was around for a long, long, long time. All right. And that's because the one before it had a lot of issues. So before Windows XP, they have Windows 2000. There we go. Windows 2000. Now, Windows 2000 was horrible. That was horrible. People didn't like it. So they had to fix a lot of the things, a lot of the issue with the Windows 2000. And then it got that to Windows XP, from Windows XP to Windows Vista, and so on and so forth. I can go back to Windows 3.1 and all the other stuff, but that's kind of useless. But I wanted to just kind of tell you the different operating system that Microsoft have had over the years, at least the last 25 years or so. Now, on the server side, let's start with the server. Windows Server 2003. That's actually a pretty good place to start. 2003. This is a Windows Server. All right, Windows Server meaning it's not used for as a client in the client machine. This one is used to serve. Basically, once you install this particular window in your computer, you turn this into something. That computer becomes, let's say, like a web server, because you can install what Microsoft calls IIS. Let me just go and put that here. IIS, Internet of something something. I don't really remember what it stands for anymore. But this is a web server from Microsoft. So basically, once you install like a Microsoft Windows server, you can then say, okay, this from now on is going to be an IIS server, IIS server. And that means that computer will be turned into a web server. We can also say, you know what, once you finish installing the server, let's say, you know what, this is going to be AD server, Active Directory, an Active Directory server. A lot of people use AD, a lot of companies use AD. So you can do that as well. Microsoft used to have an email server known as Exchange, right? Exchange server. You can literally, once you finish installing this, turn that into Exchange server so that it becomes like an email server and start serving emails. Whew, that's a lot. But all I'm trying to tell you is that they had a Windows 2003 server, 2008 server that looks like this. Then they had a 2012. This is when I started kind of messing with the servers, right? In 2008. This server, I worked with it quite a lot. Then they had 2012 server. The 2012 server was horrible because it was based on Windows 8. So it looked like this, just like Windows 8. And then they have 2019. I think they had 2016, but let me just skip 2016. But 19 server came for Windows 10. It looked like Windows 10. And recently they had 2024. They had 2020, but you know what? You got the idea, right? It looks like they're about to give us another one in 2025, which is when I'm recording this. Anyway, let's get back to this. And that takes me to a Mac. All right, let's start talking about Mac computers. Well, Mac OS comes out of Apple, the Apple computer that was funded by the gentleman, Steve Jobs, and Stephen Wozniak. I believe that the other gentleman that helped find the Apple computer. So Apple operating systems are different than Windows. They are based on Unix. I say Unix was the very first operating system to ever exist. And there's even a documentary, kind of a movie, really, that talks about how Steve Jobs out of Apple and Microsoft, Bill Gates, how they stole the code, literally how they stole the function of Unix and based their operating system based on that. That's history. Maybe you can look at that up and find that movie as well. But anyway, I'm bringing this up to tell you that a lot of the things you can do in the Mac, it can also work with Linux operating system. But Mac OS are specifically designed to work on Mac hardware. I'm going to say Apple hardware. And they usually release different versions of the Mac OS, and they name those things after some kind of a mountain, literally. Over the years, that has been the trend. So let's go to Google and take a look at a few of these. So here on Google, let's say Mac OS. There we go. So this is a Mac OS. I won't spend too much time here because, like I said, I really don't have this OS installed, so I can't really show you a bunch of things. But let me zoom in a little bit so I can talk about this. So here you have the Apple logo. When you click on this Apple logo, there's like a little drop down that comes, and that give you like system functions where you are able to see all the functionality of your Apple. You can also kind of get to the hard drive and be able to see the storage and all kind of things. Okay. Then you have this, I think they call it Finder, something like that. But this gets you to your file system. Okay, file system. And when you click on it, it should take you into the file system of the Mac operating system. But this is the deck here. You also have the trash can out there. And then you have all the other icons, which you can add them, you can remove them, you can do all kind of things with this. Okay. On the top right, you have your battery life, you have your Wi-Fi and your time, and the search and a few other things. So the thing about Apple, every program you open, its settings is going to be at the top. So you have the file, the edit, and everything else at the top as well. I think it's pretty easy to use. I do have a Mac computer. Yeah, I do. But I use it here and there. Like I said, it's not heavily used in the enterprise. So you would do yourself a favor if you focus on the Windows and Linux, because if you're going to be hacking things, you have to use Linux. Let me get back to the image here quickly. So people love Mac computers because, first of all, the design is pretty cool. I really like it. That's one of the reason why, I have a Mac. It's really easy to use, if you ask me, and there's really not a whole lot to it. That's one. Second, there's a security. Yeah. If people are telling you, oh, Mac computers don't have any virus, well, they're lying to you because there are some viruses that can get into Mac computers, but Mac computers are reliable. Yep, I've had a Mac computer for years and years, and that's the same computer I've used for like 6, 7 years, and this thing still runs. I bought this computer in my old days when I used to do video editing because I had some friends that said, hey, go with the Mac if you go editing videos. I'm like, sure, let me save up and buy me a Mac because they're very expensive. So I've saved up the money, I bought the Mac, and I used it for a very long time, even after stopping, doing videos and things. I was still using it for all my, other things. Anyway, so there is a reliability. The UI, it's pretty cool. The interface, it's kind of pretty cool, easy to use, reliable, and it does connect well as far as the features goes. It does work well with all the other Apple products. So, for example, we will talk about these other OS, but you have Watch OS from Apple. If you have one of these smart watches, which is a part of the IoT, Internet of Things, it's gonna talk to a Mac computer without any problem. If you have iOS out of the iPhones, right? If you have this running, the iPhone operating system running, well, that can work well with the Mac and Mac computers. Even if you have iPad OS, yeah, Apple have a lot of OS. It does look like this. It's basically the same thing, but like a different clone version of that same exact thing. But iPad OS, it will interact with your Mac. And last but not least, if you have TV OS from Apple, it will also interact with the Mac. So that's the beauty of this. This is one of the reasons why I love it. That compatibility, that ecosystem. And again, Steve Jobs was really good at the UI design. If you watch the documentary, you will see how, Bill Gates was always like, hey, you Steve Jobs, you cannot code. You're not a programmer, you're a marketer guy. But he was really, really good at keeping things simple and designing things. And over the years, I've seen that in the kind of spirit of Apple. Their things tend to be simple, and the design tend to be really cool. You got to give it to them. And back to the slides, let's keep going. So another operating system we have is Linux. Actually, let me go back to Google, but let me mention a few things before I head to Google. Linux, like I mentioned, came out of a Unix. All right, this guy I was frustrated how he couldn't really use the Unix, how it wasn't really user friendly, and he designed his own kernel, and that kernel turned out to be Linux. So the rest there is history. But the thing that he did that changed this industry was making Linux free. Linux is free, it's open source, which means anybody who wants, including you can make your own version of Linux. You can basically have your own distribution of Linux if you wanted to. And guess what? A lot of people over the years they have. If I were to show you the distribution of Linux, we're talking about thousands. There's a lot of copy, like a lot of different versions of the Linux operating system out there. But some of the distributions are very common, including Ubuntu. Ubuntu is easy, it's user-friendly, it's really good, it's really popular, and you might find this in desktops. So a lot of people that use Linux, they tend to just use Ubuntu because it's really that easy to use. So Ubuntu came out of Debian. I probably should have mentioned this, right? So there's like a 2OG, let me just mention this. There's 2OG distribution of Linux, and one is Debian. Debian, like this is what's like the OG, the very first, it uses like a different package manager. So when you are installing things on Debian distribution, you use something like sudo for becoming administrator. Sudo apt, that's that package manager I was telling you about. Apt install, all right, something, something. Okay, that's how you do it. That was one. Second, probably should change that to one. And then second is the CentOS. CentOS was another distribution or another variation of Linux, and this one was a little bit different in syntax, right? In how you interact with it. So, for example, see how we type in sudo install things, apt install things. Well, with CentOS, it will be sudo, same thing, sudo, and then instead of saying apt get install this, I probably should say apt get. It's accurate that way. Apt get install something. You would say sudo yum. You gotta go yum install something. Okay, that's CentOS. So these were the granddaddy of Linux. After releasing the Linux, these were the two variations that came out of it, and over the years, a lot of people came up with their own version based on these two. For example, back to that Linux. Linux is it's based on Debian, which means everything you will do in Debian, it will still work with Ubuntu. Yep, absolutely. And CentOS was maintained by Red Hat. Red Hat. So Red Hat, it's enterprise. It's used in enterprise. It's a company. I think IBM bought them. Yeah, IBM bought them. But it's stable, cutting edge, a lot of features, and they maintained CentOS until recently when they said, you know what, from now on, we won't be maintaining CentOS. Then one of the creator of CentOS says, you know what, screw you, Red Hat. We're going to create another one known as Rocky Linux. Rocky was the name of the other person who was with him creating CentOS. So Rocky Linux, it's same thing, but maintained by the community. Because Red Hat was the company that was behind it and giving updates and with the help of the community. But after dropping the ball, this guy said, you know what, we're gonna kind of keep this up. There's also Arch Linux, there's also SUSE or OpenSUSE, if you will. Linux that's out there. I'll show you all these in a minute. This was the name that I was talking about of the guy. All right, Linus Torvalds. He's still alive. You can Google him. He's still alive. You can take a look at him if you wanted to. But well, let's go to Google. Let me get to Google Images. I finished talking about that one and the Windows. Let's close that. So right here, I can just say, hey, show me Linux distribution or distros. That's gonna work. And take a look at it. These are just the common ones. But if I were to say, show me all of them, it's hundreds and hundreds of them. For example, this image right here, give you an example. These are all different variations of Linux. And let me see if I get yeah, these are just, the major ones. But there are different variations and of Linux. So let me show you image of a few. Then I will get to Kali Linux, one of my favorite distribution. A lot of people that do hacking, they love that one. But let me show you a few images here so you have an idea. For example, Ubuntu Linux. This is Ubuntu. Let me say Ubuntu OS. See if I get the latest picture. There we go. It looks like this, just like this. I think the latest is this guy. Yep. It looks like this. So let me open this image here. There we go. You have pretty much everything. You click on this right here. It gives you like another location that has a bunch of applications where you can choose from. Think of this like the start menu. Right here, they have your favorites. Your favorites. You have your search engine, you have your email, you have your File Explorer, music and documents and the App Store, you name it, it's all there. Really good. You can shut it down from here, connect to the internet from there, and all that good stuff. So as you can see, it's really good. It's free. It's free. It's maintained by the Ubuntu company, but it's free. You can install it and start using it, and nobody's gonna bother you about it. So another one we have, it's like I said, CentOS. Let me show you CentOS. All right, let me see if I find a pretty good UI of CentOS. Yeah, this is after you click on that icon, but CentOS UI. There we go. There you go. Come on. Try to get this to be clear. It's like it's not. So let me go to this one. There you go. All right, here we are. Let me bring this up, and this is the CentOS, right? You click on the little applications right there, the icon, and then you get to see all of these, and you can expand them and then open your terminal, do all kind of stuff. Right. It's pretty good. The only difference is the command you tap here. Uh, it- a lot of them are the same, absolutely the same. There's just a slightly difference in them as well. Okay. Another one I said was Fedora. Let's see, we go to Fedora OS. All right. This one is still maintained. It's pretty good. It looks like this. All right. Similar. But instead of just showing you images, which you can do that on your own, then we're going to bring on my Kali Linux quickly here. If I can find my VMware workstation, I'll go ahead and sign in. Kali Linux, it's one of those distributions that is based on the Ubuntu. That's based on the Fedora distribution. Because a lot of the commands, if I'll bring up the terminal here quickly, and then let me just zoom in. A lot of the command, let's say I want to install something. I can say, hey, sudo meaning I want to become root. Sudo apt get install what application? Net dash tools. Let me install that, right? Then because I use a sudo, it's telling me, hey, well, type in your password. We're going to put that in there. So we're going to tell me this is already installed. And that's exactly what it did. Okay, the tool, it's already installed. It should be here somewhere. There we go. Net tools, manual installation. You already have the newest version of Net tools. You're like, okay, what does Net tools do? This is the one that allows me to basically do things like IF config, meaning try to see the config information of my computer. Okay, I'll be teaching you all these in a later module as well. But this is a Linux. This right here is Linux. Most people shy away from Linux. Again, it's because you might think there's a little bit of a memorizing these commands. Well, the thing is, once you've worked with these for a while, they become a secondary, right? It's just people tend to shy away from it because of that reason. Because for you to become really good or to be a power user of Linux, you have, to an extent, know how to type in these commands, right? Kind of the most common ones, because nobody ever knows all of these things. Anyway, I brought you here to show you the little interface of Kali. So this is Kali. It's a hacking distribution that is specifically designed for hackers, for the attackers, I don't know, the good guys who knows how to do bad things. Just put it that way. And it starts from gathering the information. So everything is organized based on what the attacker does. And the attacker does from gathering information for scanning vulnerabilities and doing things like web application analysis, database assessment, password attacking, and wireless. And as you can see, as I'm moving over these, you can see the tools on the right? They keep appearing. These are the tools that you will use. These are the tools that you will use. For example, you want to do like a vulnerability analysis, you can use something Nikto or Nmap with the Nmap scripting engine, the scripts, and so on and so forth. So that's Kali. I can also click on Home. I can use this as a GUI, right? GUI, it's a graphical user interface. So I can click on that and go to Desktop, and then it starts seeing the things that's within the desktop, right? I can right click here, create a folder. I can call this folder Cyber Pros. Okay, now we have a folder on Cyber Pros. I can double click inside of the Cyber Pros, right click on it, and kind of a create document. out of this, like empty documents. Let me just call that doc one. I press enter, and then now we have a document one. If I double click on that, it's going to open in OpenLeaf. These are the program. Oh, no, mouse pad. These are the program. Then I can start typing things. This is my first document, right? And I love it. There you go. So I can click on file, click on save, and then close that. Now I have a document, right? I can use it as a GUI, but most people don't do that. I would not encourage you to do that. You know, when people are just getting started with this, they're like, this is pretty good. I'm going to use it just like that. No, get comfortable with the command line because the command line gives Linux superpower. Okay, right here, we can go to the desktop, meaning change directory, CD to the desktop. I press enter. Now I'm in a desktop. I can ls here, and then I can find that Cyber Pro right there. I can CD into the Cyber Pro. There we go. And now, if I ls here, there's that document. If I cat document, there is the information that I tapped it in there. It's really not that hard. I can also just create another document. For example, I can say, hey, touch. I want to create another document that's known as a cyber.txt. There we go. Now, if I were to ls here, I do have like another text document here. Well, you're like, okay, what if you want to edit this? Well, I can use another command known as a nano, right? Nano cyber, and then I press enter. It takes me to this location where I can start editing things or edit things here. I can say things like this and put all caps. This is my second document and I am loving it. There we go. Like, there we go. Then I can do Control X to try to exit out of it. And then it's going to tell me, hey, hold on a minute. Do you want to save this before you go? I say, yes. So press Y and then press enter. And that's it. You're done. Now there's some information inside of that guy. So if I were to cat, let me make this lowercase again. If I were to cat Cyber Pros and press enter again, now, I say Cyber Pros, but cyber.txt. Now I have this inside of that. That's a little bit of Linux for you. So just knowing how to navigate around this. I have videos on the website, so go ahead and check out the Cyber Pros hands-on, the complete hands-on for Cyber Pros. The very first video, it's all about this, to try to get you up to speed with Linux. You gotta be comfortable with Linux, because if you're not, it's gonna get it really hard for you in IT or cybersecurity. All right, let's get back to the slides. So close that and let's get out of Google and let's get to this. Let me go ahead and make this a full screen so that we can see the entire thing. So we talked about Linux, different distributions that came out over the years. Like I said, even you yourself, you can create your own. It's all free. The desktop environment is, it really depends. It's different from a distribution into another distribution. Some of them, they use GNOME, which is like very popular, modern. That's the one that we were using with the Linux. KDE, it's another one. Xforce, it's another one. You can install these on top of your Linux once you finish installing it. So what are some of the common use of Linux? Again, a lot of the Linux, there are in the servers. There's not a whole lot of regular people using Linux. So Linux handles the backend. Right? When I say the backend, I'm talking about the internet runs on Linux. Google have thousands of millions of servers serving us those Google products. Like everything we use within Google, it's housed with the Linux. So very important. But this is the same one that is used in embedded systems. Those are the IoTs. It's the one that is used in the things like cloud computing or scientific computing. When you're developing things with security-focused products like firewalls and routers and switches, all of those things, they all relies on Linux. The next operating system that you should be aware of is mobile. Now, when it comes to mobile, we have things like Android. You're familiar with this, you probably have an Android phone or an iOS phone. So these are operating systems that manage the hardware. There's a small hardware that we carry in our pocket. So again, Android is out of Google. Actually, it was a company, a standalone company, but Google bought them. And when Google bought them, they say, you know what? Although we bought this company, we will keep it more of an open source, which means all the people or companies that create hardware, you can use Android. That's okay. We, as Google, are going to keep it free. We're going to maintain it, basically, updates it, deliver the features and all kinds of things. But other than that, we will keep it sort of like open source, kind of. But companies can get an Android version. They can customize it however they want, especially if they don't want it to come with some of the Google proprietary things that you will usually find in an Android device. Anyway, Apple have the iOS, and iOS has been around for a long time. It's the leader. It's the leader when it comes to mobile operating system, and it comes out of Apple. Right? There's really not a whole lot to say about this, but this is what you find in your iPhone and things like that. One of the most common way of people using a computer is through store files, right? File system basically adding things to the operating system like image or documents or all kind of things. So the operating system comes with a file system, and that file system allows the user to organize things and to store things. We're talking about images, files, music, videos, all kind of things. So the file system allows the user to control how data is stored and how the data is retrieved from the computer. The file that gets stored into the computer will come with a metadata. Metadata is the data that describes another data. In another word, if you upload a picture in your Windows, for example, if you upload a picture in your Windows computer, well, the metadata might mean what date did that image got created? What location was it? What time was it? So that's metadata. It's a data that describes other data. But for this to work, there must be, like I mentioned, a file system. So Windows comes with what we normally call NTFS. NTFS stands for Newer Technology File System. This is the default. It's the one that Microsoft use now. And that's what this is. Let me go ahead and bring it up so I can get to show it to you right here. That's, let me clear the screen. There we go. There we go. So that's what this is right here. So this is the file system. I can right click on here. I can point it to a new. I can create a new folder, a new one of these, right? For example, let me create a new folder. Let me just call this sample right there. I press enter. We have a sample folder. Then I can right click on this and then go to show more options. This is Windows 11. It's kind of, yeah, let's, stay with me. So I can then click on the properties of this. And then right here, I have a few things. I can see the size of the folder. I can share this with whoever I want. This was the permission that I was telling you earlier. When we were talking about you're able to share files and folders with people that you want, this is how you do it in Windows. I can also see the previous versions. I just created that one, so there's none over there, and I can customize some things here. So the beauty of NTFS, the Newer Technology File System, is that it allows Windows to use bigger storage, like bigger hard drive, right? So you can have like a hard drive that is like terabyte in storage, and it will still work with this. But the other thing, like I mentioned, it allows you to have the ACE, like the access control list, or ACL, it really depends on what you ask. So that's another thing that this file system allows us to do. Let's get out of there. Let's get back to this. So before NTFS, before this newer file system, Microsoft used to use FAT32, and there was also FAT16 at some point. There was an older version that's known as a FAT16. So the problem with this, you have like some kind of a maximum of like how big the hard drive have to be. So for example, this has to be like 4 gigabytes or 32 gigabytes, it really depends. So these are now sort of like used in USBs. like those USB that are like 16 gigabytes and 8 gigabytes, they're the ones that are using this kind of a file system. It does still works with the Windows NTFS file system, but again, that's old. It's no longer used in operating systems. Okay. Now, Mac have their own file system. It's known as a Apple File System or APFS. Now, this one, it's proprietary from Apple, and it's designed to optimize things like your solid state drive. It's really good. It does provide things like a full disk encryption for the most part. Um, so it's really good. It's the file system of Apple. I don't have on the Mac. I would have showed you that very quickly. And Linux does have EXT4 or the fourth extended file system. There's different versions of this. There's EX2, EX3, and so on and so forth. But this is the standard for many Linux distributions. It allows you to basically interact with that file system. So when you saw me going into the Kali, create a folder, and do all kind of things, this is the file system that I am using. So if you have a hardware, let's say like you have a storage hardware, like a USB, let's put it that way, USB, and you want that USB to work with this file system, for example, well, you have to format, that's the keyword, you have to format that USB with this file system. If you don't, it's not going to work. That's why every time you have like a USB, you plug that onto like a Mac computer and it's not working. You're like, oh, what's going on? Well, the reason is maybe that USB is using this file system, NTFS, or maybe FAT13 or FAT13, FAT16 or FAT32. Well, if it's using that, then it cannot work on a Mac. It cannot work on Linux. Those computers will not be able to read a storage media that have that kind of a file system. Continuing with this conversation of file systems and the storage management, we have a few things that you need to be aware of. The first one is MBR. MBR stands for Master Boot Record. Okay, Master Boot Record as it applies to storage and the file system. This was used with the BIOS. Right? If your computer supported the BIOS, BIOS, the basic input and output system, well, MBR was the kind of a disk partitioning mechanism that you had. Okay, this is legacy, old, and then your hard drive had to be like 2 TB or less. Okay, and then you were limited to just 4 partitions. For example, if you want to chunk your hard drive into smaller pieces using one of these kind of a storage utilities, these tools, well, the only thing you had to do was 4 disks. You were very limited to just 4 disks. So you can only have like 4 different drives on your computer. Then somebody smart said, you know what, we got to change that. So they came up with what is known as a guide partition table. I think that's what that stands for. You can look it up, like GPT. It's not Chat GPT. This is different, right? This is the guide partition table. There we go. This is a modem. And this is the one that used the UEFI, the Unified Extensible, I believe, Extensible Firmware Interface. There we go. UEFI, Unified Extensible Firmware Interface. I believe that's what that stands for. Anyway, so this is the newest. As you know, UEFI is the newest. And it does support larger drives, meaning you can literally partition hard drives that have terabyte and terabyte in storage, and you will be just fine. So as you're going in and you're managing your partitioning, you can do that using some tools. And these tools are part of the operating systems. We call those disk utilities. Windows comes with their own tools, and Mac comes with their own tools. Let me show you a few things very quickly here. So if I bring up this File Explorer and I go to this PC, you can see that these are the drivers that I have. I have the local disk, right, with this many gigabytes. I also have this backup disk, which I haven't really put anything in there. This is like an additional hard drive that I have. When I open this computer, I install that in there just in case. So I probably need to start using it. Part of the reason I don't use it, this is HHD, a hard disk drive, HDDs, excuse me. But I installed this, right? And this was the SSD. So it looks like I am running out of SSDs because it's faster. So I might just start moving things here as a storage purposes. Like that's why I named this backup. But I can go to disk utility, for example. Let me go here and bring up disk management. All right, that right there. Click on that. And that brings me this guy. There we go. This guy right here. Let me sort of like zoom in here for you. And right here, you can see that I have a couple of different disks. Disk 0, disk 1, disk 2, and disk 3. And disk 3 is the removable. This is just the flash drive that I have inserted into this computer. X10 Pro, this is another external. This is where I stored my things, and on and on and on. But right here, I can format the hard drive, meaning I can create multiple hard drive out of one hard drive. Let's go ahead and try that. So I can, for example, right click on the backup. There we go, that right there. I can right click on this backup and let's say I want to format this, meaning when you're formatting something, you're deleting everything from it. But you can also format it as a way of changing the file system. For example, I can change that from NTFS. Looks like it doesn't allow me to change that to anything else. But let's try something that's more external because this is old. Let's see, this one right here, X10 Pro. I'm not going to format anything, but if I click on format, there we go. We have the EXFAT as the file system. I can change that to NTFS. I can format that. And if this was an external, I can create different volumes, if you will. I mean, I add additional space or chunk this storage into different, kind of chunks, different pieces, if you will. But we're not going to do that. I just want to show you that the tool comes with the Windows, and you can use this to kind of play around with your disk. So let's get back to this. So you might say, okay, so why will people want to format their hard drive? Well, it could be for RAID. RAID is a redundancy array of independent disks, basically creating redundancy. We will talk about RAID in a later section, so I really won't talk about this, but we have RAID 0, RAID 1, RAID 5, RAID 10, and they forgot RAID 6. But they all, it's a way of kind of having multiple storage, like multiple hard drive, and then be able to use those, have one that's being used, another one as a backup, and so on and so forth. And that takes me to process and memory management. Well, this is all about controlling the program execution, right? We're going in, we're watching how the program is running. We're looking at the resources that program is using. So some of the components, including process creation and termination, right? The tool that allows us to do this can let us do this. Process scheduling, process prioritization, and so on and so forth. Some of the tools that we use to do these things, including Task Manager, which I'll go there in a second just to show you a few things. But you also have Activity Monitor from Mac. On Windows, we have Top and Edge Top. When you tap these into your Windows machine, it will give you like the statistics of how your memory is functioning, your processor, right? And things like that. So if we were to open up Task Manager quickly here, let me just search Task Manager from the search here, right there. And I bring this guy up. Let me go ahead and kind of zoom in here so you get to see this. They change it. It used to look old school. I liked the old school one. But anyway, this is Task Manager. It's dynamic. Things keep changing. But you have your processors, right? This is going in telling you, look, hey, this is your CPU here. Your CPU is operating at 60-some%. That's a central processing unit. Then you have your RAM, your random access memory, operating at 44%. Then then you have your disk, and then you have your network, right? So, and then it goes in, it's telling me the kind of applications that's using these resources. So you have this copycat and, CapCut, copycat, CapCut, I think that's what that is. Then you have your Google Chrome, which I am using. You have Microsoft Edge, and these are the CPUs. These are the memory, the RAM that's being used by each one of these applications. You also have programs that are running in the background. Now, these are dangerous, especially, people in cybersecurity. We want to be a little bit careful with the programs that runs in the background, runs automatically, without you knowing. Anyway, so I can click on performance, and then start seeing additional things. So I see how these things are performing. So if I click on the CPU, this is the CPU. This is how the CPU is performing right now. And the beauty of a CPU, I can also see the utilization, the speed, the process, the uptime, all that good stuff can be found here. Same thing with the memory. As soon as I click on the memory, it can show me all kind of things that I need to know about the memory. Same thing with the disk, and I have quite a few of those here. Okay. Same thing with the Ethernet for your network. If you want to know how your network is doing, you click on that, and it will tell you how things are running. Okay, including GPU. This is the graphics card. Okay, app history. It show you all the apps that you've run in the past. Which ones are those? Startup apps. This is where you get to see the programs that starts automatically as soon as you boot up your computer. Not good, not good. But if you have like a program that you want that program to keep running as soon as the computer boot up, you put that computer here. But you can also come here and disable that, right? Because if it's disabled, it's not gonna run automatically. The user is going to tell you who are the user of that computer that are currently using the resources. You also have details, which give you all kind of things, including the PID, the processor ID. And then I click on the service here. You also have the services, again, with the PID, process ID, the description, and if the service is running or if it has been stopped. This is all juicy information from Task Manager. And this helps us understand what is taking place within the computer. So if you, as a cybersecurity personnel, this is really good place to start. Whenever there's like a new program that is making your CPU work really, really hard, well, that's something that you should be concerned about. Let's talk about this user interface that you work with, that your operating system give you, so you can be able to manage the hardware. For example, on Windows, we have the start menu. Now you got start menu, you got the taskbar right here. You got the File Explorer right there. You got the desktop, and you got the icons here on the taskbar or on the desktop. You got the Action Center, which is that guy right here. That's where the actions are taking place. That's where you get your notifications from, all that good stuff. You also got the Settings app, which you can get to it by clicking on your name here, I believe. No, not there. You can get to it by, there's a lot of ways of getting to it. You can right click on that and go to systems or go to settings. There we go. Go to settings and it will take you there. I will go there quickly and show you a few things very quickly. But on your Mac, you also have your dock. The dock, it's that location that I was showing you earlier. You got the menu bar, you got the Finder, the mission control. That's where you can search things from. You got the Launchpad and so on and so forth. On Linux, you also have a desktop, and you have the loved or the most common things that people access. You can add the things there if you wanted to. So let me give you a quickly crash course of Windows, very, very quickly. So on Windows, the UI looks like what you're looking at right now. And here, the most things that we use, it's known as control panel. Let me just show you the control panel. So I'm going to search for control, and then get a control panel. Think of the control panel as the heart of your operating system. You can do a lot configuration from this location. They have changed a lot of this into the settings page. So if I click on settings, there's a lot of things that I can do here that normally I could only do it from the control panel. So they try to make it look neat and nice, like latest, right, with the newer icons. But let's go old school, right? So this is the control panel. What if you want to install a program? Well, you can just go right here to programs, install or uninstall programs. Just go to programs and features, and this is going to give you all the programs that are installed in your computer. So right now, let's say that I wanted to uninstall Anki, which is a pretty good example here to do this on. So I can right click on that, click on uninstall, okay, and then I click OK. Now it's going and it's basically removing this program from my computer. When it's done, I'm going to click on close, and now that program will disappear. Not all programs are going to do that. Some program might require you to reboot your computer before it disappears. But this is where you will remove programs that you don't want in your computer. So let's go back to control panel. Not only have it's a hardware and sound. When you click on hardware and sound, they're giving you all kinds of things, including the power options, the autoplay, the device, and printers. So if I click on the device and printers, now they're taking me back to that Windows settings, the newer one. And here I can do all kinds of things, including adding a device. What kind of device can I add? Well, I can add a printer. I can add a Bluetooth device, and so on and so forth. Let me go ahead and close that. Your power settings are really not that important. Then you have your systems and security. Right here, you have your Windows firewall. We call this Windows Defender. This is the most important thing that you will come here for. For example, you can click on that, then you can turn on or off your Windows firewall. If I click on that, I can check these options, sort of like turn my Windows firewall off and on. There's some situations where that kind of makes sense, but it really, most of the time, just leave that on. You got also backup and restore. You also got file history. You got storage spaces. You got BitLocker for things like encryption. And let me go back. You also have, what else? Network. I skipped network. Network and sharing center. This is where you will go when you want to change things like IP addresses. So I'm going to click on that and click on the change adapter settings. Right here, it allows me to pick the Wi-Fi. I click on that or right click on that and go to settings or go to properties. And right here, I can pick IP version 4. If you don't know what these are, I'll be teaching you these very quickly in this course. And right here, I can manually assign my IP addresses, right? Like that. Go ahead and close those. And let's go back here. And last thing I want to show you, it's, you can also change your appearance and all that stuff, but I just want to show you user right here. Yeah, right here, this is where you can create an additional user. Right now, this is the computer that I use, so I'm the only user. You can go right here and then change the user type or manage another user, which basically allows you to be able to add new user to this computer. So what are some of the tools that come basically pre-installed in your Windows? Well, we call these utilities. You got tools that help you manage your disk, such as disk management, the tool that I showed you. You have things like disk cleanup and defragmenter, right? On Mac, it's just called disk utility. And on Linux, they have, these other tools there. So you got tools that can help you do disk management. You got tools that can help you do some backup and recovery, performance monitoring, like things like Task Manager and the like. Performance Monitor, that's a very common on Windows. Networking tools, I will show you a few of these later on. Things like Wireshark, really not that, more like ipconfig, ifconfig on a Windows netstat or netash. These are all kind of help you manage your network utilities. On Linux, you have IP, and on Mac, it does work on the Mac as well, ifconfig at least. System information on Windows, you can go to Device Manager or System Info 32. That's actually the real name of it if you want to see additional information. And some security tools. Right? Again, there are some tools that comes with your operating system. The problem a lot of people have is before they use those tools, they try to buy the shiny ones. They try to buy new tools. So as someone who's coming into cybersecurity or into IT, that's one of those things that you will have to be mindful of. Use the built-in stuff first before you start looking for third-party applications. I'm going to just pause that there because I can talk about this for the next 1 hour. Other things that comes with your operating system, including productivity applications. Okay, these are software that are designed to do a specific thing. Yeah, see, same thing with those utilities, those tools that are installed on top of your Windows or your Mac or your Linux. So these are productivity software. So you have Office products like Office suites. Microsoft have these Microsoft Word as a part of their Microsoft Office suites. Google Workspace have the docs and sheets and slides and so on and so forth. LibreOffice, it's what's in Linux, and Mac have Pages, or Apple have Pages. So these are suites of productivity tools. You have things like a Microsoft Word processing, spreadsheets creation from both of these presentations software that are part of these suites as well. You also have communication software. You're like, yeah, I'm familiar with this. Yeah, you got email, absolutely. You got instant messages for real-time text communications, things like Slack or Discord or Microsoft Teams. That comes in mind. Now with email, you got Outlook, you got Gmail, all right, you got Thunderbird on Linux. That's what we call it. Apple Mail on a Mac. Right? You got video conferencing applications that can be installed on your computer, things like Zoom, Google Meet, WebEx, Microsoft Teams. You got collaboration platforms, like I said, Microsoft Teams, it's pretty good, and Slack, it's pretty good for collaborations, and Google Workspace. Social media, all communications tools, and obviously VoIP, voice over IP. You got applications like Skype and WhatsApp and Signal that allows you to call people over the internet. So these are communication software. Again, these are apps specifically designed to do a specific thing. In our case, it's for communication purposes. Then you have your media applications. For example, image editing, video editing applications. These are tools that are specialized in doing these kind of things. For example, Photoshop. They has to have, they gotta have Photoshop here somewhere. No, it's not. Lightroom is from Adobe as well, and it's the one that is specifically for images as well. But anyway, these tools or software, they're designed to edit your photos. You got some that helps you do things like audio. So Adobe have some tools that does that, and Apple have also some tools that does a little bit of that. But video editing, definitely from Adobe. All right, we got things like Premiere Pro, Final Cut from Apple, and this other one. Video players, 3D rendering, game engines. I can go on and on and on. These are media applications that are used for multimedia purposes. Then you have a specialized software that are designed to do a specific thing. For example, CAD software, computer aided design, specifically, designed for architecture, right? Precious drawing and modeling, right? Technical specifications, industry-specific tools, example, AutoCAD. Yeah, from Autodesk. I think that's the name of the company. That's a really common CAD software. You got some for finance, got some for education, things like learning management systems. I've worked with these, a lot of them, Moodle, Canvas, and Blackboard. I've worked with a lot of these over the years since, I was teaching. We got some for scientific research. You got healthcare. You got geographical information systems, software that helps you kind of a map, the map and things like that. Look, these are specialized for a specific purpose, and a lot of apps, a lot of applications are specialized applications. How do you install applications? Well, it's pretty easy, really. So one of the most common way of installing applications, it's from going to the web. Right, you go through the web and then you download what we normally call an executable file. It's usually known as a .exe. Okay, the exe. So once you have this file in your computer, then you double click on it. You double click on it, and then the whole installation process kicks in. So they will set up like that. You will have that setup process, the wizard. There we go, wizard process, where you go in, you get into the whole process of installing that particular program. Well, what you need to do though is verify the vendor. Don't be just downloading things and installing things, because viruses, malicious software, does attach themselves to executables because they want you, the user, to do something. When you double click on this file, you might be thinking that you are installing a program, but in reality, you are installing a virus. Got to be careful there. But in the old days, we used to install things through DVDs, and then it changed to USBs. So now you can, just have a program in the USBs, and then you double click on it and off you go. But for the most part, you just download the installer, the executable, and then you go from there. You can also do this from a network installation. This is assuming this is like a company. So everything is connected to that company. Maybe you have like an Active Directory, AD directory running, and then you have computers connected to that Active Directory. Well, if that's the case, system administrator can literally install things to the network. They can either remote into it, like I mentioned in the older videos, we have things like RDP, Remote Desktop Protocol, that can allow you to remote into any computer, Windows computer, and then be able to install things in this case, okay? You can also install applications from the App Store, specifically on your iOS and your Android. You can just go to App Store, Google Play, I think that's what they call it, and then install things that way. You also have things like virtualization and containerizations that you can install things inside of them. If you don't know what these are, that's okay. We will be talking about these in more depth in a later module. Now, when you're installing things, you might run into problems. So here's some installation troubleshooting things you need to be aware of. Where some of the common installation issues, including not having enough space. This is actually the most common one, right? Not having enough space, the program is going to start yelling at you, telling you, hey, there's not enough storage for me to install, right? You might also have inadequate permissions. Oh, yeah. If you don't have enough permissions, you can forget it. There's nothing that's going to install. The reason is computers, you can only change, when you're installing things in a computer, you're changing the settings of the computer. The only way you're able to change the settings of the computer is if you are the administrator, admin. If you're the admin on the Windows. Now on Linux, you just need to type in sudo. Sudo, it's when you want temporary administration. Okay? Where you say, hey, allow me to be the administrator for the next 15 minutes. Well, guess what? Linux will ask you for your password as well. Anyway, so common issues, it's make sure you have the enough permission. Another one, it's incompatible system. Or the way you fix that is by looking at the requirement of the tool you're trying to install and see if it's designed to install in your computer. You'd be surprised the amount of people that will install a tool that is designed to run on a Windows 32-bit version of Windows, and to like a 64-bit version of Windows. All right. Now, here's the thing. If you're on a 32-bit on a 64-bit, it will work. So this probably wasn't a good example, but it cannot be vice versa. So if this tool is designed to run on a 64-bit, and then your operating system only supports 32-bit, these are like the architecture of your operating system, well, then it's not going to work because it's designed to run on a 64, not 32. But in the case of 32 and 64, it will work. Corrupted installation media, that's another reason. Conflict software, failed dependencies. Yes, some applications depend on other things to install. So that could be the problem. So how do you apply this? Well, you got to check the requirements. Like I said, you got to check out the software developer, see if you're installing the tool in the right version of Windows, for example. Okay, verify the installation media, run as the administrator, disable any antivirus. Yep. I had to do that a lot of time. Like disable that firewall for something to work. Yeah. So you gotta, maybe you want to clean boot and check the installation logs if you really kind of get stuck. When you're installing things, you need to make sure you have the right permission. Absolutely. I'll tell you one story. There's a company I used to work for, and we had people, employees, that were doing what we normally call shadow IT. Shadow IT. Well, you're like, well, what is shadow IT? Well, shadow IT is when, not show, shadow IT. Shadow IT, it's when regular people install software and start using them without consulting IT, without consulting the IT people. So the company I was working for, we had those people who said IT runs slow. IT can get me my thing on time. Therefore, I'm going to just go online, download the program, and then start using it. And they sure did. Guess what? This company was Adobe. I'll tell you what it was. And the program was Acrobat, right, for PDF. So they installed that, they started using it, they kept using it, and it got up to 8 people. 8 people were doing that. So this one time, Adobe knocked on the door, like, "Hey, what are you doing using this tool without licenses and things?" You're like, "Who's using the tool?" You are. The we don't know. So anyway, what ended up happening, Adobe forgive us, obviously, because we were, running some other software of theirs. All right. So, but that was one of those things that they reminded us that licensing is very important. And when you download a tool, the license says it doesn't belong to you; it belongs to the creator of the tool. So you're just supposed to use it, not abuse it, not do anything like that. So again, make sure you get the license before you start using some tools. Okay. So licensing types, you got the one-time purchase license, you got the subscription, you got the free, you got the freemium, you got the trial. All of these did kind of different licenses. And when it comes to models, you got single, multi, like a whole site for all the users, the enterprise for the entire org. And you got OEM. This is the pre-installed with the hardware in your Windows. Well, OEM, it's where we get it with Windows. Windows belongs to Microsoft, but when you buy a Dell computer, it comes pre-installed with Windows. How is that exactly? Well, that's because Windows come as OEM, right? Then you have your open source. Open source are free software, right? They don't belong to anybody. Anybody can, use them without really any without really paying any money. They're free. It's under this public, general public license out of MIT, kind of a pioneer this. So for example, Apache, it's a web server. Apache, it's a web server that is free. Anybody can use it. Okay. Now, when it comes to license management, well, it really depends. If you get the one-time purchase type of a license, well, just make sure you keep an eye on it, pretty much. So there are different systems that you can use to, for example, track your inventory. That's our list of what we used to do. But before that, we were using Excel. Oh yeah, we're using Excel, and then it will say computer that belongs to Shanika here. It's running Windows 10, and this is the version of that Windows 10, and these are the software that's installed in that computer, and these software are activated with the right license. Again, it really depends on what you're trying to do here, but most of the time it's more of just keep an eye on the license, making sure you don't lose them, and when you buy them, be sure to use them. Obviously, software are gonna get old, or the vendors are going to get out of business. So you got to keep your software up to date. Most companies don't. This is why there's a study that came out that said that home computers are more secure than company computer. Literally. You're like, what? Yeah, the first time I heard about this, I got surprised too. But the reason is home computers receives updates automatically. Right? These patch, they come automatically. But business computer, on the other hand, well, for the most part, the patch, the updates are turned off. I mean, for a good reason too, because you don't want to be getting these automatic updates. Because as a business, you might have a proprietary software that might not like the newer updates, right? So most of the time, as a business, you want to make sure you taste that update before you apply that update. But anyway, you updating your thing, it's all about keeping it up to date. It could be for security reasons, it could be for a feature, it could be for fixing a bug, it could be for like additional service capabilities, it could be just a regular drive updates, it could be a firmware updates. But look, updates are updates, right? These are designed to make your software better, more secure, more functionality, fixing of vulnerabilities, you name it, updates are extremely important. So what happens when you install a tool and it doesn't work, or you install an update and it doesn't work? Well, you can remove software. I think I did show you where you do that from Windows. Yes, I did. So you can remove software from Windows. There are some utility that comes with your Windows and Mac and Linux that allows you to be able to remove your Windows. I mean, no, your software that you install or the updates that you're trying to perform. Here's the thing. Try to avoid manually removing anything. Part of the reason is because there's a lot of dependency. There's not a single software that functions on its own. Some of these software, they call out on other things. We call those DLL. DLL, Dynamic Link Library, which is really part of the Microsoft operating system. Well, if they're calling on a few other things, well, then if you're going to remove them, completely remove them then, right? Uninstall them completely. Don't just like manually drag that into the trash can and then think it's gone. No, it's not. Windows command prompt. Windows comes with a command prompt. Now, because you're in this class, you're not a regular user, right? You're not that person who's just gonna click on the Windows logo, open the browser, and that's about it. No, no, no. You're gonna do more. And part of that is knowing what a command prompt is. Command prompt is what we call a CMD. CMD is command prompt. So this is something you probably have seen this in the movies. Like just a black screen that look, yeah, like that looks like that. Let me go ahead and zoom in. There we go. And right here, just like what you would do in Linux, you just need to know what to type. So right now I can list things. I can do ls, and ls is going to tell, I don't recognize ls, and that's true. That's because ls is a Linux command. But if I do dir for directory, then it will go in and show me some stuff. So right now I can see pretty much everything that is in the location right there. I can see documents, pictures, and downloads, and kind of so on and so forth. But we use this for all kind of things. For example, let's say I want to check for my IP configuration. I can actually type in CLS for clear. I don't know why Microsoft named that CLS, but that's literally for clearing things. Weird. In Microsoft, in Windows, you just type in clear. Not Windows. In Linux, you just type in clear and then you clear your screen. But with Microsoft, it's a CLS. Weird, but that's really, classic Microsoft. So I can say IF config. IF is not going to work because this is not Linux. So I can type in IP config, and that will allow me to check my IP configuration information. Okay, right there. It would tell me, hey, look, your Wi-Fi, which happened to be that guy, this is the IP address of your Wi-Fi, and that's the subnet mask, and that's the default gateway. Lovely. What if I want to see if my computer is up and running? I can ping it. I can say ping 172. Actually, I'm just ping Google. Ping Google.com. I ping the beauty of Windows when you're using the command prompt, it's going to ping 4 times and then stop. But right now, it's telling me, hey, Google is up. How do I know? Well, we're getting reply from Google. We're getting reply from this IP address, which belongs to Google. Well, you're like, oh, hold on a minute, first of all, well, how do I know that's Google? Well, you can literally copy this Let me see if that's gonna work. You can literally copy that and paste that in Google, in the browser and try to see if you get to Google. But you know what? Let me try that. Let me get out of here. I'm gonna open that doesn't look good. Let me open this guy. Let me see. There we go. This is you won't see any Google, so hopefully we'll get to it. All right, let's put that number in. One. Let me see if I was able to copy it. Yes, I was. Okay. So paste that in there. Same thing. 142.250, which is that .9.101. I press enter, and it's supposed to take me to Google. So let's continue to this site. There we go. There we go. It will route us to Google. Google. That's the IP address, right? That's how we know that Google is responding. Really, no, that's not how we know it. We just trust what it's giving us. We don't have to keep going and check on Google. We just trust that and look at it right here. It's going to tell us, hey, packet sends are 4. Packets that were received is 3. Packet that were lost is 1. Well, this right here, the timeout. But that tells us Google is communicating back with us. So this is the command prompt. Let me see some of the command that they want us to run. So I'll be able to tell you the accurate information. So, okay, there we go. We have a few commands right here that work. We have things like dir for listing directory content, cd for changing directory, make directory for creating a directory, copying and moving and deleting and getting help, right? All that stuff will work on Windows. And the way you access a command prompt is by searching that in Windows, just like what I showed you earlier, right here, by typing that in there. You can also just right click on this icon right there, and then you will get to command prompt right there that way. Command prompt should be here somewhere. There we go, right there. It says terminal. But it's like this will give me not the command prompt, but what we normally call a PowerShell. Yeah. I'll get to it. But just some of the commands that I can run. Again, I can change directory. I can move up to directory. If you have issues with this, again, take some of the other courses that we have on the platform. But that's the command prompt. So people that are no more than a regular user, they use command prompt for all kind of things, for managing networks, for managing the file system, just for navigating the environment and all kinds of stuff. Another tool that makes you look like you're a super user, it's known as a PowerShell. PowerShell is just like command prompt, but more. So I can go back to the search menu here, and I can type in PowerShell. And then I can I bring up this PowerShell right there. Now it used to look like all blue, but now they changed this, so I can zoom in. It does look like the command prompt, but it's different. PowerShell is different than command prompt. PowerShell will allow you, it's right there, it says PS PowerShell. It will allow you to run some of the Linux commands. Absolutely. So early I did ls and it wasn't working. Check out this here. I do ls, it's gonna work just fine. So PowerShell is more like a cross-platform. It will allow you to do a lot of cool stuff. And this is what the attackers, the bad guys also use PowerShell to do all kinds of things. So what we used to do, one of the companies to work for, we used to monitor PowerShell activity. Because regular users don't just come right here and start doing things like IF config, for example. Actually, I should type in IP config. Because not all the command works. And by the way, not all the Linux command like this one will work. So there's some specific Windows commands and a few like Linux commands that works. But you can do IP config again. I can do ping. I can trace route. .com. I can trace route is not gonna work because it's a Linux, so I can do trace rt.com, for example, and now that's gonna work. So This is a PowerShell. PowerShell gives you superpower. So the company I was working for, we monitor PowerShell activity because we knew regular users are now going to be using this. For what reason? Right? So what we used to do was if PowerShell is executed, meaning is running, we want to know it. And then we want to know what is being run on PowerShell. Because the bad guys likes to get on PowerShell and start running all kind of things. We're talking about hacking the crap out of you. This is the tool they use, especially if you allow them to run this as the administrator. Oh my God. Big trouble if you allow them to run this as the administrator. All right, so this is more of a modern command line shell and scripting engine. I should probably mention that, the scripting language, because you can do some PowerShell scripting using a specific syntax of PowerShell. So there's some object-oriented, right? It's not just text. There is that. It does also integrate with a .NET. That makes sense because both of these, PowerShell and .NET, are Microsoft products. It's way more powerful than command prompt. Like I said, it's cross-platform. Now, as far as the language that you use in PowerShell, it uses what we normally call the CMDlets. CMDlets are they're like verbs. It's kind of really easy where you can say, "Hey, give me the process," and then list all the process. Hey, get service, then you get the service. Get child item, then you get that. So that's really the kind of we call those a CMDlets, right? But these are like verb specific design in PowerShell. And last but not least, we have the Linux terminal. And we're not going to go there because I have showed you a bunch of this already. So in the terminal, you can bring up the Linux terminal. And right there, you can run a bunch of things. You can run commands like copying things, moving things, removing things, and making directories and touching files and so on and so forth. So this is the shell. This is the superpower, right? It allows you to run bash. Bash is what you do when you're typing, copying things, removing things. You run that on a bash. Bash stands for Born Again Shell. Ugh. Yeah, this is the most common. All, probably should say all because there's some that run ZSH, ZSH. But like majority of Linux shell, they run on bash. That's why I said if you type in ifconfig in one Linux, it's going to work in another. Ifconfig is not a good example because ifconfig is going away. They're replacing that with IP. I'm throwing a lot of information at you. But anyway, you can do things like ls, change directory, print working directory, find things, locate things, right? You can look at the system information with the uname, with the top, with the df or disk space usage with free and so on and so forth. So this is Linux. My recommendation to you will be if you take security serious or IT serious or networking serious, any career of IT, get familiar with Linux and get familiar with Windows. Good morning if you are watching this in the morning, and good afternoon if you're watching this afternoon. Well, I'm glad you're joining me back again here on module number 4, which talks about networking fundamentals. Now, this is going to be the core networking concept, right? We won't dig, deeper into any of the topics, but we will share the enough information that you need to know. So you can make like a decision if networking engineering or kind of a networking, it's going to be your career in IT. So this module kind of continue on domain 2.0 of that exam objective, which is again back to that 24% of the overall exam. Okay, let's get to it. Learning objective. Now, in this module, we are going to start the conversation by looking at the different network types and the topology. If you're going to design a network or you're going to work in computer networking, this is, like I said, core foundation that you need to know. You need to know the kind of networks that we have out there and the kind of topology once, they put these networks together. How does that look like? But before we even talk about that, we will take a step back a little bit and talk about, when two computers are communicating, how does that look like? What kind of a communication is it taking place? Okay. Then you can really talk about networking without talking about IP addresses. So we will explain the IP addressing concepts back to the IP version 4 and IP version 6. Then maybe I'll share with you why we don't have IP version 5. It's usually a joke, but there was IP version 5. It just never got pushed into the public, right? It stayed into the research space. Okay, but it's going to be the core foundation of the Internet Protocol, which is what IP stands for, and the addressing system that they use. In this case, IPv4, IPv6, why IPv4 it's important and why we still use it today. All that's going to be discussed in that section. And then we will compare various internet connections and technologies and services. So we will get into the protocols and ports and things like the OSI model and TCP/IP. Again, the core foundation. We won't dig deeper into any one of them, but I will tell you what you need to know so that you can see if networking is the right path for you. But also, the other thing that you need to know is that networking knowledge, it's essential. But it doesn't matter. It doesn't matter what you specialize in terms of IT or cybersecurity, you still need to know networking knowledge. So we'll finalize this by taking a look at the troubleshooting networking. Again, won't spend too much time there, but we'll take a look at the things that you can do if you're troubleshooting a network. First thing first, client server and peer-to-peer models. How do this whole networking works? Well, we have this model that's known as a client to server model, which basically means we have two things taking place. We have a client, we also have a server. And you can basically guess what these are. A server, it's a device. It's something that is designed to serve. It basically have resources, and it's going to serve those resources. Now, a client, on the other hand, it's something that is designed to request, request those things that are being served by the server. So a dedicated server provides resources and services, while the client, on the other hand, request those or consume those resources and services. This is the model of the internet. Every time you use the internet, this is exactly what is taking place. I remember when I started learning about the internet, I used to think it was magic, right? You just went to YouTube, you go to www.youtube.com and you start watching a movie. It's like this movie, it's always there. Not to realize that that movie is stored into another computer somewhere, right? In this case, since it's YouTube, in Google's data center, right? In some kind of a server, some kind of a computer that is housed in that server, designed to serve that movie or that video in the case of YouTube. So that's really what the client and server model is. We got two things involved, and this is what the internet is built on top of, right? Everything you consume on the internet is housed in somebody else's computer. When I say somebody else's computer, I'm talking about somebody else's data center or servers. Okay, so we have things like web servers, file servers, email servers, you name it, right? You go to the web, you request a web page, there's a server that is serving you that web page, right? You send a file, you access a file on the internet. Well, there is a file server, right? That is kind of sending you that file. It's not magic. Don't be like me when I got started thinking it was all magic, right? No, it's just a bunch of servers. We're talking about millions and millions of them around the world and billions of clients, meaning people, like we have a client devices like your phone, your laptop, your tablets, right? And all these things are used to access or request those things that are housed in servers. Now, what are some of the characteristics that comes in mind when you are doing a client server model? Well, There is the clear role separation. Absolutely. Like I said, we have a client, then we have a server. We know which one is a client. We know which one is a server. For example, when we're talking about like a web, Google Chrome is a client, right? And something like Apache is a web server. This is like a Linux web server application that is used pretty much everywhere, right? Like most of the web server or most of the websites that you pull up on the web, they're housed either in Apache or something like Nginx. All these are like a web servers that works on Linux environment. But Microsoft also has something that's known as IIS, which I can't even remember what it stands for. I think it's the Internet something something. Anyway, the IIS, it's just for Microsoft. So when you install something like a web operating system, like a server operating system from Microsoft, you can add IIS as one of the functions, basically turning the Microsoft server into a web server. And then you will have things like a Google Chrome, Microsoft Edge, Firefox, and there's a lot of them out there. These will be the client that's accessing the web server as well. Okay, so there's that clear role separation. We know what the client does, we know what the server does, and it's centralized because the server it's managed by some kind of a company, and that company makes the rules. Therefore, it gets a little bit easier to back it up. There is also it's a little bit better when it comes to security because we know what it is, we can secure it better and all that good stuff. Okay, it does requires dedicated server hardware. Like when you're running server functions can't run on client machines because the servers most of the time they're not designed to be shut down, right? They're designed to just keep running, all the time. So the hardware for the servers are more like a dedicated, specifically designed to, be used in servers. There's a higher implementation cost, absolutely, because like we say, you got to have a data center and you got to have all these servers in the data centers. You got to network them and make sure they're working, all that good stuff. Right now, we live in the age of AI. Right. If you were to ask me this a few years ago, like, oh, can you specialize in servers and networking and things like that? I'll probably start telling you that I don't think so, because a lot of companies have migrated into the cloud and all that kind of things. By the way, we'll talk about the cloud in the next module. But in the age of AI, we've seen a lot of investments coming into data centers. Absolutely. So now they're spinning up those NVIDIA GPUs. They're like connecting them and doing all kinds of things. So data center jobs, which is like networking types of jobs of where you're networking these hardware, it's really in demand. I think companies like OpenAI and these other companies, they're now sort of like scrambling to find engineers, to find people who can actually maintain the servers or connect the things within the servers. I say the servers, but the data centers, which happen to have those servers inside. Another model that comes in mind is peer-to-peer. Peer-to-peer is different than a client server because with a peer-to-peer, all the devices that are involved in this conversation, they can both act as a client, but also as a server at the same time. Okay, so we can have like two devices communicating. Well, each one of these devices can serve things, and each one of these devices can request things. So resources are distributed across the network. There's no centralized location. There's really nobody in charge. Now, this it's really cool. It gives you like the freedom because if you're worried, oh, my data, it's housed in Google data centers and Google it's selling all my data. Well, peer-to-peer network fixes that. Okay, so peer-to-peer is used in things like file sharing. Absolutely, that comes in mind. Some collaboration tools use, peer-to-peer technology. And one thing that's very common uh, that kind of, that comes to mind is Bitcoin. Oh yeah, Bitcoin as the application, you can call it the money Bitcoin. There we go. So that's a peer-to-peer. It works on peer-to-peer, right? It doesn't belong to anybody. It's in everybody's computer, and it can be used you can request it and you can serve it, right? So that's like a peer-to-peer model. Basically, peer-to-peer gives back power to the people. Okay. So what kind of a networks can you set up? Well, you can set up a LAN, local area network, a WAN, a wide area network, and there are some other types of networks that you need to be aware of. So let's start with the LAN, which was the very first one that got invented back in the 70s when they were working at inventing a lot of this stuff. So LAN, this is a local area network. It's very limited in a geographical area. In other words, this is the network you have in your house. This is the network they have in small businesses, in buildings, in maybe um, small schools, right? They might have these networks in there as well. So it does have a high data transfer rate. The reason is you're connecting everything with the wire. It could be a wireless WAN. I want to just also mention that, but still, everything it's close within each other. It's in the same building, so you can connect everything via wire, something like RJ45 or Ethernet cable, or fiber optic cables. Really depends on the kind of a connection that you're going with. But again, you find this in home office, in home networks, as you said, office networks, and sometimes in school networks. Although depending on how big the campus is, you might also have like a campus area network. That's literally another one that's used in a lot of these universities, especially if they have a bunch of buildings close to each other. In fact, I have that right here. I will get to it in a little bit. Okay, but this is a local area network. It's the type of a network where you have a switch and then you connect everything to it. If you don't know what a switch is, I will get to it in this module. So local area network is great, but this is just limited to that building, to that environment. What happens when you want to go outside of your network? What happens when you want to go outside of your house? Then you need the help of a wide. Then you got to go wide, I should say, right? So that's where the wide area network comes in. So a wide area network, it's a network that spans a large geographical area. In another word, this is the one that goes around the world, literally globally. The thing that comes in mind, it's internet. Yeah, internet is an example of a wide area network. There are all other wide area network like MPLS, I should say MPLS. So don't ask me what that stands for. I can't think of that out top of my head, but you can look it up. But something. But so there are a few, but the internet is the most common ones that we use, the common one that we use when it comes to a wide area network. So every time you trying to access something, so we just finished talking about a client and a web server kind of relationship. Well, what happened in my network right now? I want to access google.com. Well, I don't have anybody called google.com in my local area network. In my LAN, I don't have anybody named google.com, or that's known as to be google.com. Well, that means I need to go outside of my LAN. And that's where the internet comes in. So I will go to a device on my network. That device is known as a router. I'll teach you what that is. Router. So I'll go to a router and then I'll tell the router, hey, Mr. Router, I want to get to google.com, but nobody here is named google.com. Can you please go on the web somewhere, find google.com and bring google.com to me? Right? And the routers are like, yes, sir, right? Go to the internet, find google.com and bring google.com back to me. So wide area network, it's a wide, right? It spans cities, countries, globally in the case of internet. Okay, it's typically slower than a LAN. The reason is because now you're getting into the megabytes, per second as type of a speed. I mean, imagine if you're connecting to you are reaching out to google.com. Maybe Google have their data centers in California, right? I am in Atlanta. So my request have to travel through the wire all the way from my house to California, grab what I'm looking for out of Google data centers, and to bring that back to me. So you can see that's slow that way as well. So company often leases these telephone lines to kind of set up their own wide area network. So they can go to a provider, something like Verizon in the US, in America, or something like AT&T. Maybe you have your own provider, your ISP in your own home country. I don't know where you're watching this from, but the company can go to them and be like, hey, I need this dedicated line. It just belong to me, right? The ISP, the Verizons, they'll be like, yes, sir, we will get you that. But then they will charge them a lot of money. They will charge them a lot of money if they just want to, that dedicated line just for them. So most of the companies now, we just use the internet, right? That's really what most companies do. Just use the internet. And if they want to kind of create like a dedicated line, they just use VPN, virtual private network, to create a tunnel, right? To create a tunnel, a secure tunnel that goes through the internet, right? That's kind of the connection that the majority of the company uses these days. Then you have your metropolitan. Metropolitan, it's like a smaller brother of a WAN. So it's larger than a LAN, obviously, but it's smaller than a WAN, a wide area network. This is the network connection that spans of a city. Yeah, of a city. For example, the city of Atlanta, right? If they have like their own network that they spin up within all their buildings and all the offices and all kinds of things that's within the city, well, if all those things can talk to each other, it could be in the metropolitan. It could be part of the main metropolitan area network. Okay. This is often used by, municipal governments or large organizations where they have like a huge presence. For example, in Atlanta, we have Delta, it's huge here. We also have Home Depot, huge here. So they could set something like this up. Okay. But also, the seat of Atlanta could set something like a MAN, a metropolitan area network. It's bigger than a LAN because a LAN is just in the small buildings, but it's smaller than a WAN because a WAN can be as huge as the entire global. Okay. With MAN, I want to also just skip to campus because they're kind of used sometimes interchangeable, right? Some people might refer to a MAN as, the CAN. So a campus area network connects multiple LANs, just like how a MAN does it, just like how WAN does it. WAN is just literally a bunch of LANs, kind of just connected to each other around the world. I should probably have mentioned that earlier. But anyway, connects multiple LANs across limited geographical area. Now, keyword here, it's limited. So this typically spans multiple buildings. It's highly used in university campus. That's why it's called campus. Okay. Can the university use something like a metropolitan? I don't know. I mean, if they've taken over the entire city, I guess so. But you'll find a CAN in things like business parks, a hospital complex, where they have multiple buildings, like a university. Think about Harvard University, Stanford, where they have like multiple buildings, and those buildings are like close to each other, like in the same campus, if you will. Therefore, they might spin this one up because a LAN will be a little bit smaller for them. Okay, so they might set up multiple LANs and then connect them to each other and form what we normally call a campus area network. Another one we have, it's a PAN, personal area network. Now, personal area network, it's personal. It's a very small network for personal devices. You're like, what kind of devices? Well, we're talking about those Bluetooth devices. If you connect your headphones to your computer, well, in reality, you are forming what we normally call a personal area network. If you connect your NFC, NFC, it's the near field communication. When you do things like Apple Pay and things like that, well, you are in reality forming what we don't call a PAN. This is a personal area network. When you're connecting your mouse, your keyboards, if they're wireless, or it could be wire, if you connect them to your device, with that short distance, well, that's a PAN, personal area network. So example of that is Bluetooth connections between phones and headphones, smartwatches and phones. Are these things, when you connected them to each other, they're forming what we normally call a PAN, personal area network. Last but not least, it's the SAN, the storage area network. it's in the name, storage. So this is where a company set up some kind of a storage that can be accessed by the business or the people that works for the company. It's a specialized high-speed network for storage purposes. So what happens is a company can set up like another person or in another location, they can set up like a building, and there they're just going to add a bunch of storages like hard drives. And those storages can be accessed. They can be accessed using technology such as the fiber channel or iSCSI. This is why they said it's a high speed, because accessing this storage, it's very, very fast as well. But it's like a separate network, if you will. That's why we have this here, right? It doesn't get talked about as much, but it is part of these kind of a networks if a company does this. These days, companies are moving into the cloud, or they've been moving into the cloud. So you will literally see a company that set up their own SAN, unless they're like a huge company and they really want to kind of keep their data, house their data, and control where that data is stored. Because the thing is, when you move into the cloud, right, it's like, okay, where is my data? Is it in the California data centers of AWS or Microsoft Azure or Google? Is it in their data center in South Africa? Although we have laws and rules now that tells these cloud provider you should not store these kind of data in outside of the US, right? Things like that. If they're storing like medical data and things like that, we have rules now that kind of govern them. But this is really common in the data centers and enterprise environments where they set up their own SAN, storage area network, and they just connected these with things like Fiber Channel to kind of let people be able to access the storage. What are some of the typologies that comes in mind? Network typologies. Well, the first one is a bus. A bus typology, it's like a line. It's like a bus line. So this is all the devices are connected on a single backbone cable. Absolutely. So that's really what a bus typology is. You have a line and this is connected to it right there. There's another device here. There's another device here. So that's a bus typology. Well, it's very simple to set up as far as implementation goes, but it's very limited when it comes to scalability. And here's the problem with this. It got a single point of a failure. In another word, if this cable gets cut, for example, well, that means the connection is gone. Right? These devices can't talk to each other anymore. Okay, but that's a bus typology. Another one we have, it's a ring. A ring is here somewhere. Yeah. And another one we have, it's a star typology. Now, a star typology, it's the one that is very common. This is the one that we commonly used in today's environments right now. Because with the star typology, you have a centralized device. It's known as a switch or a hub. If we're going back, 20 years back, they used to use a hub. A hub is a device that looks like a switch, but the problem with a hub is not intelligent. It's dumb. In other words, when it receives content, it distributes that to everybody. That's what a hub does. So you got a hub, you got all these things connected to it. This is that star. It does literally look like a star because you can connect a bunch of devices to it. These are computers. Okay. So a switch can help us create a star typology, but also a hub can. But the difference, which is what I'm trying to tell you right now, is that a hub is dumb because every time it receives a conversation, it's going to distribute that to everybody, even the computers that did not request that conversation. A switch, on the other hand, it's a smart. It does have like a little CAM table. I'll teach you what that is. CAM table that keep track of all the what we call MAC addresses, media access control. I'm sure I've talked about this. If I haven't, I will. MAC addresses, so that as soon as it receives a conversation, it will look at the CAM table and be like, okay, this particular device with this MAC address is the one that requested this conversation, and then be able to send that to that particular device and nothing other devices. So back to the point of a star typology. A star typology, all the devices are connected to a centralized hub or a switch, is the most common typology in today's lands right? It's easy to set up because you can literally remove and add the devices as you wish. And if one of the computer decides to stop working, or if the wire decides to not work, well, that does not affect any other ones. They can still talk to each other. They can still be connected to the network. The problem is the centralized device, the switch. So you still have that single point of a failure, because if that switch dies, then everything stops working. That's the problem. And then you have your ring topology. Your ring topology, it's like a ring. It's a circle, and everything is connected in that circle, something like this, right? It's usually used to be, it's used in what we normally call a token ring. So each device connects to exact two or other devices. It forms a closed loop, just like what you're looking at here right now. The data travels in one direction or both direction. It really depends. But here's the problem. This is old. It's not used anymore because a failure of one device, oh my good, can kind of affect the entire network. As you can see, the whole thing is going. If this wire gets cut, then we have a bigger problem. Bigger problems. So it was used in what we normally call a token ring, very old kind of a network designs. I don't think it's used it anymore, right? So a ring topology, again, it's a circle. Everything it's a circle. All the devices are connected in the circle. And then you have your mesh topology. Mesh. This is when devices connects to multiple other devices. So you have a partial mesh. You also have a full mesh. This is when like literally every device connects to every other devices. Now partial, I'm probably not saying that right, with the accent and everything kicking in. But this right here, it's when some devices connects to multiple other devices. So it looks like this. You have maybe a device here, another device here, another device here, another device here, and now they got to communicate with each other. So this talk to that. There we go. Let me go ahead and delete this one so I can give you a better design. There we go. So this talk to that guy, and this talk to that guy, and this also talk to that guy, and this talk to this guy, and this talk to this guy, and this talk to this guy, and that tells that. So it's like everything. Yeah, probably. There we go. Connect that guy to that guy. There we go. So everything is talking to each other. So a full mesh, it's when all of them are like there's like a connection, like a wire that's direct connected to it. And a partial mesh, it's when there's some wires that's not connected to it. Maybe this is connected to two, and this other one is connected to two, and on and on. So why would they do this? Well, it's for redundancy purposes. For example, if this wire gets cut, right, this can talk to this guy. Well, what end up happening is if this trying to get to that guy, there's more wires, so it can go around, it can come right here and just connect it to it. So there's all kinds of ways that it will be able to get to it. And it's very complex as far as setting this up, and it's commonly used in backbone of the networks. And then you have the hybrid typology. This is the combination of two or more typologies. So for example, you are working with a bus, a star, a ring at the same time. That will be a hybrid typology. Okay, it's commonly used in large networks. So again, like I said, the star bus typology. If you are using both of them together, it will form what we don't call a hybrid. Okay. And then you have your tree and hierarchical typology. Just like a hybrid, this is where you use more than one, specifically a bus and a star typologies. This is becoming a little bit common now, where you see large networks set up something like a bus as the backbone, right? And then they connected that through the star to kind of form that line and then a star, right? And another line, and then another star, right? Something like that. Okay, so that's the tree hierarchical typology that you will find in some enterprise networks. As you're creating these typologies, you got to connect these devices that you're connecting to this network. Now, let me go ahead and show you a few things because I like to be showing you stuff. So if we go here and let's go to Google, and then search for. Let me actually show you a lot of these things that we just finished talking about. So I can start with the star topology. Let me go to images quickly here so I can show you how this looks like. You have an idea of the design. This is where you have that switch and then you have all the devices connected to it. So this is a star. This is the most common. This is the one that we use. And like I say, you could have a hub, right? Which is I need to show you a difference between a hub and a switch so you can kind of see them. But a hub is just like a switch, but you're connecting all the devices to it as well. And then let me show you a hub. Right? This is like a hub, right? It's just like a switch. The problem with the hub is that conversations get sent to everybody, similar to what this little illustration here is doing. Now, the problem with the hub, like I said, it's that if computer here didn't request that, then you are wasting bandwidth. You are wasting resources. Try to send the thing to that computer that it didn't request it in the first place. So hubs are old, and I don't think they're used nowadays. All right, so let me show you a switch. This is a switch. I like that, the Nintendo Switch. This is a switch, something like this. You usually have like a 49 ports, and then you connect your computer here to form that star topology that we are talking about. These are the Juniper switches. You got Cisco switches as well, but switches, they look like this. They're smart. You even have like smart switches that not only deal with all the things that the switch does, but also do a little bit of what the router does. We call this a smart switch. I will teach you that once we get to the OSI model. Then you have, what did we say? We have a bus topology. That right there. So this is where you have the line, and then everything is connected from the line. You also have a mesh topology. Like I was, drawing there for you. This is where you have everybody communicating with everybody. In the case of a full mesh, or you can also have like a partial mesh where not everybody's connected with everybody, but there's like a connection. So like this is like a partial mesh, and this is like a full mesh where everything is connecting with everything. Okay, let me see what else did I had here. You also have a hybrid. We talked about a ring. There we go. Let me show you a ring. There we go. This is the ring topology. This is all of them. So this is the ring right there, right? So this is the star. This is the partial mesh. This is the bus, and this is the full mesh topology, right? You got the idea. Now let's talk about these devices, these connections, I should say, right? So we have twisted pair cables. So we have two types of cables. Probably it shouldn't say two types, but because we have all kind of ones. But you do have a copper cables. You also have a fiber cables, and these are used to connect networks. Now, fibers are extremely fast, and twisted pair cables are also faster, but it will depend on the type or the kind that you got. For example, let me actually zoom in here quickly, talk about this, then I'll show you some pictures to drive these points home. So you could have something like a Cat 5e, which goes up to 1 GB, and this it goes up to 100 meters, right, with just 1 gig. Cat 6 give you up to 10 gig. Cat 6a again 10 gig. But once you get to Cat 7 and 8, you get higher speeds, like higher speeds. Now there's two types of these copper cables. There's the unshielded twisted pair, and then there's a shielded twisted pair. They're like, whoa, which one would you use and which one would you use where? Well, unshielded twisted pair, this is the one you find in a lot of home networks. Okay, home networks, they use unshielded twisted pair. The reason is it's cheaper. The problem with unshielded twisted pair cables is that there are acceptable to EMI. EMI is the electromagnetic interferences. Okay. So to solve that problem, you got STP. These are the shielded twisted pair cables. Again, same brand. These are all still the RJ45, the registered jack 45. I'll show you that on Google in a minute. And is the most commonly used in local area networks, like I said. So shielded twisted pair cables, these are used in places like data centers. And the reason is because they have there's a little shield around the cable itself to protect it from, like I said, EMI, electromagnetic interferences that comes from other kind of connected devices. Okay, so you got that there. You also have a coax cables. These are used to connect to TVs and things like that. Uh, like I mentioned, you also have fiber optic cables. These are extremely fast. They use a light signals, different than the twisted pair cables or copper cables, because copper cables uses electricity, to do the connection as far as the speed goes. So they have these light signals that travel through glass or plastic fibers, and it's not really good for the eye. At least that's what the books, tend to say. But these are very fast, and they're used in backbone networks. So the cable that goes from the US all the way to Europe, it's probably fiber optic cable, because you got things like single mode fiber optic cables that can travel for long distances, and the speed can go up to a 400 or more, 400 gigabytes per second. Yeah, that's like a billion, like 400, this speed is insane. It's insane. But you also have a multi-mode or multi-mode. This is a shorter when it comes to, distance and things. And this is the one that you'll find in most backbone networks. It's still fast. You can, get up to fairly like 100 gigabytes per second as far as the speed goes. Um, and it's used in the backbone of kind of a networks, and you have some of these guru people that will have this as well in their their networks as well. You also have cable standards, things like we usually just used to call this TA and TB, right? The wiring standards for twisted pair cables. You got straight through cables. These are used for the SAM, kind of a SAM standards, like SAM devices. Then you have your crossover cables, different standards on each end. In other words, when you're going in and you're doing the twisting, we used to create cables, when I got started in this, when I was working for the schools. Yeah, if a cable breaks, we cut it. We had the tools to and kind of fix it. And like we had to know which end takes what, depending on the kind of a hardware that we're trying to connect. But you also have a wireless that doesn't, use cables, and you got 2.4 gigahertz, 5 gigahertz, and these days you also have a 6 gigahertz. So let's go to Google. Let me show you a few things. One, let me go back here, make sure that I see it. So let me show you the RJ445. RJ45. The RJ445, this is the Ethernet cable. This is that twisted pair cable that we're talking about, the one that uses the TA and TB standard, if you will. Okay, so this is the cable. It's known as an Ethernet cable. Ethernet cable, and they all look alike when it comes to the categories. So no matter if you're getting Cat 3, Cat 5, Cat 6, Cat 7, and 8, it all looks like this. The biggest difference is the speed. That's the kind of the difference between them. So they look like this. It's known as a RJ45 because it registered jack 45, because when you take them apart, the pins that connected to it, it's like 45 of them. Okay, so there is that. Let me see if I forgot anything here. No. Okay, so the other one I want to show you is fiber optic. Just show a picture here. There we go. Fiber optic cable. right? It looks like this. Depends on the kind of a connection that you're getting. They have different connections, like we saw. They have STLC and so on and so forth. So that's like beyond this class. Take the network plus to kind of dig a little bit deeper into those. But this is how it looks like. It's completely different. They're usually smaller in terms of the size, but they're extremely fast. Extremely fast. The speed of light travel through them, and they're used as the backbone of the internet. So if I were to show you the internet global wire, let me bring that up. So this is how the internet is connected, for example, like this. So you got wires that's going everywhere. When I got started, I used to think it was magic, like I mentioned. Um, until I learned that it's just a bunch of wire that they managed to connect it all around the globe, right? So you got wires that goes from the U.S. to Europe, and from there Africa, and South America, and so on and so forth. So these wires, they travel the ocean, and you name it, right? Something like this. So this will have those fiber optic cables, specifically the single mode ones, because they travel through with the long distance, and they are extremely fast. All right, so let me get back to this, and let's talk about a few other things. Now, another thing we want to talk about is routers and switches. I can just go back and show you this, but before I do that, let's talk about them quickly. So routers. Routers are devices. These are hardware, okay? These are hardware that you will find on your network. Early, I was telling you that routers, you will earlier, I was telling you that routers are used on your network to be able to allow you to get outside of your network. So this is a hardware, a device that connects different networks together. That's it. It allows you to connect different LAN, local area network, together. So basically, the routers are the reason why we have the internet. Without routers, we will not have internet. Because every time you're trying to get outside of your network, you're trying to get outside of your LAN, you try to get to somebody else's LAN, right? You try to get it to Google's LAN that they happen to have in a data center. Well, you will need help from a router. So router is going to make forwarding decisions based on what we normally call IP addresses. I'll teach you what that is in a minute. But also routers have the routing table. Basically, it's just like a little database of known routers, other routers that it can kind of talk to. You have a Wi-Fi routers, like these are the ones you use at home or Wi-Fi routers. But Cisco and Juniper's and other companies, they also have enterprise routers, and these are used by businesses as well. So there are a lot of things we can do in the router. For example, router, we can create a NAT. I will teach you what this is, but this is a network address translation used to translate IP addresses from what we normally call a public IP to private IP. If you get like a home router, it can be doing some DHCP services. If you don't know what DHCP is, I'll teach you what that is. But this is really a way of assigning IP addresses to computers. So I'll teach you what that is. We can do like traffic filtering with things like LCA. Uh, no, not LCA. Access control list, ACL. There we go. Why did I have that backward? That's interesting. Access control list, right? Where we filter to the traffic, a little bit of security. We filter to traffic based on different things. It could be through IP addresses. Mostly it's through IP addresses. Okay. Then you have your quality of service. In the router, you can go in and say, hey, router, I want you to prioritize this traffic over this other traffic, right? So like, traffic prioritization, and that's really what QoS is, quality of service. The router do packet forwarding, absolutely. Router do pick the best path or the best other device to, send the conversation to based on what it has or what it know from that routing table. There you go. Again, this was a lot that I'm throwing at you, especially at Tech Plus. I really don't think you need to know all of this. But just remember, a router is a layer 3 device. I'll teach you this in a minute. But a router is a hardware that allows you to get outside of your network. Every time you want to access something that's outside of your network, when I say your network, I'm talking about your LAN, then you need a help from a router. A switch, on the other hand, is the one that we use to create LANs, a local area network. So here this is a data link layer. I'll teach you what this is in a minute. But it's a device that connects devices within the same network, basically within the same LAN, local area network. So you have a device, you connect a bunch of things to it. We're talking about computers. Now these computers can talk to each other. Yeah, literally, like they can talk to each other fast too. Because once you connect that with the, let's say, RJ45 cable, now they can travel out to 10 gigabits per second, right? Depending on the cable that you connected to it. So it's extremely fast. But they do all the conversations based on the MAC address. MAC address is a media access control. This is the number that is unique, and it's assigned to every computer by its creator, by the manufacturer. I will show you an example of that on Google in just a little bit. So we have two different types of switches. We have unmanaged switches. We also have managed switches. Unmanaged are the ones you have at home, right? These are like, I don't want to say dumb switches, but these are switches that are just configured to do, basic stuff, and that you can't really do anything else. Whatever they're configured to do, it's what they're gonna do, and that's it. Managed switch, these are like the enterprise switches. And these, they have the OS. They have a switch operating system that you can work with to do all kind of things, to change MAC addresses, to, there we go, here's some functionality, to do things like MAC filtering, to go in and create VLANs, virtual local area network, right? And to, prevent loop by turning on what we normally call the spanning tree protocol. Again, if this is a lot, which I think it is, you got to take the Network Plus class, okay, which we have that on the platform. So, let me go on the Google. Let me show you a few of these. So if we go here, let's start with the router. This is a router, especially the ones you have at home. It looks something like, not that, like this, right? Like this is like your home router. It's going to act as your access point, giving you Wi-Fi connections. But also on the back of it, it's probably going to have like 4 ports. There we go, something like this. 4 ports where you can maybe connect it to the computer using like a cable. So your router, in this case, it's acting as a few things. One, it's your home router. We usually call these SOHO, small office, home office routers. And the reason is because, one, it's acting as a router, meaning it allows you to get outside of your network. Second, it's acting as a switch, meaning it's connecting all your home devices together, allows them to talk to each other. Your TV, your phone, your computers, they're all connected to it, either via Wi-Fi, or maybe you can connect those via a wire. And then third, it's acting as an access point. Access point, it's like a Wi-Fi device, okay? It's not only allowing you to connect it to it via wire, but it also allowing you to connect it to it via radio frequency. Radio frequency, those radio waves, right? You can communicate using air instead of using wire. So these are a home router. You also have these Cisco routers. They're not Cisco routers, but literally they have different brands out there. But these are like enterprise routers, something like this. Enterprise routers that are designed to be used for businesses purposes. They also have an operating system inside of them. These are like a specialized OS designed for routing things. So you can configure routing protocols. You can do all kind of things inside of these things. right? This is where you can create your access control list inside of that guy. This is where you can do things like QoS, right? Quality of service, you name it, all of it can be done inside of this type of a router. I had already shown you a switch, but let me bring it back up. Not a router, a switch. Okay. And this is a switch. Like I mentioned, this is an example of a switch. Inside of this switch, that's where you will configure a bunch of stuff. When I say a bunch of stuff, I'm talking about VLAN, virtual local area network, and the spanning tree protocol. There's a lot of things that you can do here. You can do MAC filtering. One thing that I said I was going to show you was a MAC address. MAC address. MAC address, you'll find them on a NIC card. NIC card are network interface card. These are NIC cards. This is what you're looking at here. So you can basically buy this and connect that to your computer. So this thing, this NIC card, usually computers comes with this. If you have a laptop, it's already inside. If you have like a desktop, definitely already inside. So on top of this NIC card, it's going to have this media access control. It's also known as a physical address because it's physically attached to the NIC card. This cannot be changed. It's usually burned in by the manufacturer of that particular computer. So this is the MAC address. Every computer have this. They have MAC address. So what the switch does, the switch is going to learn what this is, so that when you're communicating, the switch will remember which computer is trying to communicate, so that it knows specifically which computer to send the information to. Modems and access points. Well, modem stands for modulator and demodulator. Its job is to convert things. So it converts digital signals from computers to analog signals for transmission. Okay, like, I think I'm following you. Yeah, absolutely. Every network must have a modem attached to it. And the reason is modem kind of connects to the ISP. It connects to your internet service provider for these conversion purposes, because you might be kind of giving your internet different traffic. For example, you might be calling people. Well, that's more like a telephone type of a conversation. You might be streaming videos. That's a different conversation. You might be doing all kinds of things. So modem, its job is to convert. So the primarily function of a modem is signal conversion. It's converting from a digital ones and zeros to analog ones and zeros and the like. So we have a cable modems that connect to cable TVs. You have a DSL modems, right, that connects to the telephone lines, and then you have your fiber optic modem that obviously connects to the fiber optic networks. Again, the job is to convert the signals. For example, if we are getting like cable conversations, but that needs to be transferred to fiber optic type of a conversation, the modem is the one that goes in and do that kind of job for us. Okay, so this is often combined with the router functionality in home devices. For example, if you have like a router from AT&T or Verizon, again in America, well, these devices, they're going to be functioning as a modem. As they function as all the other things I mentioned, they're also going to go in and do the modulator and the demodulator type of stuff. And then, like I said, you have your access point. Access points provide a wireless network connectivity. This is where you say, you know what, I don't want to connect it via cable. I want to connect via wireless. Well, maybe you're in a place where, you can run a wire. That's where you need a wireless for. So this is where you want to connect it to the internet via radio wave, radio frequency, instead of a connection using wires. So here's some of the functions of an access point, including wireless signal broadcasting. Absolutely. Before you can start connecting using a wireless, you have to connect it to the access point, and the AP, the access point, which is the hardware device that is broadcasting these radio frequencies. So the client, your phone, your laptop has to connect it to that signal that have been broadcasted. Usually, the thing that's broadcasted is known as SSID. SSID. This is the service said identifier. Basically, it's a fancy way of saying a Wi-Fi name. Wi-Fi name. There we go. So a Wi-Fi name. So before you can connect to that Wi-Fi, you have to know the name. So the client authenticate, and when the authentication is taking place, it's probably using something like WPA2 or maybe WPA3. This is for security. WPA is the Wi-Fi protected access. This is the protocol we use to secure Wi-Fi connection. Okay, so you could have, for example, in the business settings, you could have multiple access points, kind of a broadcasting, maybe the same SSID, maybe different SSIDs. It really doesn't matter. Again, when I said SSIDs, we're talking about Wi-Fi name. And then you have a roaming support, especially if you connected, via things like LTE, or 4G, which is all wireless, right? 4G and 5G, this is all wireless conversation. Now, for security, like I said, they used to have WEP. WEP is the Wi-Fi equivalent in privacy, very old, not secure. And then they said, we're going to come up with a new one. They came up with the WPA, the Wi-Fi protected access, wireless protected access. I believe that's what that stands for. So the first version wasn't, it was better, right? It got some security, but the algorithm that they use TKIP with RC4. These algorithms, they were weak. So they said, you know what? WPA is pretty good, but the algorithm is weak. Therefore, let's go ahead and change this. So in version 2, the WPA2, the current version, they swipe these with something that we normally call AES, the Advanced Encryption Standard. So that's why we've been using. AES is super secure. It's really not going anywhere. Then you have your WPA3. This is the newest, came out in 2018. And it has a lot of great features, a lot of great things with it. There are some standards that you need to be aware of. There is 802.A, there's 802.B, 802.G. Now, before A, there was 802.11B. This is the one that came out first, this guy. And the speed was 11 megabytes per second. And then it was using the 2.4 gigahertz range. Then some geniuses said, you know what, we got to advance. And they came up with the W802.11A, which was using 5 gigahertz range, which was faster, but people really didn't adapt this. And part of the reason was because the 5 gigahertz range wasn't supported in a lot of Wi-Fi devices, like those access points, the access points that we're talking about. They wasn't really supporting that yet. Then they came up with the I keep saying W, W stuck in my mind, but 802.11G. This was around for a while. The reason is they went back to the 2.4 gigahertz range, and it was supporting 54 megabytes per second. The thing about 2.4 gigahertz range, 2.4, it's better in terms of the distance, like how far can you connect to your Wi-Fi. So you can be like couple, feet. You can be far away and still be, getting Wi-Fi signals. So that was pretty good. And then they came up with the 802.11n, which was pretty good. And this one supported both 802.2.4 gigahertz range, but also the 5 gigahertz range. And the speed, poof, went to 600 megabytes per second. And they called that Wi-Fi 4. And then there was Wi-Fi 5. They start, because nobody really remembers. This is 802.11 this, 802.11 this. Marketing said, you know what, we got to do better. So they start calling this Wi-Fi 4, Wi-Fi 5, and now we have Wi-Fi 6, which is the 802.11ac for Wi-Fi 5, and then 802.11ax for Wi-Fi 6. And what got better, it's the speed. Right? As far as the range, the frequency, we still uses the 2.4, the 5 gigahertz, and the 2.4 and 5. And recently, with the Wi-Fi 6, they also introduced the a 6 gigahertz range, which is very fast. Firewalls and security devices. Well, when somebody's talking about security, or they're mentioning about network security or cyber security, the first hardware that comes in mind is a firewall. Why? Well, because this is that device that is designed to monitor and controls that traffic, the incoming traffic and the outgoing traffic. The firewall is that device that sits between your network and the internet, and then it be controlling what's coming in and what's going out. So there are different types of firewalls. The first one is the packet filtering firewall. This was the very first version of firewalls. We're talking about back in the 90s when they were coming up with these firewalls. This was the very first one. This just did some basic traffic filtering, meaning you go into the firewall, you create what we normally call the firewall rules. Let's say firewall rules, right? Also known as ACL, access control list. Literally inside of a firewall, you can create access control list. But once you set these up, these are very basic rules that goes in and says, from this IP address going to this IP address, block or allow or deny or something like that. Usually firewalls, they just do that. So these were the very first version of the firewalls. Now, here's the problem with these. Well, what happens if somebody shows up, maybe they're from the outside, right? They're from the internet. They show up and the rule, it says allow, right? What if I just show up right now and I'm using port 80? I will teach you what these are if you don't know what that is. Port 80 is HTTP. This is the web traffic. So what if I show up and I am new, I am coming from the internet, never seen me before on this network. Then I show up, I says, hey, I'm coming in and I'm using port 80, where if the firewall have a rule, the packet filtering firewall have a rule that allows port 80 to come in, well, that's going to be allowed. Even though nobody invited me from the outside, from the internet, I will be allowed in. That's where the stateful inspection firewall comes in. This firewall, it's going to track the connection, right? In another word, the people from the inside, I say the people, but the computers from the inside are going to make a request on the outside. Now, the firewall is going to keep track of that conversation. It's not a stateful inspection. It's going to kind of track the connection that comes from the inside. So whenever a traffic comes in from the inside, from the outside, the firewall is going to remember that. It's going to be like, oh, yeah, somebody requested you. This is more of like a returning traffic. Therefore, go ahead and go back in there. So stateful inspections firewalls are like the second version of the firewalls, and they're really good. Then they have like a application layer firewall. These are like they do deep packet inspection. They go in, they look at the application. For example, with HTTP traffic, they're not only stopping the traffic based on the port or based on the protocol. No, they're going in, they're stopping the traffic based on the actual content that is within the traffic itself, that is really within the application itself. So for example, with HTTP traffic, they will open the HTTP conversation. They will look inside and see what's exactly inside of that, conversation, and then perform the blocking or allowing based on that. So it's going to inspect the application data. And then the industry said, you know what, we can't keep coming up with different versions. So they designed a next generation firewalls to combine the multiple security functions in one. So this one, it does all the packet filtering, it does all the stateful inspections, the application, it's application aware. It does provides a deep packet inspection and so on and so forth. So what are some of the function of a firewalls? Again, packet filtering by those rules, or maybe being like a stateful as well. You can also do some network address translation in the firewall, although this is more of like a routing function, really. You can also log activities, absolutely. You can also do some kind of intrusion prevention within the firewall. Again, it's designed to stop traffic that's coming in or going out. You also have things like IDS. IDS and IPS, these are designed, these are also hardware. They can also be software. Firewalls can also be a software that you install on top of like a server or something. But IDS, intrusion and detection system, it's designed to monitor the network. Okay, what is the monitoring for? Suspicious activities. So keep an eye on the network, watching the network and see how things are kind of behaving and then reporting it. So IDS is going to detect and then let you know, send you an alert. Right? Detect, send an alert. IPS, on the other hand, is going to detect, but also is going to block the threat. It's going to stop the threat. It's prevention. There's a intrusion prevention system. Okay. Then you have another tool that's known as a unified threat management. A unified threat management is just like a next generation's firewalls because it does have a lot of the security features in one tool. It's unified. So it's like all-in-one security appliance that has a lot of the security inside of it. Okay. One that is very common and it's open source. By the way, I'll be coming back to all these once we talk about the security section of this class. And search for something like OPN Sense. OPN Sense. It's open source, it's free firewall and like UTM type of a hardware. You can also download this and install it, virtually in your environment. But this thing can be acting as a firewall, as a multi-WAN, as a VPN networking. It can be watching your network as an intrusion prevention systems. It can be used as a hardware failover. And there's, can see more features there as well. But basically, it's one appliance, a unified threat management. It's one hardware, one appliance that can also be a software that can be acting as a firewall, that can be acting as an antivirus program, a content filtering. Basically, it's all the security things kind of put it into one hardware. This is really good for small businesses, but when you're like a big companies, this is not good, right? Because you have that single point of a failure and you can't have all the security things happening in one device, right? It's not good for speed, but also for single point of failure where if this UTM dies, basically all your security die with it, okay? So with that, let's keep going. Now let's talk about something that's going to make a lot of this make sense, right? And that's the OSI model. OSI stands for the Open System Interconnection. Okay, it's a model that was developed back in the days. We're talking about the 70s to kind of sort of understand how computers talk to each other. So just finish talking about the hardware that we use, routers and switches and firewalls. And each one of these devices are designed to do different things. The switches connecting computers together, routers connecting networks together, and firewalls to keep everything secure. But it really gets hard when someone is communicating with another person or a computer communicating with another computer. And then you try to understand, okay, what is taking place between these two things that are communicating? Well, that's where the USI model comes in. Well, the USI model, it's a model, it's a theoretical model, it is theory that is designed to help us understand what takes place as two computers are communicating. So there is a seven layers of this model from a physical layer all the way to the application layer. Physical layer happens to be layer number one. Now, this is where you have your physical hardware. This is where you find your electrical, your wires, your RJ45, your hubs. Hubs are here, right? Your hubs devices. All these things are at the physical layer of the OSI mod. Then you go to layer two. Layer two is what we normally call a data link layer. This is very important, but I won't spend too much time on this because, again, the security, well, the network plus class, that's where we talk about this in more depth. But anyway, layer two is the data link layer. At the data link layer, this is where you're dealing with things like MAC addresses. MAC addresses. This is where you have your switch. There we go. Your switch. There we go. Your switch hardware, it's right here. Your media access control, it's right here. Right? Physical addressing and media access. That's at the data link layer. When you hear somebody says, "Oh, layer two," they're literally talking about things like MAC addresses and switches as well. You also have layer 3. This is the network layer, layer 3. So the network layer, this is where you will find things like IP addresses. I'll teach you what IP addresses are in a minute. And this is where you will find things like routers. Routers, as far as hardware goes. So routers are at the layer 3 of the OSI model. This is a logical addressing and routing. Again, you're trying to find a particular device on the web where you use IP addresses. Every device on the network has to be assigned an IP address. So think about an IP address as your physical home address, where everybody must be assigned one if you're going to expect, people to deliver things to you. And that takes me to layer number 4. Layer 4 is the transport layer. This is where the end-to-end connection comes in. This is the transport, right? This right here. And as far as the transport goes, we have two things that do the transport. One is what we normally call a TCP, the transmission control protocol. And the second thing that does the transport for us is known as a UDP, the User Datagram Protocol. Okay, the Transmission Control Protocol and the User Datagram Protocol. Both of these are designed to help us transport stuff. Now, there's a lot to it, but I won't get to it. Again, that's what the Network Plus is really all about. Then that takes me to layer number 5. This is the one that deals with the sessions. So it involves establishing a session, managing a session. So when two devices are going to communicate, layer 5 is responsible to kind of establish that end-to-end session. For example, if you were going to do like a video conference or calling each other, well, layer 5 is the one that's going to establish that session for us. Then you have your layer number 6. This is the presentation layer. This is when the data gets translated, right? It gets translated back from like a computer, ones and zeros, all the way to something that a human can read and understand. That's layer 6. Layer 6, it's also responsible for encryption and decryption. It's also responsible for encoding and decoding of the data, right? That's layer number 6. Now, layer number 7 is the application layer. Application layer, this is the application. This is with the thing that the user interact with. So for example, if you're sending an email, the application layer will going to be Gmail. So Gmail will be that application that you deal with. Another thing that I should mention is this. Actually, there's a few things I need to mention here. One is that this is theory, right? This is not practical. The OSI is theory, and it's used for the most part for troubleshooting purposes. When you are experiencing, let's say, a network issue, you can say, hey, I'm having a layer 3 problem. Now, what that means is that either you're not connecting to the internet, and then you're having some kind of IP problem, or your router is giving you trouble. So you will kind of encounter network engineers or people who works in this industry that's going to use these things kind of interchangeably, where they said, oh, we're having a layer 2 problem, we're having a layer 1 problem. What you need to understand is that whenever they say a layer 2 problem, they're talking about a switch problem, a MAC addresses type of problems. In layer 1 problem, they're talking about electricity and wires are not connecting, and maybe the wire got disconnected, that kind of stuff. Okay. So another thing that I wanted to mention was that because this is a theory, what they said, specifically the DoD, the Department of Defense, when they wanted to deploy this, because they really, come up with this, they decided to design the TCP/IP. So the TCP/IP model, it's another model that is practical. So if you're going to do this in practicality, this is the model that you will use. TCP/IP model, not the OSI. The OSI is more for educational purposes. Try to understand what takes place in whatever layer. And the TCP/IP model it's more of a practical. Now, what they did, they took all the 7 layers, then they condensed those into 4 different layers. So they took layer 1 and layer 2, they call that a link layer, and they combined both of those. It kind of makes sense because the devices that are here, like computers that are like physical here, they also use MAC addresses. So it kind of makes sense for you to combine a data link and the physical layer into one. So they call that a link layer, right? And then they went on and they combined, actually the layer 3 stayed layer 3. This is the internet layer. That's that network. It kind of makes sense because, again, at the network layer, we're dealing with IP addresses. So that's layer 3. And layer 4 stayed the same as well. That's the transport layer. They didn't even change the name. That's how critical this layer is. You have a lot of things taking place on layer 4. So layer 4 is still called the transport layer on the TCP/IP model. And then what I wanted to mention earlier was that layer number 5, 6, and 7, they basically condense that into one, and they call that the application layer. And this makes sense. The reason is a lot of what happens in layer 6 and layer 5, it's done by the application itself. So for example, if I'm using Zoom to call you, well, Zoom is the one that's going to establish the session. Zoom is the one that's going to do some encryption and decryption and decoding and encoding, and that's going to present the data and making sure that I can hear you okay. And the Zoom is the application that we're using. So it kind of makes sense to condense all of that into the application layer. Besides, it's really hard to tell what happens in layer 6 and layer 5. Especially layer 5. Layer 6 is better, but layer 5, it gets really hard to kind of know exactly what the layer 5 does. So glad that TCP/IP went in and said, you know what, we're going to break all these 7 layers into 4 different layers. Then we will go from application layer to transport layer to internet layer to link layer. Now, you're like, okay, Francois, I got that. How do I remember this? Because this is a lot of information. So the industry kind of have 2 ways of remembering the OSI. One way it's by this saying that goes like, please, starting with the bottom going up, starting with the physical, please do not throw sausage pizza away with A at the end. There we go. 1, 2, 3, 4, 5, 6, 7. Right. Please do not throw sausage pizza away. Again, please, please, in the voice of my daughter, please, 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 please do not throw sausage pizza away. Okay, that's how you remember this. Another way is by going from the top to the bottom. And that is A with all people seem to need data processing. There we go. There we go. All people seem to need data processing. All people seem to need data processing. And please, please do not throw sausage pizza away. Okay, let me just say one more thing, then we're going to move on because there's a lot to unpack here. The process of a computer A sending a message to computer B, that process is known as encapsulation. Encapsulation. This is when the computing and the layers and things that are involved, they're adding a data to it. So for example, the data gets into the physical layer. Well, we call that a bits. Actually, these are known as PDUs, a protocol data units. I think that's what that stands for. So these are known as PDUs. And this is involved in the process of encapsulation, meaning adding things to the data as it goes from layer 1 all the way to layer 7, or de-encapsulation, removing things to the traffic, the data as it goes from 7 back to 1. So when the data is at the physical layer, it's known as a bits. When it gets to layer 2, it's known as a frames. When it gets to layer 3, it's known as a packets. When it gets to layer 4, it's known as segments. And when it gets to layer 5, 6, and 7, we just call this data. So people just call this data. Or you will hear people just mentioning this as a packet, right? Nobody goes in and be like, hey, we're looking at the frames, or we're looking at the bits, right? Unless, you know, these are like super technical people, which I'll tell you, do not party with those people, right? Don't party with those people. Anyway, so that's how we call the data as it's going from layer 1 all the way to layer 7. Again, a lot to talk about here. It's all going to be in the Network Plus class. So I mentioned that on layer 4 of the OSI model, the layer 4, we have two things. We have the TCP, the Transmission Control Protocol, and we have the UDP, the User Datagram Protocol. So think about these two as the bus, like the bus, like the one that provides the transportation, okay? But the difference between the two is what you need to understand for this exam and all the other exams. The difference is TCP, the Transmission and Control Protocol, is reliable. So this is a connection-oriented protocol that is reliable, meaning when you're sending something from point A to point B, TCP is going to make sure that gets there. There is a reliability, there is a guaranteed delivery. Okay, it will make sure that your packet, your data reaches its final destination. Okay, you're like, oh, I got you. How does it do that? Well, TCP does that using what we normally call a three-way handshake. I'm going to mention here, I think it's behind this class, but I'm just going to mention here. It does that using what we normally call a three-way handshake. Okay, what is that? Well, three-way handshake, it's how like two computers establish a communication. And what happens is computer A trying to communicate with computer B is going to send what we normally call a SYN packet, CYN. It stands for synchronization. It's going to reach out to computer B and be like, hey, computer B, can we talk? Computer B have to respond. Okay, and then it will send what we normally call a SYN, basically saying the same thing that computer A said, and then it's going to acknowledge it. This is known as ACK, or acknowledgement. Okay, so computer B is going to send a SYN and a SYNACK, SYNACK, and then a computer A is going to confirm that. So it's going to send a final ACK, basically acknowledging it. Hey, yeah, we can start communicating. So that's the three-way handshake. This is how it's reliable. This is how we make sure that the conversation reaches the other computer. Now, your question might be, okay, well, what happens if computer B doesn't respond back? Well, computer A is not going to send anything as far as data goes. It's just going to keep asking with the SYN message, hey, can we talk? Can we talk? Can we talk? Can we talk? Until computer B responds back and says, yeah, sure, we can talk. And then computer A confirms that, like, yeah, let's start talking with the final acknowledgement. Now, UDP, on the other hand, it doesn't do that. Okay, so UDP does not do that at all. UDP is a connectionless. There's no guaranteed delivery. So what ended up happening with the UDP, it's fast, right? It's fast. It's going to send the things very quickly, but there's no reliability. So if you're there, you're listening, you're not listening, it doesn't really care. Okay. Therefore, it does have the lower overhead compared to TCP because TCP is used on things like emails, right? Web browsing, that kind of stuff. And the UDP will be really, really good for things like but it's really, really good for things like voice over IP when you're calling people using the internet, for DNS, for things like video streaming, music streaming, all that stuff really uses a UDP. The reason is you want speed. When you're streaming a music, you want that to be coming to you as fast as possible. When you're in when this is an email, it doesn't matter if it takes a few seconds to get to you. Most people are not sitting around waiting for the email to pop up, right? Anyway, so these are the two. Each one of these have 65,535. Literally 535 protocols behind it. So this has a 65,000. This has a 65,000. Absolutely. So these are like doors that we can use when we are, transporting using TCP or UDP. These are like the little doors that you can go through. And those doors are what you are looking at here, at least some of it. For example, you have a HTTP. HTTP is a protocol that happens to be using a TCP for the transmission, for transmitting things from point A to point B. But HTTP is web, and the web happens to be on port 80. So each protocol must have a port number, right? Because remember, computers only speaks binary. When you say HTTP, computer have no idea what you meant. But you put that into port 80, now you're talking, right? Computer can kind of convert that into ones and zeros. So HTTP is not secured. It's port 80. Then you can secure this using another protocol that's known as, do I have it here? Yeah, this guy. TLS and SSL, sorry, I'm looking at that one. But SSL, these are used to secure other protocol. So these are used to provide encryption to secure other protocol. For example, HTTP is not secure. Well, let's run HTTP under this guy, TLS, and now HTTP is going to change to HTTPS, meaning HTTP secure. And every time you use a TLS to secure unsecure protocol, it's going to change the port number. So the port number is going to be 443 in this case. Again, I think I'm giving you a little bit more than you need for this exam, but again, you're learning this, and if you ever want to advance in your cyber IT networking, this is the core knowledge that you need to know. Okay. Another one we have, it's which one should I mention? Let me start with this one. All right, SMTP. SMTP, this is for email, sending or receiving email. SMTP, it's for sending email between the servers, all right, port 25. And then you got POP. POP, it's for client. This is for receiving emails. When you're using something like Gmail or Outlook, you might be using POP, right? And POP3 specifically. This is a port 110. Okay. And then you have IMAP. IMAP is port 1, I think 114. Let me see. IMAP port number. It's 143. There we go. IMAP is 143, not 114, 143. And both of these POP3 and IMAP, there's for receiving emails when you're using your email client. Pretty good. There's a lot of difference between the two, which we're not going to get to those in this class. Another one we have, it's DHCP. DHCP, it's used to automatically assign IP addresses. I'm going to talk about IP addresses next. But DHCP is Dynamic Host Configuration Protocol. This is used when you don't want to manually assign an IP address to a computer. So you can set up like a DHCP server that's going to automatically do some IP address assignments. What is an IP? Well, IP is the number that gets assigned to a computer. Now, this number can come out of the two versions that we have, version 4 or version 6. We'll talk about both of these in this class, but that's on an IP. DNS stands for Domain Name System or Domain Name Services. This happens to be on port 53. And it's designed to resolve domain names to IP addresses. In another word, every computer must have an IP address. That's very true. Something like 192.168.1.1, right? But the problem is humans are bad at remembering numbers, but we're really good at remembering names. That's where DNS comes in. So when you go to www.google.com, well, the computer have no idea what google.com is. Guess what's going to do the translation? DNS. So DNS is the domain name system, domain name server, depends on who you ask. And it does the translation for us from domain names to IP addresses and vice versa. Then you have your FTP. This is your file transfer protocol. This is used to transfer files. And then you also have the secure file transfer protocol, which is the secure version of this. Port 21 or 20, depends on how you configure this. And the secure file transfer protocol is port 22, because behind the scene, this is being secured with SSH. So SSH is port 22, and it's secure shell. It's designed to secure remote into Linux, for the most part, Linux computers. Although you can also use some tools to be able to use SSH to remote into a Windows machine, but usually on Linux. The equivalent to Windows for this one is RDP, Remote Desktop Protocol, which happens to be port 3389. There we go. You're like, oh my God, that's a lot. Yes, it is. Did I memorize this? Yes, I did over the years. So like I said, TCP have 65,000, UDP have 65,000, over 65,000, and all of these can be found in either TCP or UDP, except things like IP. They're IP's at the layer 3, TCP's at the layer 4, And the DNS and all these other things, they happen to work on the layer 4, either using TCP or UDP in some cases. Introduction to IP, specifically IP version 4. IP version 4 came out back in the 1970s. That's when they were designing these core networking protocols, and that's when they created IP version 4. And when you do the math, IPv4 gives you up to 4.3 billion addresses that you can use, that you can work with. Yeah, like these are unique numbers that you can assign to computers. Now, in the 90s, when the www got invented, the www, well, they realized that, IPv4 is not going to be enough. So late 90s, they start working on IP version 6. Before IP version 6, they have worked on IP version 5, but they had some that one was never published. It stayed there for research purposes. We're not going to get to it, but IP version 6. We'll get to IPv6, but right now, let's talk about IP version 4. So IP version 4, an example of that, it's something that looks like what you're looking at here. So it's something like 192.168.1.1. That's it. This is an IPv4. Now it's 4 bytes, right? It's 4 bytes, the whole thing, and that's equivalent to 32 bits. In another word, there's 8-bit here, there's 8-bit here, there's 8-bit here, there's 8-bit here. If you times that by 4, if you take 8 times by 4, it's 32-bit. Okay, that's how they got the 4 bytes. Remember, there's 8 bits in 1 byte. Okay. Now back to this. Each one of these, the 192, it's known as an octet. That's another way of saying it. So this is, or a group 1, group 2, group 3, group 4. So octet 1, octet 2, octet 3, octet 4. Okay. They're separated by a dot. So that's why you will see where they said, oh, IPv4 is a dotted, or like a dotted IP addresses. Well, all they're talking about is that IPv4 is presented in, it's dotted, right, as a way we write it. That's different than IPv6, and you will see that in a minute. So each one of the octet can range from a 0 all the way to 255 or 256. So 256. I'm going to teach you the right stuff, right? It goes from a 0 all the way to 256, okay? But 0 can never be used, and 256 can never be used because you have to minus 2, okay? The 0 is for network. Basically, that belongs to everybody who's connected on that particular network. And the last IP belongs to the broadcast. Broadcast, meaning if the computer doesn't know who to talk to, it's going to send it to this particular IP, meaning it send it to everybody if it doesn't know specifically who to send it the message to. So that's really, why you got to minus 2 there as well. But numbers, all right, in each one of these groups can go from a 0 all the way to 256. All right, a few other things that you need to know. Classes. Well, they have a few different classes that you need to be aware of. For example, class A, which is any IP address from a 1 all the way to 256. If it begins with one of these 2 letters, it's a class A IP address. So if you see an IP address that says 10, does something, does something, does something, that's a class A. If you see an IP address that says 11 or 12 or 100, does something, does something, it's a class A IP address. These are usually used for a large network. Large networks, okay? Then you have your class B. Class B, it's an IP address that starts with 128 all the way to 191. That's a class B IP address. These are for medium IP addresses. This right here with the class A, it can have to thousands, if not millions, of computers. Like literally, depending on how we've configured this. So it can be huge, very, very huge. And then you have your class B. Class B, it's an IP address that begins with 192 all the way to 223. Any number between these two, it's a class C IP address. These three are the most common ones, and these are the ones that we use practicality in networks. They also have class D, which is multicast. They also have a class E, which is experimental, like research and the things like that. Now, here's one thing that you need to remember, and this is really important for you to understand this. If you have an IP address that looks like this, 192.168, this is a class C IP address, .1.0, for example. If you have an IP address that looks like that, well, the question you might be asking is, well, which portion of this IP address that belongs to the network? Meaning, what part of this IP address that's going to be shared by everybody else? For example, in my home network, if this is my IP address, well, I have laptops, cell phones, TVs, and IoT products. Well, they all connected to that same Wi-Fi. Well, which number do they all have to share since they're connected on the same network? That's really what the network portion is really all about. And then, so keep that in mind, like hold that thought. You also have a portion that belongs to the host. So this is the specific number that identifies the device. Okay. So if your question was like, okay, how do I know then which one belongs to the network and which one belongs to the host? Well, that's where this guy comes in, the subnet mask. A subnet mask determines which portion of the IP address belongs to the network and which portion of the IP address belongs to the host. So for example, if they give you an IP address that looks like this, 192.168.1.1 with the subnet mask, also known as a mask, that looks like this, 255.255.255.0. Well, what that means is that these right here, this belongs to the network. You can't touch it, meaning all the hardware on your environment are going to share that. And the last one belongs to the host. So right now, in my IP address, these right here will be the network. Will be shared with all of the other things, okay? And then the last part, the last piece will be for the host, meaning it can be shared by different computers. For example, my phone can be 192.168.1.1. That'll be my phone. My TV can be 192.168.1.2. And my tablets can be with .3, .4, .5, all the way until we get to 255, 254. Really depends on how you do this. It gets complicated. But anyway, that means these are going to stay the same. The only thing that changes the last one, because we want to be able to identify a particular host. Okay, when the conversation is coming back, once it gets to the switch needs to know exactly who to communicating with. And the way it does that, it's one, through MAC addresses and through IP addresses. Okay, so it's going to use a MAC and IP addresses to be able to know, okay, this belongs to this particular computer, this traffic that's coming on right now. Hopefully that makes sense if it doesn't get into the network plus class. All right, then you have your special addresses. These are special, you cannot use them. All right, one is the network address. All right, all host bits are 0. Yep, just like how you were looking at here, right there. Okay, you see how here they said it's 0, 0, 1. 1 belongs to the host, but the other ones belongs to the network. Okay, so every time there's a 0, that means it's a network. You cannot use it. So that's special. You can never use it, that one. Then you have your broadcast. Your broadcast, it's used to communicate with all the computers on that given network. Okay, so usually it's like 255 as an example. It can change, depends on what we're doing. You got the loop back. Loop back, it's any IP address that starts with the 127.0.0.1, for example. This is known as a local host. Right? It simply means home. Every time you see that IP address, that means yourself. Right? If you, for example, the computer, if you want to know if the computer is communicating with another thing, you literally just ping that guy, and then off you go. Then you have your APIPA. Any IP address that begins with 169.254, these are the only two ones. The other ones can be really anything. It's known as automatic private IP addresses. But basically, this is the IP address, the DHCP. If the DHCP cannot assign you an IP address, this is that IP address that you will get. Okay, so basically, if your computer cannot be assigned an IP address, it will be assigned a PIPA IP address. Now, obviously, there's a lot to talk about here. I'll be honest with you. A lot to unpack. But I'm going to leave it there. But also, let me show you this since I'm here already. We go to CMD. And let me zoom in and let me just type in IP config. Right now, I can show you the Wi-Fi. Then you can see this is my IP version 4 right there. This is in my network. That's my IP version 4, 192.168.114.112. And this is my subnet mask, which basically is telling me, let me get this right here, which is basically telling me that these right here, these three numbers cannot change. Everything in my home network right now uses these three numbers. They're identical. But the computer that I'm sitting on right now happens to be 142. If I were to pull up my phone right now, the last number is it's different. Okay. And then there's the default gateway. Default gateway is an IP address that belongs to the router. If you remember when we said we have a router, and the router's job is to get me outside of my network. Well, this is the IP address. A router must be assigned to every computer. Because every time you're searching for something that's not part of your LAN, your local area network, LAN, guess what? That request goes to the router. The router it's going to be asked, hey, I'm looking for Google. Google's not here. Can you find Google on the web and bring the Google back to me? Okay, so that's the IP address of a router. Another thing I should say, because people really don't like to keep remembering 255, 255, 255, 255. What they end up doing and what you're going to see, it's what we normally call a CIDR notation, CIDR. There we go, CIDR notation. What the heck is this? Well, this is an abbreviated way of saying the subnet mask. When somebody says that we had a CIDR notation, they're literally talking about subnet mask. But the mask, it's written as a slash something. So for example, something like this, 255.255.255, that's a slash 24. You're like, hold on, Francois, how the heck did you gather 24? If you remember earlier, I told you there's 8-bit in there, there's 8-bit here, there's 8-bit here. So if you take that 8, you times that by 4, you get 24. So that's like a slash 24. Okay. If everything is on, if all of these things are like on, then you have like 32. But as we learned, IPv4, it's a 32-bit. But in this case, I can just say slash 2024, and that means it's the 8 plus 8 plus 8. If I say slash 16, with the slash 16, that means it's 255.255.0.0. That's really what that means, slash 16. If I do slash 8, that means it's just 1255. 255.0.0.0. Okay, that's really what that means. I'm hoping you're still with me. I just want to throw all of this at you because this is important. When we are doing this in the real world, you don't walk around writing 255, 255. No, it's a slide and you're done. Now, once you start, you start getting into another topic that's known as a subnetting. Subnetting. This is where you take one IP address, you chunk it down into small pieces, like small networks. So that can mess you up. That's where you start using different subnet masks, where you're doing like a slash 26 or slash 30. Once you start doing these kind of things, and then we have some math to do. This is one of the complicated topic in networking. It's subnetting. A lot of people tend to have issues with subnetting, but you've come to the right place. So get into the Network Plus, and I will teach you what that is. I'll make it easier for you. Public and private IP addresses. So like I said, when it comes to IP version 4, the number can go from a 0 all the way to 256. Okay, so like I mentioned, they ran out of IP addresses, all right? And they said, you know what, we got to make some of these IP addresses private. And they went out there, they had a request for comment, RFC, for this 1918. It's specifically pointing out which ones of these IP addresses are going to be private, meaning they're not routable on the internet, meaning you will never see these on the internet, and they're only used within private networks, meaning anybody can use them, anybody. And when I say anybody, I'm talking about any business. Okay, if you were to look at your IP address right now in your computer, you are using one of these private IP addresses. Okay, so they said any IP that begins with a 10, it's a private. And this is for that big network, huge, large networks. If you do something like this, you have up to 65,000 IP addresses that you can play around with as a business. You have up to 65,000 computers that you can assign IP addresses to if you use the 10 network. And then the 10 IP addresses, excuse me. And then you have your 172.16, okay? All the way to 172.31, right there. This is private IP address. You can also call this class A. Just go ahead and say A here. You can also call this class B because they are within that range. Remember the range we just finished talking about? So this will be a private IP address. If you ever see any IP address that begins with 172.16 or 172.17 or 172.18, that's all private IP addresses. And my favorite one, it's 192.168.something. This, it's a class C, and it's private IP address. Okay. So why did they do this? Well, they did this to slow down IPv4 expiration date. Let me just put it that way. Okay, because there was a lot of devices that were connecting to the internet, and then we were running out of IPv4 because like we only had the 4.3 billion numbers that we can use, and there's more than 4 billion people around the world, so it was going up, fairly quickly. So guess what they did? Well, they slow it down by going in and saying these IP addresses are private now. They can be used by any company around the world as long as they keep it private. It can never be routable. Now you're like, okay, Francois, I got that. But does that mean every other IP addresses other than these three, it's public? And the reason is yes. The answer is yes. So if you ever see any IP address that begins with 11, that's a public IP. If you ever see an IP address that begins with 194, that's a public IP. Okay? IP address that begins with 80, it's a public IP. Unless then the IP begins with the numbers that we just mentioned here. Every other number from a 0 all the way to 5 or 6 or 4, really. Every other number else begins with the it will be public, right? So what is the technology that made this possible? Well, NAT. NAT is the network address translation. This is the one that translates private IP addresses to public IP addresses. And this happens in a router. It happens inside of a router. So what end up happening is, as a business, I can have like 100 computers, right? In my network, I can have 100 computer, and then I can hide all of these 100 machines behind one IP, one public IP address. Oh yeah, absolutely. And if you're like a huge business, for example, let's say Walmart, well, you can use the 10 network. Well, you can hide up to 65,000 computers. Literally, more than 65,000 machines can be hidden behind a single public IP. Just single public IP. In my network right now, let me actually show you this, then we'll come back and kind of finalize NAT. If I go to IP chicken, let me show you my public IP address. Here we go. This is my public IP address. Whenever I pay for the internet, this is what I paid for, right here. But guess what? In my home network, I have probably about 20 different computing devices, phones, tablets, kids' tablets and TVs and computers and all kinds of things. But each one of these have private IP addresses, and they're all hidden behind this single IP address right there. Okay, so if I go back here, back here. When you're doing NAT, network address translation, there's a static NAT where you're doing a one-to-one mapping, which is like one private to one public. Really not that common unless you are like a company that just want to do that. Like Google, for example, Google, they have a DNS server that's very popular that happens to be on an 8.8.8.8 network. So for them, in that case, they can do static and natting where it's one-to-one, where from internal is that and the public will be, this right here. Anyway, you also have dynamic NAT. This is where they have a pool of public IP address. And when computers are communicating, they can pick from the pool of those public IP addresses, right? You're trying to go to the web, you pick one IP address, you go to the web, you come, you release that IP, they give you what you were looking for. So this is okay, but it's not sufficient. The best way of doing this is by using NAT with its little cousin. It's known as a PAT. PAT is port address translation. This is what kept IPv4 in business. Okay, because what ended up happening is instead of doing a one-to-one mapping, instead of doing a pool of IP addresses, what we can do is have a bunch of private computers or using private IP addresses. Okay, and then we can hide them behind one public IP. And then all we do, whenever these things are going out to the internet, the router, because this is where you configure this into, the router, it's going to do the PAT, the port address translation. So it's going in and assign a dynamic port to it, right? Dynamic port to it. And then the router is going to be intelligent enough to remember that conversation. Oh, that's a lot. That's a lot I'm throwing at you. But that's really what takes place. Again, more to this in Network Plus. The dynamic host configuration protocol. This is the protocol that automatically assigns IP addresses to computers or any networking devices. So you can either do that using this automatically, or you can statically do that. Let me go ahead and get to my Windows computer so I can go ahead and show you this. So you go to Control Panel. I'm going to show you the longer way. Then from here, I go to the networking, internet connections, and I go to the network and sharing center. And right here, I can click on change adapter settings. Then right here, I can look at the Wi-Fi, right click on it and go to the properties. I can also double click on it. But once I get to the properties, I look at IP version 4 right there. Then I click on property one more time. And here we are. So right now, there's an option that says obtain right there, obtain an IP address automatically. That's DHCP. That's what we're talking about right now. Basically, my computer have received an IP address dynamically, automatically using a DHCP server. My router is acting as a DHCP server. This is actually what a lot of routers, home routers, and home access points do. As soon as you have your home Wi-Fi set up, well, the router, the access point is going to be acting as a DHCP server. That's why when you want to connect your cell phone, all you have to do, you just connect it to the Wi-Fi, the Wi-Fi name, and then all of a sudden, you automatically connect, or you automatically receives an IP address. How is that? That's to the power of a DHCP. Well, what if I didn't want to receive an IP address automatically? Well, what I can do I can use the following IP address in case in my Windows, and then I can specifically say, okay, my IP address is going to be 192.168.114.205, for example. Okay, then I can click here, and then here's the power of Windows. It's going to automatically assign you this subnet mask. It's going to think about this and be like, huh, this is a class C, therefore, the subnet mask is going to be 255.255.255.0. This is exactly what I'm having here. But remember, for this whole thing to work, you also need a subnet, a default gateway. And then right here, I can specifically say the default gateway is 192.168.114.1. I think that's what it was. I'm not so sure now because I'm not changing this. I'm just showing you. So because I want to be able to get to the internet, you want to be able to configure your DNS, your DNS server. And usually right here, you can put something like Google's DNS 8.8.8.8, which is pretty good. And what that means is that your computer, it's going to be reaching out to 8.8.8.8 as the DNS. Now, this is if you're like in your home network. If you are at the business, you will put your DNS server IP address here, and then have a 8.8.8.8 as the backup. Because your computers usually at the business will reach out to this DNS when it's trying to resolve names and IP addresses to names. It will reach out to the preferred DNS first before it goes to the alternative, before it goes to the second one. But this is the static IP address assignment. This is where you go in, you manually put those numbers in. I'm going to go ahead and close that, close all of this, and get back to this. So the process of dynamically assigning IP addresses to computer, it's known as DORA. If you remember that cartoon movie that says Dora Explorer, the same thing here, right? It's going to start with the discovery. This is when your phone, your client, broadcasts a request for the IP. It basically, as soon as you try to connect it to that network, it's reaching out and saying, is there anybody, and I mean anybody, on this network that can assign me an IP address? Okay, so if you have the DHCP server running, well, it's going to respond. It's going to offer. It's basically going in and saying, me. I, Mr. DHCP server, I can offer you an IP address. I do have some numbers. I can give you one, right? And the client is going to request that. That's the R in the DORA. That's the R. So it's going to request, the client request the IP address that have been offered by the DHCP server. And then last step is the acknowledgement. This is where the server confirms, hey, Mr. Client, from now on, this is it. This is your IP address. So that's the DORA that's the DORA process, right? Process of assigning in an IP address automatically, an IP address to a client computer. And that takes me to IP version 6. Now, IPv6, it's a little bit interesting, right? Part of the reason is because it's different than IP version 4. As soon as you see IP version 6, you start thinking, oh my God, what is that? An example of IPv6 is what you're looking at right here. Look at how it's written. You got like phone numbers, colons, phone numbers, colons, right? You probably have seen this if you watched this training from the beginning. I have showed you IPv6 before. But here's a few things I want to mention about IPv6. First of all, IP version 6, it's 128-bit in length as far as the length goes. So it's huge. IPv4, it's just 32. IPv6 is 128 long. Now, each one of them, it's a 16 bits. Each one, it's a 16 bits, and IPv6 has 8 groups. I don't want to call those octet. I think that's more of like an IPv4 thing. But there's 8 groups of 4 hexadecimal digits. There we go. The numbers that you're looking at here, these are hexadecimal. And if you take 8 times 16, you get to 128. Yeah, I memorized that number. And you're like, you're a math genius. No, I'm not. Just memorize that number. But with IPv6, there's these many addresses that we can use. the number that I cannot even pronounce, undercillion. Basically, I just like to tell people IPv6, it's unlimited, at least for now. But they have Internet of Things, IoT product. They're all going to need IPv6. That's one of those things that's pushing IPv6 into the market as well. So remember, IPv6 is 128-bit long. It's a group of 8. As you can see, there's group 1, group 2, group 3, group 4, group 5, group 6, and group 8. I'm counting this. 1, 2, 3, 4, 5, 6, 7, 8. There we go. Group 8. Like I said, each one of these, it's 16 bits. And if you were to times that, it's going to equal to 128. That's usually what CompTIA tend to ask as well. Now, here's some notational rules that you need to be aware of. When it comes to writing IPv6, zeros are usually eliminated. For example, if the number begins with a 001, these 3 zeros are going to be deleted, and it's just going to be colons 1, then colons something else. The other thing is if there are leading zeros, like double zeros that follow each other, for example, this is 0 and this is 0, these are going to be replaced with the colons. So it's going to be colons, and that's equal to these zeros. So the IP address that looks like this is going to be turned into something that looks like that. Why they did that? To make it a little bit easier, right? When you're writing this. So the leading zeros here, 0, 0, 0, 0, 0, colons, 0, 0, 0, 0, colons. That's colons like that, right? Then it's 0, 0, 0, 0, 0, 0, 0. That's these 2 columns that you're looking at right there like that. Then as you can see, there was a 0 at the beginning of this particular one, and that also was eliminated, right? Basically, you just, get rid of that 0. So it's a little bit easier for you to manage. Now, there's a little bit more to this conversation, including the different address parts and the different prefix length. For example, how IPv6 uses your MAC addresses, which happen to be 48 bits, in order to do what it does. I will hold on to that to the Network Plus conversation. Okay, but there's a little bit more to IPv6. But what I just shared with you right now is what you need to know for this exam. Over the years, we have been trying to transition from IP version 4 to version 6. And there's this thing that's known as a dual stack. This is when we're running both IP version 4 and IP version 6 at the same time. Although they don't like each other, but again, we're in that process of transitioning. And they developed other things that can help kind of to ease up this whole transition process. For example, tunneling, it's a way of encapsulating IP version 6 packets within IPv4 packets. Now, the way you do that, you create this tunnel, is by using these other protocols that they created. For example, 624, Teredo, 6RD, and ASATAP. All of these are used to kind of tunnel the traffic between IPv4 and IPv6 and IPv6 within IPv4. So there are some networks that allows you to be able to run both of these at the same time. Like I said, they don't really like each other, right? I think I was talking to another engineer who said they kind of turned both of these on and things weren't working. So they have to either, turn off one. It's more like use one over the other. All right. But they do have these protocols that can help kind of ease up the transition or the translation as the traffic goes from IPv6 to IPv4 and vice versa. So these transitions, it's going to convert the traffic. So for example, you have a NAT 64, you also have a DNS 64 that goes in and do the translation as the traffic goes from one IP, from IPv4 all the way to IP version 6. And that takes me to DNS, Domain Name System, DNS. DNS is the phone book of the internet. This is used to translate from names to numbers and vice versa. So for example, if your domain name is cyberprostraining.com, well, that can be translated to this. And don't try to Google this because that's not the really IP address of cyberprostraining.com. But anyway, the domain name is the one that help us with this translation. Okay. Otherwise, we will be walking around remembering the IP address of every website we visit. Let me go ahead and spin up Kali Linux. Is that Kali? Let me bring up Kali. There we go. So I'll be able to show you this very quickly. So as that's coming up, let me get back to this and talk about this a little bit more. DNS have a hierarchy. So you got the root servers, which is really what that dot means. Every time you see the dot in the DNS language, that means this is the root, where the granddaddy, where everything is coming from. And then you have the TLD. TLD are the top level domain names. TLDs are the .com, the .org, the .net, the .edu, the military, the .this, the .that. So these are the TLDs. Basically, every time you're looking for a website that ends with a .com, well, the conversation starts from the root. The root is like, hey, I'm looking for something that ends with a .com. Do you happen to know who that is? Well, root is going to be like, hey, there's a TLD that knows everybody who ends with a .com. Go ask him. Then the conversation goes to this TLD DNS. And the .com, which will know everybody that ends with .com, it will then be like, oh, who exactly are you looking for? I'm looking for google.com. Then that's where it's gonna get sent to the second level domains, where it knows exactly who google.com is. It's gonna point you out to the google.com DNS server, and then google.com then can specifically ask you, hey, I am google.com. You're looking for me. What do you want? Right? And then you can specify like, okay, I'm looking for this particular web page that happens to be hosted here. There we go. Then the conversation goes that way. Okay. So as you go in and using DNS, there are some records that you need to be aware of. There's a record. This one represents IPv4. There is the quadruple A record. This one presents IPv6, which kind of makes sense. IPv4 is 32-bit, and the quadruple A means IPv6, which is 4. If you take 32 times 4 equals what? 128. 128. The 128 is the IPv6 bits. Once you understand this stuff, it's all kind of makes sense. Okay, and I'll show you this in a minute in Kali. And then you have your CNAME. This is a canonical name, alias, used for things like subdomains. Okay, so you can start saying, hey, store.cybertraining.com or cert.cybertraining.com. That's like a subdomain, okay, which you can create that as a CNAME. And then you have your mail exchange, MX. This is for emails, right? If you have like an email server that you want a DNS to be translating names on it, then you use that. Then you have your text, TXT. This is for kind of adding information into your DNS server. Like if people want to verify if that DNS server belongs to you, then you might use the TXT. Then you have the printer. The printer is the reverse lookup. See how like you can look up things using names, where PTR is when you can look it up using IP address. For example, you already know what the IP address of google.com is, right? You got that. PTR will be to go to your computer and be like, hey, what's the name associated with this IP address? So that would be a pointer or PTR. Okay, let's go to Kali quickly here. Let me show you a few things. Now I'm going to bring up Kali. There we go. Looks like it did not load up. Let's go ahead and close this. Power that guy off. And let's go load this one up again. So in Kali, we're going to use a tool that's known as a dig. And the dig, it's a way of accruing DNS. Actually, let me be doing that on a Windows. Let me go ahead and get a CMD command prompt as we wait for that Kali to come. So on Windows, you can use a tool that's known as NSLookup. NSLookup is a DNS tool that you can use to query DNS servers. For example, you can say NSLookup, I want to know what's the IP address associated with the google.com. Literally, you type in NSLookup space google.com, you press enter. It goes in and says, hey, you looking for NSLookup? Got it. Here's the answer for you. Google.com can be found on one of these. I mean, Google is huge, so they have different IP addresses associated with them. Okay, you can also say NSLookup at cyberprostraining.com. we're going to say, hey, what's the IP address? What's the DNS IP address associated with the cyberprostraining.com? It comes back, it says, hey, here's the IPv4, and here's the IPv version 6 that is associated with the cyberprostraining.com. Yep. So that's NS lookup. Okay, let me show you that in Kali using a different tool. Let me get rid of that right there so I can have a little bit more room to work with. And we're going to spin up the terminal. And let me go ahead and zoom in. What am I doing? There we go, zoom in. So the tool that I said we're going to use is called Dig. You can say, hey, Dig, google.com. Okay. Same thing with NS lookup dig. It's just been around for a very long time, and it's very useful in Linux. So here it comes back, it says, hey, you're looking for google.com. Got it. Here's the answer section for you. Google.com can be found on these numbers. And here's the beauty. If I were to copy this one right here, if I were to copy one of these numbers, then go to, like something like Google Chrome, go to a browser, then paste that number in. For example, I paste this number in. If I to hit enter, it's going to search for Google. It's going to translate that back to Google. That's the power of DNS. If it wasn't DNS, I'll have to remember these numbers. Every time I want to get to Google, I'll go to 64.233.177.138, right? But thankfully, Google have solved that problem. Google, DNS have solved that problem for us. So if I press enter right now, there we go. It has to take me back to google.com, right? It has to take me back to google.com. I'm going to close that. And earlier, here right now, it gave me this right here with A records. As you can see, it gives you the A records, which is IPv4. But what if I want IPv6? Well, what I can do, I can say, hey, Dig. Let me clear this screen here. I can say, hey, Dig. I want you to find me the AAA of google.com. Like literally, we just went in and said, hey, show me the quadruple A, the IP version 6 of google.com. And then he went back and says, hey, these are the IPv6 of google.com. Well, what if I want to know if Google is using a Gmail, right? What if I want to know if the google.com is housing some Gmail? What I can do, I can say, hey, Dig, I want you, now this is where the MX, this is why it's really important for you to know these records. It kind of helps as well. So I can just say, hey, Dig, show me the MX, the mail exchange of google.com. If I press enter, it's going to go in and it's going to say, hey, yeah, I got some answers for you. Here's the answer section. It's google.com does have a mail server that is housed on SMTP, Simple Mail Transfer Protocol.google.com. Ah, juicy, 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 juicy. So you got to learn DNS. DNS is extremely important. All right, few other protocols. Then we have your web. I've mentioned this one, so I won't be spending too much time on this one. HTTP. HTTP stands for Hypertext Transfer Protocol. This is the protocol that is used when you're accessing the web. So every time you go to our website, this is what you are using. A protocol, it's a language, right? Think about this as a language. So as you go in and you're trying to communicate web, you have to use the language that everybody understands on the web. And that's really what HTTP is, okay? HTTP happens to be on port 80. It does have the default port of 80, although you can change it to something else. And over the years, FTTP have, gotten different, kind of versions. So there was version 1, 1.1, 2. Recently, we have version 3, which does have some improvement in performance. But HTTP came out in 1990, 1991. This is when Tim Lee, the inventor of the World Wide Web, he invented www. He also invented HTTP. He also invented HTML. This is a protocol. HTML is a markup language, hypertext markup language. That's what that stands for. And www is the World Wide Web, as I said. So these three were the only missing pieces in order to use the internet as we know it. Once he invented this, it was game over. So like I said, HTTP is not secure, so you can secure it. Once you secure it, it's going to use a different port. It's going to use the 443. You can also secure HTTP using TLS. This is the transport layer security. That's the protocol that is used to secure other protocol. Now, the benefit of securing this, then you have your confidentiality, your data integrity, and other things. We're going to talk about this in the security section of this class. Now, there are some methods of HTTP. This is a little bit beyond of this course, but when you're communicating using HTTP, you're basically saying, hey, give me this, right? Like you're retrieving the data. When you go to request a website, you're saying, hey, give me this web page. That's the get command, right? And then there's the post. This when you submit a data. This means you're on the website already. Now you are maybe authenticating. That's the post in HTTP language. Then there's the put, where you update things. There's the delete, when you remove things. There's the header or the head. This is when you get the header information only. And there's all kinds of other things that gets involved as well. And then you have your email protocol, right? When it comes to your email, like I said, you have your SMTP. This is the Simple Mail Transfer Protocol. Happens to be port 25. It's used for sending emails between servers. Okay, so Microsoft servers, email servers are communicating with the Google email servers. This is the protocol they're going to use. Okay, so it's unsecure, but when you secure it behind the TLS, it's going to change a port number to that right there. Okay, and then you have your POP, like Post Office Protocol, specifically version 3, happens to be on port 110, like I mentioned earlier. It's unencrypted, but you can secure this using TLS as well. And then it's going to change the port number to 995. The problem with POP is that when you're using POP to retrieve things, to receive things, well, when I say things, I'm talking about emails, it's going to download and delete the email from the mail server. That's a problem. Okay, that's a problem. The reason is because nowadays, people are using cell phones to access an email. They're using a computer to access the same email, and they're using another device to access the same email. So in the case of POP, that email it's already deleted in the server. So if you're accessing it from a computer, that means you cannot access it from the phone because it had been downloaded, literally. It had been downloaded. They have been removed from the server into the client machine, meaning into the device that you're using to access the email. That's where IMAP comes in. IMAP is the Internet Message Access Protocol. It's better than POP when it comes to retrieving emails, right? It's unencrypted, port 143, but you can encrypt this, which is going to be on port 993 using TLS. Now, the mails are still stored in the server. That's the biggest difference between POP and IMAP. The mail is still stored in the server, which means you can access the same email from multiple locations. Multiple devices as well. Okay, if I were to show you this very quickly, I can go to Gmail right now. Let me get out of this. There we go. So I can go to Gmail. And right here, I can click on settings. I can get to settings. And here you can see that there's a POP and then IMAP. You can see that POP is disabled. Yeah, POP is disabled and IMAP is enabled. Now there are some security that that you can do. It's a little bit beyond this, so I won't spend too much time on this. But you have SPF. This is the sender policy framework, which is going in and it's verifying the sender's IP address. So as you're receiving those emails, you want to know if the email came from the right personnel. And that's one of the protocol that can be used for that. Another one, and this is the one we used to use, it's SMIME. SMIMEs provide end-to-end encryption. Yes, you can encrypt the email using this, and then encrypt the emails that are coming to you using, this right there. But if you do that, that means from the client all the way until it gets to the other client, there was a point where the conversation wasn't secure, right? So for hospitals, I used to work for hospitals. It's a problem. Therefore, we need end-to-end encryption. That's where SMIME comes in. You also have a PGP, pretty good privacy, also provides end-to-end encryption and signatures. You also have DKIM, domain keys identifier mail, which is for assigning the message. You also have the DMARC or domain based message authentication, which is the framework that goes in and authenticate the message. Again, all for security of protecting that email, making sure it did come from the right personnel. Then another one we have, it's a file transfer protocol for sharing files, okay? For sharing your files. So it's a protocol for transferring files, right? The default port of 20 and 21, right? But most of us just say, 21 for FTP. Right? If you see this on that exam, be like, I don't see 20. Where is 20? It's usually just, 21. But you can use it on both 20 and 21. Again, this one is used for transferring bigger files. It's not secure, but you can secure it, this. And there's two ways of securing this. You can secure it using SSH, and that turns the FTP into secure FTP. Okay, and that changes the port of this to 22. Why? Because SSH uses a port 22. That's the other thing about SSH. Anything that is secure behind SSH uses the same port number. Yeah, port number. You can also secure this using TLS, SSL, SSL, excuse me. And it's going to turn this into the FTP secure. Again, with this, the port number will change. The port number will change as well. SMB, this is the server message block. It's used on Windows to share files. For example, when you're printing things on a Windows network, Windows environment, well, you will be using SMB. The reason why I included this right here is because it's commonly attacked. Oh yeah, this one right here, attackers have used this over the years to attack companies. It happens to be on port 445, and there's different versions of this. There's version 1, which Microsoft have been begging people to turn off. There's also version 2, and there's version 3, which is the current, the one that have security and things. Okay, so again, used when you want to share files and printers on that same network. But if you're using the older version, it's very vulnerable. If you ever heard about the attacks such as WannaCry and CompTIA that happened in 2017, these attacks have cost organizations around the world over $10 billion. $10 billion in damages. It was all using SMB, server message block. Now, connectivity testing tools. After talking about the port and protocols, we have some tools that we work with. And let me go ahead and zoom in here for you so that I can kind of show you this very quickly. We have a ping. Ping, it's a way of testing connectivity. So for example, I can ping myself. If you remember earlier, I was telling you that 172.0.0.1 means it's a loop back. That's my own IP address. I can ping that. Oh, 127, excuse me. Bring that back. Go back here and change that to 127. There we go. Not 172. I messed it up. So 127 is the loop back. Right? That's if you ever saw somebody wearing a t-shirt that says there's nothing like 127.0.0.1, those are geek people, right? Don't party with them people. No, that basically they're telling you there's nothing like home, right? Because that's really what that means. Anyway, it's coming back, it's telling me, hey, look, yeah, you can ping yourself. It looks like you're good to go. There were 4 packets were sent, 4 were received, and 0 packets were lost. Fantastic. I can also clear the screen. And then I can get back here and be like, what if I want to ping Google? This is the fastest way to know if you're connected to the internet is by pinging Google. Maybe ping A8888. Let's go ahead and do that. Let's ping Google's DNS. I press enter right there, and it's coming back. It's saying, yep, you, my friend, are connected to the internet. There we go. I sent 4 packets, 4 were received, 0 packets were lost. Pretty good. Well, early we talked about a router, like a router. Well, what if you want to know the path that your packets takes from point A to point B? That's where you use traceroute on Linux and then traceRT on Windows. So here you can say traceRT to google.com. Basically here, you want to know the amount of packets, the amount of router you have to hop into to go from where you are, from your own router to google.com. So right now, imagine if Google is in California. Well, my computer right now is going in, is saying, hey, hop number 1, it was this guy, and that happens to be me. That's my router's IP address. Okay, hop number 2 happened to be that guy, whoever that was, and then that guy, and then get who that guy, and then it's gonna keep going and on and on and on and on. And on the Windows computer, it only have maximum of 30 hops. These are the amount of routers that it can jump to as well. Again, maps the path to a destination. That's what these tools are used for. You can use them in your own environment to try to figure out where the traffic goes. I'm going to Control C to stop this. I'm going to clear the screen again. And we have dig. I just showed you NS lookup and dig a minute ago. I've been showing you IP config. So let's keep going. Few other tools that we have include what you're looking at here. You have netstat, which is used to display network connectivity, like connections. You can see things that you're connecting, you're connected to. You can see the things that's listening in. So it basically showed you things that are actively connected to your computer. So right here, I can say netstat, and then I can use some of these syntax, these options. I can say NAOB, right? And right now it's telling me, hey, we can't do that because you are not administrator, right? Because I'm trying to, get administrative things. Let me try to run a netstat by itself. There we go. It comes back and show me the active connections. It's give me the local look back right there. It's show me the foreign. Foreign is the thing that we're communicating with, and the port number, right? And then it's tell me the state is established and so on and so forth. So this was all just generic stuff. But once we get here, we start seeing my exact IP address, the source protocol, the source where the traffic is coming from, and the destination where it's going, and if it's using some kind of a well-known destination port and auto protocol. In this case, it's a protocol which happens to be HTTPS. This is an equivalent of 443. They tell me the conversation has been established. So if I were to close this and then bring CMD, right click on that and run this as administrator. I'm going to click yes. Now I'm running this as an administrator. You can see that in the chat right there. And I can just do the same thing, netstat. Now I can add my options, my syntax, and hopefully that's going to work. NAOB, I press enter, and voila, it's working. There we go. Well, why did I run this? Because I want this to give me more information. I don't want just this to tell me just who I'm communicating with. I want to see the protocol. I want to see the actual application that's actively running. So if I scroll down a little bit here and start seeing some real information from me with that IP address, I can see the Google Chrome. Yes, I am running Google Chrome. I can see Zoom. Yes, Zoom is actually actively running. And I can see this is my IP address right there. And this is the port that my source port. This is like a dynamic port. Again, get to the network plus where I dig a little bit deeper into this. And then I can see the Zoom, this is Google Chrome. I can see the Google Chrome IP address and the 443 IP address that I'm connected to. And I can see that this conversation have been established. And here is the thing. It also gives me the process ID. Also, what we normally call a PID, process ID. This is juicy information. Okay. Another one we can do path ping, which I think it only works on Linux, but let's try it here. Okay, pathing.com. Okay. Oh, it works here too. Fantastic. This is a Windows terminal. Maybe I'm running the one that supports Linux. Who knows? Okay, so this is when you're combining ping. You're combining ping and the trace route. Basically, you're going in, you're getting statistics of how things is going. It's pinging, but also it's running trace route at the same time. And you can see that it's coming back, it's telling me, hey, you have this, this is your router, right? The one that I'm connected to, and so on and so forth. Here's the thing. A lot of product are going to deny these connectivity testing tools. Oh yeah, pinging and NAT statting, path pinging and that kind of stuff. It's not gonna work. It's not gonna work. So the reason is because when you're using these things, you are running what we normally call the ICMP protocol. This is the protocol that you are running behind the scene. And most devices just don't like ICMP because ICMP is used to troubleshoot networks. All right, I am telling you a little bit too much. Then you have your Nmap. I'm not going to run Nmap 1. It's not installed on my local computer. I will have to use Kali, but it's beyond this. But Nmap, it's a network scanning and discovery tool that you can use to scan for port and for operating system detection to detect the versions of things that are running in your environment. There's also a bunch of syntax that you can run with Nmap as well. What are some of the common network issues that comes in mind? Well, if there's no internet connectivity, well, all you do, you just check the internet, right? You cannot access any network resources. There is internet problem. What you do, you ping the router, ping Google, right? See if you can reach out to your own router if you know the IP address. If you can't, see if you can reach out to Google. If you can't reach out to your own router, then see if you can reach out to Google. If you cannot reach out to Google, but you can reach out to your router, that means your router is having some issues. Then you will take a look at the layer three of the OSI model. Okay. So what could be the possible issues if there's no connectivity though? Well, it could be a physical problem. Literally. If you cannot ping your router, if you can't even get to your router, that means your computer is having some issues. So you will take a look at that and see if your wires are connected, right? And then see if it's not an IP address configuration problem. See if you can get to your router. Okay, so that's like part of that troubleshooting steps. Verifying the IP, restart the networking devices if you have to. What if you have an intermediate problem where the connection comes and then goes? Oh, well, if you can access some resources, but you can access all of the resources, what could be the possible issues? Well, it could be a DNS thing. Remember, DNS is used everywhere. We got to have DNS running all the time. But if our DNS is experiencing issues, you could have this problem right here where things work and they don't work. Okay. It could be a routing problem. Router have these things known as a routing protocols. Well, if that routing protocol is not configured the right way, this could be the problem. It could be a firewall blocking something. It could be a proxy server not working. Okay. How you do that, how you troubleshoot this, you test the DNS, you check for the proxy settings. If you have a proxy, you verify the firewall rules if you think the firewall is the one that's giving you issue. Then you're like, what is a proxy? Well, proxy, it's a hardware device. I should have mentioned this when we we're talking about hardware. But it's a hardware device that sits between the two things communicating. A and B are communicating. A proxy is going to be right here. And what happens is A cannot communicate with B directly. He has to go to the proxy. The proxy is gonna tell A, hey, hold on, let me go get what you're looking for from B. I'll bring it back and then give it that to you. That's how a proxy works. And then we have a forward proxy. We have two different proxies. There's a forwarding proxy. There's also a there's another one. I forgot the name. But they all do the same thing. It's just that a forward proxy, it's better because there's some security that you can do at that proxy. Hello and welcome to module number 5. This is the module where we're going to talk about cloud computing and virtualization. Again, we're covering the domain 2.0, which is 24% of that exam. As you can see, there's a lot in that domain, and that's why we're taking our sweet time to talk about everything there is to know about this. So here's what you are going to learn as far as the module learning objective goes. First, we're going to identify and compare different cloud services model. If you've heard about things like infrastructure as a service, platform as a service, software as a service, function as a service, well, that's this section. This is where we're going to kind of introduce all that stuff to you. But before we do that, we'll talk about virtualization first. And then explain various cloud deployment models. So you can maybe deploy like a private cloud, a public cloud, or a hybrid cloud, or they used to have community clouds and things like that. So you're going to understand the different deployment models that you will seek for if you are migrating into the cloud. Then again, we will start with describing the virtualization, because virtualization is what gave birth to cloud computing. So we'll talk about key virtualization technology, including application virtualization, which is also sometimes known as containerization. We'll talk about containers as well. So we'll finish this by looking at the implement basic virtualization solution. Basically, I'll go in and kind of share this with you, show you what I have in my own home network using VMware Workstation, which is what I use. So what is a virtualization, you may ask, right? Let's start this conversation by talking about virtual machines. Well, when you virtualize something, basically you are using some kind of a software that goes in and emulate a physical computer. In other words, you're going in and you are running a machine inside another machine. Yes. So what you are end up doing, you are virtualizing an operating system, or it could be an application, but an operating system. Then you have that running inside another machine. So instead of just talking about this here, just like that, I'm going to go ahead and demonstrate this for you very quickly, so you have an idea of what we are talking about right now. So here, what you're looking at right now is what we call a VMware workstation. VMware workstation is a hypervisor, something that I will touch upon, and now I'm talking about it already. VMware workstation is a hypervisor, is a software, is a tool that I am using to virtualize my virtual machines. Okay, so once I have a VMware workstation installed, the next thing I do is go ahead and install a virtual machine. So all I do, just go to new, like create a new virtual machine. I click on that, and then it goes into the process of trying to get me to, install a virtual machine. Once I finish doing all of that, it's going to look like what you're looking at right now. So here's a few things that you need to know to be aware of. This hypervisor, VMware Workstation, it's going in, it's emulating physical hardware. It's basically lying to the virtual machine, and then it's telling this virtual machine, hey, you do have memory, meaning you do have CPU, you do have a processor, meaning you do have RAM, random access memory, you do have a hard drive, you do have a DVD drive, you do have a network interface card, you do have USBs, you do have displays. But it's going in, it's telling this virtual machine that it does have everything it needs to run. In reality, all of this stuff is virtualized. None of it is true, is real. But guess what? This computer doesn't know that. All this computer does know is that it has the hardware that it needed to run. So this was good. And it's good because now I am able to run a multiple operating system inside of one operating system. For example, I have a Windows 11 running on this computer that I'm sitting on right now. But right now you can see I have how many machines? 1, 2, 3, 4, 5, 6. There we go. Got a few more from there. We got a few more from here. But basically, I have like a lot different VMs on top of this one computer. How is that possible? It's through the power of hypervisors, which happen to be part of virtualization. Okay. And I have already mentioned what a hypervisor are, and then I showed you one example of that, including the VMware workstation. So again, hypervisors are software that creates and manages virtual machines. Okay, basically it allows you to create what we normally call the guest machines. And a guest machine is a machine that runs on top of the hypervisor. So those Kali, those Meta that you were looking at, those are guest machines. They're guest in my host machine. Host machine is this computer that I'm sitting on right now, this Windows 11 as well. So there's two types of hypervisors. The one that I showed you, it was this guy, type 2. Type 2 is the one that I just showed you. So type 2 hypervisor runs as an application on a hosted operating system. My computer Windows 11 is the hosted OS. Okay, it's really easy to install. You just install it and then you add whatever you want. So some example of this, including the VMware workstation I just showed you. If you're on a Mac, it's known as a VMware Fusion. You can also get the Oracle VirtualBox also does this. Microsoft have a Hyper-V that does this, and so on and so forth. But this is a type 2 hypervisors. You also have a type 1 hypervisors. These are bare metal. These are the ones that doesn't need a host operating system. They run directly on a hardware. There's no host operating system that is required. Now, this is the one that company use. It's used on the enterprises, right? If you want to just go in and virtualize everything, then you will want to go with the type 1 hypervisor. Type 2, it's really good for training. Literally, like if you want to create like a home lab and things like that, that's type 2. Type 1, on the other hand, it's great for businesses, enterprise. It does have a better performances and some dedicated hardware designed specifically to be able to run this. Some example of that, it's a Microsoft Hyper-V. It does have like a bare one version. VMware also have this ESXi. Then there is a Citrix that also have some type 1 hypervisor as well. So when they virtualized computers, they didn't want to stop there. Because the problem with the virtualizing computer is that you still need to run, for example, I still need to run my Windows 11 right now, my host OS have to run, and then I have to open up this VMware workstation, and then I have to power on this machine, which is gonna take a minute, right? Guess what they did? What they said? They said, you know what if we don't have to do any of that? Well, what if we can just add a container to the host operating system, and then off we go. We don't have to kind of install another operating system. And that's exactly what they did. So containerization or containers is a lightweight, portable computing environment that package just application code and its dependencies. And usually those dependencies are based on the host operating system or the kernel of the host operating system. Okay, so a great example of that will be Docker. And I happen to have Docker running in on this computer. Let me go ahead and bring it up. The Docker desktop. Okay, this is like the engine. All you do, you install something like Docker on top of your operating system. And then all of a sudden, it looks like this, and hopefully things are going to load up. And all of a sudden, all you do, you just install the application that you need, and that's it. Like, for example, if you need like a web server, you just add the web server on top of that and game over. For example, I was playing around with the AI that came out the other day. What is it? DeepSeek. There we go. DeepSeek, the AI. And then I said, you know what? I need to install the Open Web UI on top of my Docker so that I can be able to have a really cool interface that allows me to access my DeepSeek AI, LLM. And that's exactly what I did. So instead of installing an operating system and then reboot it and doing all kinds of things, all I did, I just edited this right here. I can turn this on and have this running, but I'm not gonna do that. But just add this on top of my Docker and off I go. What's the beauty of containers? They are extremely fast because you don't need to reboot and boot it up and boot up all kind of things. So containers, they're sharing the same operating system as the physical machine. So they're extremely fast. They're very lightweight. They're not going to boot up things you don't need. It's only going to boot up the application that you need. What are the benefits and limitations of using hypervisors and containers? Well, one, as far as the benefit goes, it's has some efficiency in the way you use your resources. Yes, higher utilization of a physical hardware, it's definitely what we're getting out of this, because now you have one computer that you're using to its max as far as hardware goes. It's flexible because you can use any hardware, any CPU, anything, and then it's gonna work, just okay. It's easy for things like recovery. For example, in my VMware workstation right now, I can take a snapshot and I'll be off I go. It's really straightforward, just like that. Now, when it comes to some limitations, isolation, yes. Remember, since you have those things installed on a computer, you have that single point of failure. And the other problem is if you get breached, or the VM gets hacked, then your physical machine can get hacked too. And this is known as a VM escape. VM escape. This is where the attack starts in the virtualized machine, and then it escapes into the hypervisor, and then from the hypervisor into the host machine, into your actual computer. All right, management is another thing as far as limitation goes. So there's that centralized administration. You can also automate this, but you also have things like a VM sprawl. VM sprawl. I think that's how you spell it. You can look it up. VM sprawl, that's where you set up things, then you forgot those things exist. And that's a problem. That's a problem. That's one of those limitations. You can also use these as, for testing and deployments, which is, pretty okay. But isolating this environment where you're able to use it for testing purposes can be a little bit challenging as well. And that takes me to cloud computing. Here's a few things you need to know about cloud. Well, cloud started back in 2005, 005, when a company we both know and love, known as Amazon, when Amazon was running one of their Prime days, right? They have these days where they basically let everybody know, hey, prices are going to be down. So you had a lot of people flooding in and trying to buy things. And Amazon, when it's during this peak time, they have to buy a lot of hardware and start using it. I mean, deploying it, to get ready for the for that spike in usage. Here was the problem. After the Prime Day, after people are not flooding the website to buy stuff, they were left with a bunch of hardware that they didn't know what to do with it. And so somebody out of the Amazon employees, some geniuses, he came and he said, well, all this hardware we have sitting around, what if we can borrow this to somebody, not to another company that's maybe going vital right now, right? That doesn't have enough hardware. What if we borrow them this hardware so they can start using it? And that, my friends, was the beginning of what now we call the cloud computing. But the underlying technology was already there. The virtualization was already there. So a cloud built on top of a virtualization. But what I'm trying to tell you right now was the beginning of it all. So Amazon started doing what they call AWS, Amazon Web Services. And I think in 2010, Netflix became their customer. Yeah. And then from there, everything changed. Everything changed. In 2012, Microsoft said, you are not going to leave me behind. So Microsoft joined the party with Microsoft Azure. And then in 2014, Google said, huh, you're not on my watch. So Google also joined the party with the Google Cloud, what they call now Google Cloud. At the time, they were calling this a Google Computing Engine. I think that was the official name for it. Anyway, back to the point. So cloud computing is basically computers that you're renting, and you can manage those computers from the web. So that's where you're going in and you're getting infrastructure. You're telling AWS, hey, just give me the infrastructure. Basically, AWS have a data center, and inside of that data centers, they have a bunch of hardware, and they basically lease those hardware to the people who wants the hardware. Okay, that's really pretty much all they do. So here, the infrastructure as a service, that's where we provide virtualized computing resources over the internet. Okay, this is obviously offer the fundamentals infrastructure components. This is where a lot of companies have been shifting, bigger companies, where you go in, you tell AWS, hey, give me the hardware, I am going to manage it. Right? I have my own system administrator. I have my own application. You just take care of the infrastructure. Give me the infrastructure, then I'll take care of everything else. Okay. So that's really what IaaS is, the infrastructure as a service. Okay, great example of that, like I said, it will be when you go to AWS and said, I'm looking for the EC2 instance. Well, that's basically a computer that's housed in AWS. That will be the infrastructure, where they just give you the EC2, then you take care of everything. You bring your own operating system, you bring your own application, like everything else is yours. They basically just give you the infrastructure. And then we have the platform as a service. So instead of me talking about these from here, including the software as a service, let's go to Google and bring up a picture. It will help you look at this a little bit better. Infrastructure as a service versus platform versus software. So let's go to image and let me bring up one of these here. Let me find a really good one since I am here. All right, this is a pretty okay. I'm gonna spin that on the other side. There we go. And here we are. So let's talk about these from here. One thing that I should mention is when you are talking about the cloud, you start getting into things like responsibilities between the customer and the cloud provider. Basically, you want to know who is responsible for what. So, like I mentioned, infrastructure as a service or IaaS, this is where you are going to manage these things. And the provider, AWS, Google Cloud, Microsoft Azure, they're going to manage this right here. So let's talk about that from that perspective of who is responsible for what. So back to the infrastructure as a service, you can see that the cloud provider is going to manage the hardware, right? They're going to manage the infrastructure. They're going to provide that to me. And the infrastructure they're going to manage is the networking. We're talking about the physical infrastructure, the networking, making sure that the servers are there, the building has power, the storage, and the underlying virtualization. So basically, they're going to give me the virtualization environment that I can run everything on top of. So in the case of AWS, I'll go there and get, hey, I need the EC2 instance. Cool. The EC2 it's literally the virtualization environment allows me to access the EC2. Once I have that, off we go. Then the platform as a service, this is where I, as the customer, I manage this. Meaning I have my own application, I have my own data, and the provider, AWS, manages all this other stuff. Basically, they not only manage the infrastructure, but they're also managing the platform. Okay, they're going to manage the operating system, the input and output systems, right? The OS. They're going to manage the middleware. They're going to manage the runtime. All of this is their responsibility now. Okay, that's the platform as a service. This is where I go in and says, hey, I have my application, meaning I'm a developer. I can code my own application. I got my own data, but I'm not a system administrator. I don't know anything about Windows and Linux and deploying, servers and things like that. Can you handle that for me? I just want to be able to, add my application on top of your platform and then be good to go. And that's what this platform as a service will be. Then you have your software as a service. Software as a service, this is where they manage pretty much everything for me, the providers, right? Think about the Microsoft 365, right? It's a cloud-based application, right? Cloud-based, but do I care about the underlying infrastructure, or do I know how to manage the underlying infrastructure? And the answer is absolutely not. Do I care about the platform the 365 is housed on? The answer is no. I don't care if it's running on the Linux. I don't care if it's running on Windows because I'm not managing that. Now, am I the developer of the 365? No, I'm not. Microsoft is handling all of this stuff for me. So that becomes a software as a service. This is where I don't really all I do, I just pay them a little bit of money and then I start using the application. Okay. Now the application could also be free. For example, if we are talking about Gmail, it's managed by Google, right? We don't develop it. We don't know if it's running on Linux or Windows or the kind of database that Gmail is running on top of. We don't know the servers that this thing is running on top of. I will still use it. And I want to say for free, but there's really nothing for free. I usually tell people, if a product is free, you are the product. All right, so look at this from that perspective of who is managing what. Another as service that we have, it's the function as a service, or FAAS. This is also known as a serverless, which really doesn't mean you don't use the servers. Like everything runs on servers, right? Because I've had people in the past, they're like, whoa, what is serverless? Does that mean we don't use the servers? Not necessarily, right? But basically what this means is that you are running functions in the cloud, and then you don't want to deal with the servers. So you don't want to manage the servers. So what end up happening, let's say, imagine you're a developer. You have your own code. You're not a system administrator, right? You don't want to spin up servers and things, but you do have your own code. So what you can do, you can go to AWS and get something like AWS Lambda, that right there. And what this service is going to allow you to do is be able to do the serverless kind of a computing model. And the beauty of this is pay as you go, or pay for the only resources that you use. It's usually event driven. It's easy to scale because you can, it gives you that elasticity and scalability that comes with the cloud, because you can spin up things as, becoming popular and then shut them down automatically as well. It's all, event driven, using code. It's sometimes short-lived. Like I said, if we're becoming very popular, we can auto scale, right? Auto scale. And if we're not that popular, then we roll down. Some of the common use cases, including APIs, literally API. You can use this as a way of API, real-time file processing, Internet of Things, chatbots, and so on and so forth. Examples of this, including AWS Lambda, Microsoft Azure Functions, Google Cloud Functions, and then IBM functions and Cloudflare workers are all part or like examples of a function as a service. Remember, this is it's a family of a serverless where you're the developer, you don't have the infrastructure knowledge, the deployment of infrastructure knowledge. Therefore, you just want to have your application being run automatically without taking the responsibilities of managing the underlying infrastructure. As the business goes into the cloud and try to set up the services, they can ask for a public cloud. Yeah. So what is a public cloud? Well, this is again, you are renting computing services from AWS, from Oracle, from Alibaba, Microsoft Azure. But you're going in, you're saying, hey, look, I don't mind sharing the infrastructure with your other customers, literally. So it makes it cheaper. So for example, if AWS have a 10,000, let's say like 100 people, 100 customers, other businesses, and they have one servers, well, all of you 100 are sharing the same kind of resources of that one server. Okay, that's really what a public cloud is. You pay as you go, as with a lot of the things in the cloud, but usually multiple tenant are in the same server, meaning they're sharing the same hardware. Okay, that's a public cloud. It's shared between multiple customers of the cloud service provider. If you're a big company, you might say, you know what? I don't want that. I want a private cloud. I want something that belongs to me. So this is the cloud infrastructure that is dedicated to a single organization. I remember in America, for example, there's a company that's known as a Walmart. Walmart. It's like a food, like grocery store type of a store. Anyway, one of the biggest competition of Walmart is Amazon. Amazon. And when Walmart wanted to migrate into the cloud, guess what they did? Instead of going to the Amazon, because they know Amazon, it's their biggest competition. Although Amazon, like I mentioned earlier, started this whole cloud computing movement. So at some point they had like 80% of all the market share. Right now, I think they have gotten down to like 60, if not 40, around that number. But a few years ago, Amazon was the king of this type of stuff. So guess what? Walmart said, you know what? We're going to Microsoft because Microsoft does not compete with us. Okay. So Microsoft gave them the private cloud because Walmart is a huge organization that need a dedicated kind of a private cloud just for them. So this will be a little bit expensive because it's private. It's only dedicated to you, but it does come with a lot different benefits. Okay. One, like I said, it's dedicated to you, so it's faster, but it does offer some security. It does offer some segmentation, privacy. So it's better. It gives you more controls on how you can customize things. Basically, you can do a lot of the networking. A lot of the things we talked about in networks, you can do that if you have like a private cloud. So let's say you want to monitor things that are happening in your cloud using some kind of a SIEM, security, information, and event management. There we go, CIEM. Okay, so you can do exactly just that because now the entire thing is within your control. Okay, so what is the disadvantage of this? It will be expensive. It will be expensive, and then you have to hire people to maintain it. Meaning you have to hire those system administrators and those people who are who specialize in the cloud. If you are going to work in the cloud, if cloud computing is one of those things that you specialize in, here's my recommendation. Go with the Microsoft Azure first. Azure. The reason is a lot of the company, we're talking about very established companies, when they migrate into the cloud, they go with Microsoft because they're already using other Microsoft product. We're talking about like Windows operating system. It's on Microsoft. Office products like Office 365, PowerPoint, Excel, you name it, it's all Microsoft. So they all been migrating into the cloud and then just go with, yeah, you guessed it, with Microsoft Azure. So I recommend you specialize in that first. Pick one, and then later on, as you advance your career, you can then go on and go with something like Google or AWS, kind of become the go-to cloud personnel. But in the beginning, you want to specialize in one so that you can master that one first before you move on with the other ones. Another one we have is a hybrid cloud. Hybrid cloud, it's when you combine the two or more, really depends. Because a few years ago, they were also throwing a community cloud into the mix. as one of those things that you can go for. But a hybrid cloud is when you said, I need a private cloud, but I also need a public cloud. Now, the reasons could be for pricing purposes, right? Pricing, because private cloud are expensive and public is cheaper than private. Therefore, you might want to use both of them. But that might not be the only reason. It could be maybe for you want to test your development stuff in the public, but also put the production things in the private. That could be also your use case, right? But really, hybrid, it's when you're going in to the same cloud provider. You said, hey, give me a private, but also give me a public. I want to use the both. And finally, you have a multi-cloud. Multi-cloud, it's a trend that some of these organizations are using. This is where you are using services from multiple cloud providers. This is where you said, you know what? I just don't want to rely on AWS. I want to use AWS, but also use Google Cloud. Right? Use Google Cloud. And there's a lot of reasons, right? One is for segmentation purposes. Because if AWS ever goes down, you're okay. Actually, that have happened before, a few years ago. AWS went down, and it was as if the internet was down. Because all these services that we use, that we rely on day in and day out, including TikToks and Twitter and Snapchat, and most of these startups are in AWS. So they all went down, and a lot of people were like, oh my goodness, the internet is down. It was just AWS going down. So multi-cloud is the idea, kind of strategy of going in and then using a multiple cloud providers. Now you can always exchange things through APIs. This is the application programming interfaces that allows, kind of these two to sort of like communicate. Although they really don't like each other for the most part. But there are some, things that you can do to be able to pull data from one to another and vice versa.